in Tirupati, we want to see it.
I can join you online. At that
Yeah,
time.
sure, sir. Thank you, sir. It's yeah. And I will send a mail, sir, about regarding your message to incorporate in the souvenir. So I will take. Yeah. Already 2 years back, which you have given that message, but that time is only Professor C.R. Rao 100 years birth centenary. But now this time our department celebrating Diamond Jubilee celebrations.
Anyhow, I wish you best of luck and
Thank you, sir. With all your wishes. So with
Yeah.
all your kind wishes only that we are doing good things in Tirupati. I feel always you are the one of the strong pillar to motivate me to do something. Yeah, so really.
I still, I'm active. I still keep my work. So I
Yes, sir.
keep
Yes,
on
sir.
doing my work.
Yeah, yeah. First time, I think through my students, I heard about you, my Venkateswaran and
yeah, they came to my classes.
Then I have decided to see you because while gone through your CV, it is you did the MSc in 59, sir.
Yeah,
My
59.
my brother did the MSc in 59 to 61 in Madras Presidency.
I did it in 57, 59.
Yeah.
Yeah.
So my brother Ratna Sabhapati, both were classmates in yes, yeah, Madras Presidency College that time.
So are you going to USA soon or coming back?
No, sir, my daughter, she is expecting, first daughter, she is expecting in June, sir, June, sometime 24th something. And they will be here 3 weeks. And likely my second daughter may visit next year. So this year, I may not go to anywhere. So, because of this Diamond Jubilee celebrations, so there is I have to contact nearly 1,800 students, more than 2,000 students to contact.
All the alumni, all the previous students you are contacting?
Yes, sir. All the students, because now there is I initiated one small office in the department, so which we are contacting all the old previous alumni in the abroad and all the students. And we initiated one Statistics Alumni Association also, sir. It is now we are good. In every year September we are doing some type of programs in the department, like features, like National Statistics Day, like CRO birthday with some workshops.
Some music or something is interfering?
Yes, sir.
Good morning, Professor Reddy. Good morning, Professor Mathai.
Good morning, sir. Somesh Kumar, sir.
Good morning. Good morning.
Nice to see Professor Mathai.
Some music is disturbing there. Thank you.
Is it so? But there is nothing else is on.
There is some music or something, some disturbance is coming from the office there.
Is it still there?
No, now it is not there.
Now it is coming.
Yeah, no.
Sir, good morning.
Good morning, Professor Thangraj.
Sir, we'll start the session at 9:30 sharp.
Who is going to chair this session?
Yeah. Dr. Reddy.
Professor Reddy, you are muted actually.
Good morning, sir. Sir, unmute.
Professor
Yeah, good morning.
Thangraj is speaking from London, I think.
London. Okay. Very nice. Yeah, very nice to see you from London, sir. but every day I'm getting your WhatsApp message. Then I thought, okay.
Good morning, Professor Balakrishna.
Yeah, good morning, Professor Somesh.
Balakrishna, this talk, I will chair the session for this Matai sir talk, because Ravi, it seems, is not, maybe busy with some other work. So
Oh,
he's
that means you will manage the session?
Yeah, I will manage the session.
Oh, very good. Okay, good. In fact, I was trying to find out. Yeah, that is very good. Okay, please go ahead, sir.
Yesterday she called me. Yesterday,
Yeah.
Jayashree told me. Then I said, okay, Matai sir, I will take care, no problem. I will be here.
Okay. That's good.
Good morning, sir. Professor Prakash Rao.
Oh.
You are muted, sir.
Good morning.
Yeah.
Good morning. Good morning.
Good morning to everybody.
Good morning, everybody. I think
Good morning,
Professor
sir.
Velleswamy is also
Good
present.
morning,
Why
Professor
can't-
Matai.
Good morning.
Oh, yeah. I can see his name. Professor
Yeah, please,
Velleswamy, are you there?
please open up your camera, Professor Velleswamy.
Oh, sorry. Sorry, I changed my name. Okay.
Prakash Rao, sir, just I wanted to tell you, actually, yesterday I had a talk with Professor Divakar Sharma. He had a angioplasty on Wednesday.
Oh, I see.
Yeah, I wanted to just inform you.
Professor Reddy, I think we may start now.
Yeah, I think, yeah.
It is almost it's 9:30.
Okay. Yeah, I will start. Okay. Shall I start?
Yes, sure.
Yes, go ahead.
I think Matai sir is ready.
Yeah, Matai sir is ready. Yeah. Good morning to everybody. It's my immense pleasure to say a few words and to introduce Professor A.M. Matai. Professor A.M. Matai is the Emeritus Professor of Mathematics and Statistics, McGill University, Canada. And he is an Indian mathematician who has worked in statistics, applied analysis, application of special functions, and astrophysics. And he got his MSc statistics first class and first rank and gold medal in the year 1959.
I don't see him.
University of Kerala, and he has published more than 25 books with highly reputed publishers, more than 300 research publications. And Professor Mathai sir was the former president of Indian Mathematical Society, former chairman of the Kerala Statistical Commission, member of Lok Kerala Sabha, president of the Society for Special Functions and their applications. And in 1998, he received the Founder Recognition Award from the Statistical Society of Canada. He is a fellow of the National Academy of Sciences, India, and a fellow of the Institute of Mathematical Statistics. He has also received the fellow of Indian Society for Probability and Statistics, and he was the recipient of first Professor C.R. Rao Lifetime Achievement Award from ISPS. So I am very happy, sir, to introduce you, sir. There are only, we can say that Professor Mathai, sir, among few, he has contributed so much for the nation development in statistics in India. So I am very happy to introduce you, sir. Sir, yeah, please, sir. Go ahead.
Thank you. Thank you very much.
Thank you. Sir is going to speak on Eigenvalue problem in the real and complex domains, sir. So now I request you, sir.
Eigenvalue problem. Okay. Thank you.
Post to disable the participants screen share. Signed an active account share.
Yeah.
Signed up PPT sharing.
I cannot enter into mine. This is
Yeah,
it says
please,
post to
please grant permission to share, please. I'm asking the people in Hyderabad.
It's already these things are already kept. You can
Yeah.
share.
Okay.
Permission is already given, sir.
Okay.
On bottom of the screen, you'll see share screen, sir. Mataya, sir. Share screen.
Sir,
and
please
you
see
select
that
the
upward
PPT.
arrow mark with the green color. Please click that.
yes.
Yeah. Then there something is coming there, right? Like screen. Then click that screen and then full screen.
Screen coming, it says host disabled participants screen sharing.
Oh.
My screen is not coming.
Sir, check once again.
Maybe-
Close the window and then check once again. Close that window, sharing window, and then open it again.
No.
Yeah, we can see
Yeah.
your screen, sir.
Yeah, now the screen is coming, sir.
Yeah.
Now it's coming.
Yes,
Okay.
sir. Yes, sir. Now
it's coming, sir. My screen is already.
yeah, now
Can you
you
hear?
okay.
Can you hear me?
Yes,
Yeah,
sir.
yeah,
Yes,
yeah. You can hear you as well as you can see the screen also.
yeah, now screen also.
Sir, we can hear you as well as your screen is also visible, sir.
Okay. So I'm going to talk about eigenvalue problems in the real and complex domain. In the early 1960s and 70s, there were a lot of activities on this particular problem. That is a distributions of either largest eigenvalue or the smallest eigenvalue of gamma distributed or matrix varied gamma distributed or matrix varied type 1 beta distributed or matrix varied type 2 beta distributed cases. So I have looked into that problem, and I find that all the representations available are very complicated type of representations are there in the literature. So I found that it's very simple and one can give explicit solutions, explicit forms where everybody can compute. And I'm going to give something about those lines for all the three cases. That is general matrix variate gamma eigenvalue problem. That is distribution of smallest eigenvalue or largest eigenvalue, or joint distributions of a number of eigenvalues, whatever you want, as well as distributions of eigenvalues of matrix variate type 1 beta distributed case and type 2 beta distributed cases. Now, these eigenvalues are actually used when we talk about the central Wishart distribution or eigenvalue problems in tester hypothesis in multivariate statistical analysis, or eigenvalue problems also come in analysis of variance and related areas. So I have also given the corresponding distributions in the complex domain, because it is not very difficult to extend the theory for the real variables to the complex domain. So now, in multivariate analysis in general, usually the subject matter becomes complicated because of too many symbols appearing and too many subscripts, superscripts, and all that you needed to represent the various items. So I have found a way of simplifying all those things. I treat mathematical variables and random variables alike. No double notation is used for random variables. All the variables, scalar variables, will be denoted by small letters, and vector matrix variables will be denoted by capital letters. So, and variables in the complex domain will be denoted by with a tilde like this, scalar variables as well as matrix variables. Therefore, in that way, the notational problem is simplified. Now, I need some ideas about any of the determinant will be denoted like this or like that. In the complex case, absolute value of the determinant or modulus of the determinant will be denoted like this. Then the standard notations like Wedge product or differentials, that is the standard notation. I use dx. And if it's a symmetric matrix, then a real symmetric matrix, then dx will be like that. And in the complex case, it's a complex matrix random variable. The complex case, the wedge product here will be defined as wedge product in the real part and the wedge product in the complex part. And integrals of this type means fx tilde is a real valued scalar function of with matrix argument x. Whether x is real or complex, f is real valued, only integrals of that type will be used, considered here. For a density, of course, we need a real valued function, scalar function, so that it is non-negative and total integral is 1, whether x is real or in the complex domain. Now, a star will be used like this for Hermitian matrices. This means that x is Hermitian. And for positive definiteness, I use a standard notation, that is this type of a notation. This means the matrix A is positive definite. This quadratic form is positive definite. Other notations will be standard ones. Now, there will be a book of around 1,000 pages coming soon. It's multivariate analysis in the real and complex domain, and authored by me and my co-authors. and it should appear between April and June of 2022. And an enlarged version of this paper is available there with examples and illustrations. And I have already sent the paper to the organizers. Those who would like to get copies, you can get the copies from the organizers. The slides are also fully sent there, and you can get those things. Now, here is our matrix variate gamma distribution, gamma density. So I denoted it by F1. These are the conditions. In statistical problems, the parameters are usually real, but all the theory will go through for complex parameters also. And hence I am giving the conditions for the complex parameters. When it is real, remove R and say alpha greater than P minus 1/2. Gamma P alpha, that is, I call it, it is known by different names in the literature. I call it the real matrix variate gamma because it is associated with a matrix variate gamma integral of this type. Therefore, I call it a matrix variate gamma. This is the real case, and its expression will be like this, and that we can easily derive. It's a standard result. In the complex case, the matrix variate the gamma distribution with scale shape parameter alpha and scale parameter matrix B, positive definite B, is of this type. This is the absolute value determinant. This is absolute value determinant. Those slight changes are there. This is, I call it complex matrix variate gamma because it is associated with a complex gamma integral of this type. Now, this is type 1 beta, the standard type 1 beta, real matrix variant type 1 beta. It is of this form, determinant of x raised to alpha minus this one, determinant of I minus x, the range is support is like that. And the complex domain, the corresponding type 1 beta densities of this form. Slight changes are there. These are the corresponding matrix variant gammas. And here absolute values are there. Here also absolute values are there. Otherwise, it is very parallel to the real case. And real type 2 beta, the function will be of this form. This is the ordinary determinant. This is determinant of I plus x. And these are the real matrix variant gammas. And the corresponding case for the complex, this is type 2 beta distribution in the complex domain. Similar to this, instead of determinant here, I have the absolute value determinant. And in the exponent, there is slight change here. And here also, here the exponent is the same in the real case as well as it is absolute value determinant. Those are the slight changes so that one can look into the parallel results. Now, what I will do, I will need is when you have a real positive definite or Hermitian positive definite P by P matrix, I would like to convert that into the eigenvalues. So the conversion formula is the following. That is, this is in the real case. U is my real positive definite matrix. Here, U is Hermitian positive definite matrix in the complex domain. So when you convert it, this is the Wedge product of the lambdas. Lambdas are the eigenvalues of U, and this part will be coming. That is coming from integrating out the differential elements of the orthonormal matrix. Here, this is the corresponding differential integral of the differential element corresponding to the unitary matrix. And the difference between the two is, here I have this type of a factor, pi I less than j lambda I minus lambda j. And here it is in the complex case, it will be the square of this. And this part is also slightly different. Otherwise, they are very similar. Now, once you convert from a type, say, for example, if you look into the matrix variate gamma distribution density, I had already given the density. The corresponding density, joint density of the eigenvalues will be like this. This part will be there coming from your determinant of e raised to something. This part is coming from the e raised to trace something. And this part is coming from that differential element. And in the complex domain, for the matrix variate type, the matrix variate gamma in the complex domain, the joint distribution of the eigenvalues will be like this. This is the structure of it, and this part is slightly different from this. Now, similarly for the type 1 beta, type 2 beta, I have given the various. This is the real case, this is the complex case, this is the real type 2, this is complex. That is the joint distribution of the eigenvalues coming from those densities. Coefficients are given here. Now, when you look into the structure of it, any of those, if you take, for example, here, type 1 beta, the complicated part is this. Otherwise, this part is not a problematic part, because when you are integrating and all that, this part is not problematic, but this part is. So therefore, the success of the method is in rewriting this part here. So I have rewritten, because you know that this can be written as a Vandermon's determinant. That is a standard result. So here, it's available in many books, or if you want to look into my book, it is already there. This is that factor here. And that factor is this Vandermonde determinant, this part here. Now, the ijth element here will be lambda j raised to p minus j. Now, this determinant can be expanded in different ways. If you say, for example, expand it in terms of the first row and the cofactors, one advantage is the coefficients will be only functions of lambda 1, and the cofactors will be free of lambda 1. But on the surface, it may look like that is an ideal type of expansion for looking into the distribution problem. But I found that the cofactors are not symmetric with respect to the lambdas, and therefore that is not the form that I am going to use. So I will use the general expansion. General expansion of a determinant will be of this form. That means the terms are of this type, where one and only one element comes from each row and each column. So therefore, this part, if I write in terms of that Vandermonde determinant, then I have this particular format. So you can see that here I have lambda j raised to p minus kj. That is the format coming there. Now, of course, this part is coming from the number of transpositions needed to bring the second set of subscripts k1, k2 to kp into the natural order 1, 2 to p. So if the number of transpositions needed is odd, then the corresponding coefficient will be -1. And if the number of transpositions is even, then the corresponding factor is +1. And I have given some examples here. Some simple examples. In the complex case, the problem is slightly more complicated, because you have this part squared, 2 times it is coming. So it is equivalent to the real determinant squared. Real determinant square, I can also write it as a prime. Actually here a prime is a itself, No, here it's A prime is different. So here I can write it as A prime, but the determinant of course will be equal to determinant of A prime A. So I'm going to use this for this representation here. Now A prime will be of this format. So you can see that now my lambda, say lambda 1 is only in the first column, lambda j is only in the jth column. So a matrix of the form, some matrix times its transpose, and that I can always write it in the form like this. Here Bj will be this times its transpose. So this I can write it as B1 to Bj, the columns. And when you take A prime A, then I can write a format like this: B1, B1 prime, etc., BP, BP prime. Note that in my Bj, only lambda j is coming. So I have the advantage that here only lambda 1 will be coming, here only lambda p will be coming. So therefore, B1, B1 prime, here it will be of this form. So I have simplified the exponent. So finally, I can rewrite in terms of in this format, and I will come to the actual form. So these are the individual elements there. And if I convert that in terms of lambdas, I will get a form like this, where these are already predetermined. The exponents R1 to Rp are already predetermined. So my determinant is of this form now, that which I can handle. Now, say for example, if I look into the gamma density, then this is the joint density of the eigenvalues, and this is the part containing that Van der Waals determinant. That part is now converted into this. So the whole thing becomes a sum of lambda 1 raised to m1, lambda 2 p raised to mp, where mj is this explicit form, where everything is recognized. So now it's only a matter of integrating out this, and I can consider two cases where one case is mj is a positive integer, and the other case is mj general. But in the complex domain, you will see that the general case as well as the particular case are one and the same. Or in other words, in the complex case, one has the advantage that my mj will always be a positive integer, because in the complex case, mj will be of this form, and this will always be a positive integer, provided this part is a positive integer. But in the Wishart distribution, in the complex domain, this is always a positive integer. It is m, the degrees of freedom. In the real case, it is m by 2. So in the Wishart case, all these things will become very simple. When they are not positive integers, in the Wishart case, they are half integers. I have considered the general matrix variant gamma distribution with a general parameter alpha. So my distributions are derived for general parameter alpha. But in the case of statistical applications, here alpha will be either m by 2 or m. When it is m, it will be a positive integer in the complex case. Otherwise, it will be a half integer. So in the Wishart case, you have either a positive integer or a half integer. Those are the only thing coming. So now I continue with, I have given a connection of my alpha here. When alpha is m by 2, we have the Wishart in the real case, and b should be 1 by 2 sigma minus 1. I have a general b. So these are the particular cases of Wishart. These are some of the old-time work. Quite a lot of number of papers are there, but in all these papers, you will see that the exact distributions are either represented in terms of multiple series involving incomplete gamma functions or incomplete beta functions or things like that, or Pfaffians of skew symmetric matrices, determinants. So those are determinants. So either representations in terms of determinants or representations in terms of multiple series or multiple series involving either incomplete gamma functions or incomplete beta functions. So even the recent papers, you still have those type of representation. These are all the old type papers. I have given a recent one. Here there is one 2014 paper and there is another one 2021 paper. In all these, the representations are still complicated. Come into the structure of it. First, let us take the case alpha plus t minus b2 being a positive integer, so that these mj's will be positive integers in the real case. I am considering matrix variant gamma case first. In the matrix variant gamma case, you will see that if you are looking at the eigenvalues, the smallest eigenvalue I denoted by lambda p, largest eigenvalue lambda 1. So we will integrate out lambda 1 lambda p minus 1 to get the density of lambda p. Similarly, to get the density of lambda 1, we will integrate out lambda p all the way to lambda 2. Now, if you want to get a joint density of a few of them in the beginning, then you integrate out from lambda p up to there. And if you want a joint density of a few in the end, you integrate lambda 1 to lambda j. You can do that. But if you want a few of them in the middle, you can integrate from both ends so that you will get a joint density in the middle. So lambda j for a particular j, if you want to get the density, my procedure is integrate from lambda 1 to lambda j minus 1, lambda j plus 1 all the way to lambda p. And both the techniques are given here. Now, when it is an integer, it is simply an integration by parts. So this will be the form. I integrate lambda 1. Lambda 1 will go from lambda 2 to infinity. So I get this form. Now, I continue the integration. Then you will get, this is the final form. Note that this is programmable and you can compute it explicitly also. These are finite sums of explicit expressions for the density. I'm considering the density of the smallest eigenvalue. So for a general integration, I integrate up to lambda j minus 1, I will get a form like this, explicit form. Now, I give the general density of the smallest eigenvalue lambda p. So that is simple as this. The explicit form is this. Now, we come to the constant part is sitting there. That's already explicitly available. Now, in the corresponding complex domain, my mj is like this. Now, the corresponding expression will be like this. This is the explicit expression. As I mentioned earlier, in the statistical application case, in the Wishart distribution in the complex domain, this will be m, so that it is positive integer itself. That is the general case as well as the particular case coincide in the case of complex domain. So the whole thing is, this is the final expression in the complex domain. So I have mentioned it here. Now, integration. Now, if you are looking at the density of the largest eigenvalue lambda 1, we will start integrating out from lambda p onwards. So lambda p, when we integrate, so it is something of this form is coming. Okay. Now, that is a incomplete gamma integral is coming. So in that incomplete gamma integral, I can also write it like this. So it is this form. Now, that form, when you multiply, now multiply each term and integrate. Okay, so you have this. This is the step 2 integral. Step 2 integral means second integral, that is lambda p and lambda p minus 1 are integrated out. So you will get something of this form. Even though there are lots of terms there, all the quantities are finite sums, and therefore they are explicitly available and explicitly integrated. Now, for the general case, I have seen that I can create a pattern by looking at representations like this. So for example, for the step 4, this is the step 1. Step 1, I consider two column, either 0 as one column filled with zeros and ones. All are filled with zeros and ones. So here in step 2 integral, I have these possibilities. These are the corresponding term also. I have only these terms. 4 terms will be there. And the terms I have denoted by this structure, 0, 0, 0, 1, 1, 0, 1, 1. Looking at the number of ones in each structure, this number of ones is odd, then the corresponding sign will be negative. If the number of ones is even, then the corresponding sign will be positive for the corresponding term. So this is the pattern. So by looking at this pattern, I can just write down all the elements explicitly. That means these are all the elements available. These many elements are there. This is one element. And this is another element. This is another element. Like that, these many elements are there. And all elements along with their signs can explicitly be written down by looking at these patterns. Now, here is how the terms can be evaluated. So if the first entry in a sequence is 0, then the corresponding factor will be this, empty factorial, like that. If the first entry is a 1 and the corresponding is this, if that is the last entry, then the multiplicative factor is there. Otherwise, it is this. Now, 4 situations. All these 4 situations will cover all possible cases. And therefore, I have now the explicit evaluation of 6 cases, 6 situations. I have the explicit evaluation of all the terms available. Now, for example, by looking at the pattern, if you are looking at a step 3 integral, step 3 integral, the pattern will be like this. These many terms are there. 1, 2, 3, 4, 4 here, 1, 2, 3, 4 here. Okay. By looking at those and by using the rule, I write it down. So these are the actual terms. Or you can also obtain it, verify it by look at the step 2 integral and multiply it by the corresponding lambdas and integrate out. Lambda raised to m2 and m3 and e raised to minus lambda. And so and integrate out. You will get this. And here is the general case. So P3. So the general case will be like this. So BP lambda minus Q, P minus Q is here. This is the case. The jth step I denote it by Bj of lambda P minus J. Then the density for the largest eigenvalue is this form. This is the constant part coming, this part, and this is the general jth one multiplied by lambda raised to m e raised to minus lambda 1 d lambda 1. This is the last one. This is the explicit form of the exact density of lambda 1 in lambda 1 is the largest eigenvalue. So I have given the exact density of the largest eigenvalue as well as the exact density of the smallest eigenvalue in the case of real matrix variate gamma. Now, the general case or the corresponding complex situation is this. In the complex domain, constant part will be this, and the Vp minus lambda is exactly the same as before, and this is also the same. So only this part will be different, and the Mj will be different. Structure of Vp minus 1 lambda 1 is the same, but Mj is different for real as well as complex case. In the complex case, Mj is like this, and the real case I mentioned earlier. So that's the only part which is different. Otherwise, the structure remains the same in terms of Mj. I have given explanations of how to get joint densities as well as the density of a particular lambda j here for a particular j. Integrate out, I can get joint densities of many. And here, general case, if Mj is not a positive integer and in a matrix variate gamma case, and if it is not a positive integer, I take general alpha. As I mentioned earlier, if you are considering the Wishart distribution, then this alpha is m by 2. So in the general case, if this whole thing is, that is this part, if this part is not a positive integer, then it will be a half integer in the Wishart case. In the general matrix variate gamma, alpha is general. Alpha is simply bigger than p minus 1 by 2. That's only condition. P is the order of the matrix. Here, alpha is greater than p minus 1 by 2. So when it's a half integer, we can also handle it much better. But here I have given it for the general case. Whatever be your alpha. General case, it will be like this. It is an infinite series in the general case. In the general case, at the jth stage, the integral will be like this, and this is the form. The only difference is here in this case is a infinite series, but not a product of infinite series, but sums of infinite series. So that is one advantage with other representations available in the literature. Here it is sums of infinite series in the general case. As I mentioned earlier, if it's a Wishart case, then it is a simple to handle. It's a half integer. In most of the cases, you can, by using duplication formula for gamma functions, you can combine them. And if p is even, then all can be converted back into the integer case. And if p is odd, then it will be something like, and I don't want to go in those details. I can handle those things also. Here is the general representation. Here is the general density for the largest eigenvalue in general case. When Mj is not a positive integer, it will be like this. And this I have already given. The jth stage at this p minus 1 lambda j is already there. Here, it's already given there. And this is the last one. And the corresponding complex case, the expression will be, this will be different. This expression is the same. This form is the same, but Mj will be different. Mj is this. As I mentioned earlier, in the Wishart case, there is no such thing as a non-integer case. This is still an integer case. In the Wishart case, in the complex domain, this will be the degrees of freedom, m. In the case, it is m by 2. But in the complex case, it is, this whole thing is a positive integer. So therefore, in the Wishart case, the explicit form given earlier for the integer case is the final case. Here, when alpha is general, you have this form here. Again, it is can be handled easily. Patterns given and details. Illustration for the case of 3. This is the density for the smallest eigenvalue, real case. Density for the smallest eigenvalue, complex case. Now, when I come to type 1 beta and type 2 beta, type 1 beta and type 2 beta is actually all the results are available from type 1 beta. So for type 1 beta, I have also given explicitly I have in the area for explicit forms in the for the type 1 beta as well as type 2 beta. They are available. I think most probably they are in the paper that I sent, or if it is not there, it is there in the forthcoming book on multivariate statistical analysis in the real and complex domain, which should be out soon between April and June of 2022. So there you have a detailed description along with examples and exercises. Explicit forms as well as examples are given there. Included the type 1 beta and type 2 beta case in the current presentation. For the type 1 beta and type 2, I haven't included in this particular talk, but they are available. Explicit forms are available. For type 2 also, I have explicitly given from first principles as well as derived from type 1 beta. So both the type of procedures are shown there, so that if someone already has type 1 beta representations and would like to get type 2 beta from there, that is available, and vice versa. If somebody has the type 2 beta representation or worked out in detail and would like to get the type 1 beta from there instead of going through the same steps, you can get from one can get explicit forms of type 1 from type 2 as well as type 2 from type 1. In the book, I have given both general independent derivations as well as I have shown how to get one from the other. So those are already there. So that will completely cover what I call the pathway family of distributions. The pathway family that I defined consists of the gamma family, the type 1 beta family, type 2 beta family. Gamma family also contains our Gaussian also. Gaussian model also comes into that gamma family. It's a particular case. So all those are connected through a pathway parameter, and all these families are we can reach one. All the families can be reached from either from one of those forms, type 1 beta form, and we can get to type 2 as well as the gamma forms. Similarly, gamma form, if you have it, from there you can go into type 1 and type 2 beta forms through a pathway principle through pathway parameter. So I have completely covered the real and complex matrix variate gamma family of distributions, type 1 family of distributions, type 2 family of distributions, and the explicit evaluations of the distributions of eigenvalues connected with all these matrix variate random variables. Eigenvalue problems, the smallest distribution of the smallest eigenvalue, largest eigenvalue, or the jth largest eigenvalue, or joint distributions of some of the eigenvalues. Okay. Thank you very much.
Thank you, sir. Any questions from the audience?
I just wanted to ask, actually, like the procedures for the multivariate normal were developed earlier. This kind of result. So the difference, or you can say the points where the results are somewhat different, are the technique part basically, as we have seen here.
I have looked into the literature. I could not find explicit forms, the ones I have given, explicit forms like that. Eigenvalues, distributions of eigenvalues, either in the gamma case or in the type 1 beta or type 2 beta case. That's why I worked out those in detail. Okay. For the, you are talking about what? In the Gaussian case, what?
Yes.
This type of form is available. That's a particular, when you look at the gamma, the parameter alpha, when it is alpha equal to p plus 1 by 2 in the real case, you have the exponential form. So in a particular case, exponential density will come. There the question of alpha does not appear. Alpha is the one creating problems whether you have an integer case or a non-integer case. So when alpha is not there, it is an integer case, it's a symbol. So that means a very particular case of this, whatever I have worked out. Because the exponential form is actually coming from a from a gamma distribution with alpha equal to p plus 1 by 2 in the real case and alpha equal to p in the complex case. So then the density will become the exponential density. The exponential density can also be the Gaussian type density, depending upon, because we are taking the exponent as a positive definite trace of a positive definite matrix or a Hermitian positive definite matrix. So exponential form as well as the Gaussian form, they are all covered. And in fact, they can also be extended to the rectangular matrix variant case.
Thank you, Professor.
Thank you, Somesh Kumar. Any questions?
Yes, sir.
Any questions? If no questions, then thank you, sir. Thank you for your nice presentation, and it will be very useful for the youngsters. So thank you once again for participating and giving your talk, sir. So thank you very much.
Yeah, it was a pleasure. As I mentioned earlier, the full paper and the full slides are there. Anybody can use them. It is up to you. And I send the whole thing to the organization. So the students can get hold of those. And once the book is published, and it is available also in the book. In detail. Okay. Okay. Thank you very much.
Thank you.
I take this privilege to thank the speaker as well as the chair, and I take a special privilege to thank our chair, Professor Rajshekar Reddy sir, former professor of statistics in the Sri Venkateswara University, Tirupati, and sir also held the positions, as all of us know, as head department of statistics, as vice principal of Sri Venkateswara College, and as former coordinator for MSc Statistics and Computer Applications, and former registrar of Dravidian University, Kuppam. And sir also was elected president of ISPS and elected president of Operations Research Society of India. And vice president.
Oh, okay, thank you.
Thank you very much, sir, for readily accepting our invitation. Thank you, Matai sir. Thank you, everyone. Thank you.
Okay. Thank you, everybody. Thanks, everybody.
Lokanathan, good morning.
Good morning, Lokanathan sir.
Yeah.
Good morning. Good morning.
Okay. Now switch you over to all the halls, no? Okay.
Yes, sir. Now there will be 4 parallel sessions.
Good morning, Professor. Good morning.
Good morning, sir.
Good morning.
Hey, Ilangavan.
Yeah, good morning, Professor Reddy garu.
Namaskar.
Namaskar.
Namaskar to Annamala University.
Good morning
Yeah.
to all professors who
Yeah,
have
yeah.
joined.
Good morning, Jayashree. Good morning, Professor
Good
Jayashree.
morning,
Yeah,
sir.
good morning.
Good morning, sir.
Next we have
Now, I take the privilege to introduce our chair of this session, Professor Loganathan, sir. Sir is a professor of statistics in Manonmaniyam, Sundarnar University, Tirunelveli, and sir has over 27 years of teaching
Madam, இப்படி
experience.
வரட்டுற.
Sir has guided 8 students for their PhD program, and 3 are in progress. 2 theses were submitted, 8 are awarded, and number of candidates who have worked under sir for MPhil program are 17, who got their award also. And sir's area of specialization is Bayesian inference in finite mixture distributions, and sir's fields of research interests are finite mixture distributions, acceptance sampling plans, live testing and reliability theory, cluster analysis, and number of publications are 57 in various national and international papers, journals, and a number of research papers communicated for publication in the recent is 1. Number of papers presented in conferences is 110, and number of books.
Your voice is breaking, madam. Your voice is breaking.
Madam, it is already 10:30.
Edited are 8 and not completed are number. Sir, can you hear me? And completed are number, sir.
There was.
Yes, sir. Can you hear me now, sir?
Yes, we hear, but madam, it is already 10:30 now.
Yes, sir. Just for honors conferred to sir were Young Scientist Award by Tamil Nadu State Council for Science and Technology, and sir delivered Professor Rajgopalan Endowment Lectures, appointed as University Representative to Bishop Calvert College, and sir is a life member of Indian Bayesian Society, and also life member in Calcutta Statistical Association, and life member in Indian Society for Probability and Statistics. Thank you, sir, for readily accepting our invitation, and we are proud that you are here, sir. Thank you, sir.
Thank you, Dr. Jayashree, for your good words. Of course, you have got these details of, I do not know, from the past, the older CV. I gave you a very short profile for your reference. I think you did not receive it. Anyway, thank you for inviting me to chat this session. Let me first of all thank Professor Satish Kumar for his first invitation to this conference and inviting me to submit my abstract. Good morning, Professor Thangaraj, sir. And good morning, Dr. Sandhamarakannan and our speaker, Professor Elangovan. Good morning to all. Madam, how much time we can take for this session? Because we should have started by 10:20. Now it is 10:30. Can we go 10 minutes?
Yes, sir, maybe around 25 minutes, 20 to 25 minutes.
Okay. Professor Elangovan, please make a note of this time point. And it is, I have the pleasure of introducing our speaker of this session, Professor S.R. Elangovan. He is the professor of Department of Statistics of Annamalai University. He has put more than 30 years of teaching and research experience, and he did all his graduation, post-graduation, MPhil and PhD programs, everything in his home institution, Annamalai University itself. And he has guided so far 16 candidates for the award of PhD degrees. There are 6 more candidates there under his guidance, and he has guided 43 students, including the postgraduate students, for their dissertations. His area of specialization includes stochastic process in its applications, survival analysis, biostatistics, and reliability theory. It continues. Of course, he has a lot of interest in different topics of statistics, and he has published more than 80 papers in reputed journals of national as well as international repute. We understand that he was awarded financial support by the government of India for visiting foreign countries to deliver lectures for teaching programs. There are a lot many things to tell about Professor Elangovan. Of course, due to shortage of time, let me cut with this and let me invite Professor Elangovan to make his presentation. Professor Elangovan.
Yes, sir. Yes, sir. Thank you very much, Professor Loganathan, for your nice words. I thank the organizing committee member given an opportunity to deliver my talk. Now I start sharing my slides, sir, with the permission of the chair. Is it visible, sir? The slide is visible?
Yes, sir. It is visible.
Okay. Mic cut pannida. Yes. Okay. So my topic is accelerated failure time model using frailty in survival analysis. So AFT model, a lot of work is already published in the recent past. Now there are two different things going to be done here. One is called the AFT model. There are two. One is with the frailty and without frailty. So some numerical examples also delivered. Okay. This is the outline of my work: abstract, introduction, material and methods, proportional hazard model, partial likelihood method, accelerated failure time model, parameter estimation, fitting of proportional hazard model and AFT model, and conclusion and references. Okay. So in cancer studies, the main outcome of interest is the time to occurrence of the event, like death, response, relapse, or toxicity, etc. In clinical trials, survival analysis implicitly assume a homogeneous population to be studied. That is, all individuals are in principle subject under the same risk. The accelerated failure time model without frailty is an attractive alternative to the popular Cox proportional hazard regression model. The accelerated failure time model is a linear regression model in which response variable is the logarithm or a known monotone transformation of a failure time. AFT model with the frailty is the deviation from the proportional hazard may sometimes be explained by unaccounted random in heterogeneity or frailty. In this paper, in this talk, it is proposed to discuss accelerated failure time model using frailty in survival analysis. Numerical examples are also provided with the real life data set in survival analysis. So this is the introduction. Many practical problems related to survival data. Proportional hazard model is widely known as the most used multivariate survival analysis to investigate the effect of several covariates on survival time. The proportional hazard model is a semi-parametric, which means that baseline hazard is left unspecified and there is no assumption about the statistical distribution of the survival time. You can refer this paper. Another model which also uses a pH assumption is the parametric proportional hazard model. This model modifies the proportional hazard model by assuming that baseline hazard function follows one of the statistical distribution. You just refer to Lee and Wang 2003. On the other hand, the AFT model is one of the parametric survival model that can be used as an alternative to the pH model, especially to overcome statistical problem due to the violation of pH assumption B 1992. You please refer. Then AFT model accounts the effect of the covariates directly on survival time instead of the hazard rate as in the pH model. Moreover, the interpretation of the results in AFT model is easier than the result of pH model because the parameters indicate the effect of explanatory variable on the mean survival time. The AFT model have been widely studied by many authors. So you can, according to K and Kinsley 2002 also. Then the comparison of AFT and pH model for several numbers of censored observation and the sample size was conducted through a simulation study for 2002. However, in many real-life applications, it is also common that researchers have to analyze a large data set, such as in demographic and public health studies. Okay, so material methods. The data used in this research were obtained from 2021 NFHS 5, which is conducted by Statistics India and United States Agency for International Development from January 2000 until April 2021. In order to collect data in all provinces of India, they used to stratify two stages clustering sampling technique, where the cluster blocks and the household were the first and the second stage unit sampling, respectively. The cluster blocks were based on the Indian population census that was held in 2011. The response were asked to answer the questions in the questionnaire. Not all the respondents filled the questionnaire completely, therefore only the complete questionnaires were included. The pH model, the Weibull AFT model, exponential AFT model, gamma AFT model, and log normal AFT model were fitted to the data set. After the performance of each model was evaluated by using AIC values, finally, the gamma AFT model was chosen as the best fitted model. So the gamma AFT and several distributions like log normal and other distributions studied by extensively by many authors, especially Professor Balakrishnan did lot of work in this gamma frailty. So we are using the same gamma frailty for our data set just for this. The proportional, this is a proportional hazard model. As the young researchers, those who are doing to start with the work in pH model, this is the simplest proportional hazard model explanation. Proportional hazard model is a semi-parametric regression model, which can be used to measure the effects of covariates on the survival time. This model is represented by the relationship of the hazard function, the baseline hazard function, and one or more covariates in the form h of t is equal to h naught of t and e to the power beta dash beta tx. Okay, where t is a survival time, h of t is a hazard function, h naught of t is the baseline hazard function, which is left unspecified. Beta is a column vector of the regression coefficient, and x is a column vector of the covariates. The Cox regression model assumes that there is proportionality of the hazard rate between any two individuals in the population. The hazard ratio is defined as the ratio of the hazard function for two subjects with the different values of the covariate x1 and x2. Okay. The formula for hazard ratio is given by h naught of t e to the power of beta 2 x2 divided by h naught of t e to the beta 1 x1, which is equivalently presented as the subsequent expression, and it is written e to the power of beta t x2 minus x1. Okay, it can be seen that hazard ratio is independent of time. In other words, hazard ratio for any two individual is constant over time. This property is also known as proportional hazard assumption. Okay, then what is meant by partial likelihood? Partial likelihood, there are two papers already appeared in 1970 and 72 by Cox. One of the paper by 1992 introduced PL method as the process to estimate the regression coefficient of pH model. This method used the partial likelihood function instead of the likelihood function in the maximum likelihood estimation, refers to for 2014. The first step in PL method is by arranging the observation time t I equal to 1 to k in ascending order so that the times are ordered. That is 0 less than or equal to t1, less than or equal to t2, less than or equal to tk. Next, x is the vector of summation of all p covariate for individual whose experience is event of interest at time. If there are di occurrence of the event at time ti, the h element of xi is x of xi equal to given by this, and hxir is the value of x2 covariate for the rth individual of d, h equal to 1 to p and r equal to 1 to d. The approximation of the partial likelihood function in the case that it allows more than one individual to experience the event of interest at the observed time is expressed by the approximation of partial likelihood function in the case that it allows more than one individual to experience the event of interest at the observed time is expressed by L of beta is given by this expression 1. But delta is an indicator variable whose value equal to 1 when the event occurs or equal to 0 when the event is censored. Yi is the number of individuals who experience the event or after time ti I equal to 1 to k. There are two reasons why equation y is called a partial likelihood function. That is, it is not a full likelihood for beta. It does not use full data, but only use their ranking. Okay, the related log likelihood function of the partial likelihood function, equation 1 is given by log L of beta equal to given by this expression 2. Then by maximizing the log likelihood function of equation 2, the estimated value of beta may be obtained by using numerical approximation such as Newton-Raphson method referred to Jackson 2016. Then what do you mean by accelerator failure? Now we are going to discuss about the AFT model. That T is a random variable of survival time and X is a column vector of the covariates X1, X2, XP. And the AFT model defines the relations of survival function for every time T belongs to T given X, and the covariates as follows: S of T given X equal to S0 into T of e to the power beta dash X given by expression 3. Then where S0 is the baseline survival function and a beta T is beta 1, beta 2, B is the vector of regression coefficient and N belongs to capital N. The factor e to the power beta Tx is in equation 3 is known as the accelerator factor, which accelerates the survival function with the covariate X equal to 0. The AFT model assumes that the effects of covariates are fixed and multiplicative by the accelerator factor on the time scale of T. However, it does not assume that model holds the constant hazard assumption as in pH model. Okay, the relationship between covariates and the survival time can be illustrated. A linear relationship between natural logarithm of the survival time and the covariate X is given by ln of T equal to mu theta Tx and sigma of W, where mu is the slope, sigma greater than 0 is an unknown scale parameter, theta T equal to theta 1, theta 2, theta P. Okay, the is a vector of regression coefficient and theta equal to minus beta. Sigma is a scale parameter. W is a distribution error, which is a random variable and assumed to follow certain parametric distribution. For every distribution of W, there is a later parametric for T. The name of the AFT model comes from the distribution of T rather than the parametric distribution of L and T. The commonly parametric distribution which corresponds to AFT model are variable, exponential, log normal, gamma, and log. These distributions can be studied in detail by many researchers in the recent past. However, the AFT model that are considered in this research are variable AFT model, exponential AFT model, and log normal AFT model, and gamma AFT model. Their survival function of Ti, I equal to 1 to N, is given by Si of T equal to probability of Ti greater than or equal to T, and given by this expression. It is also rewritten as the last expression Wt of T, which is greater than or equal to ln of T my mu plus theta T over sigma. What is parameter estimation? Similar to other parametric model, the AFT model also can be estimated by using MLE. Likelihood function of observed time with unknown parameters beta T and a sigma which contain n-r right sensor data is expressed by this expression 5. Where theta less than or equal to r less than or equal to n is an indicator variable, is equal to 1 if Ti is observed and equal to 0 if Ti is censored observation. FT of and SA are identity function and the survival function of time Ti respectively. By taking logarithm of equation 5, it yields log likelihood function is as follows. Okay, the estimated values are unknown parameter beta, mu, and sigma, which maximize the log likelihood function. And equation 6 may be determined by using Newton-Raphson method. Table 1 respondent characters. This is the data set I already pointed out. Category age at birth, place of residence, woman education level, husband education level, contraceptive knowledge, access to mass media, wealth index, and employment status. And categories rural, urban, it is continuous nominal scale, and no education, primary and secondary, but it's ordinal scale. And the next one is ordinal scale, and contraceptive knowledge. Yes, no, yes, it is nominal, and access to mass media, no, yes, it's nominal. Wealth index is poor, middle, and above, ordinal, and the employment status is nominal. Okay, fitting a pH model, the AFT model. The AFT model, which are no assessment about pH, are used in the alternative to pH model. In this research, partial MLE approach are employed to estimate the regression coefficient and pH model and AFT model respectively. The computation of the estimation of both the model FBA data in India is performed by RStudio. So the estimation results of p-values of pH model AFT model in order to access the effect of each parameter and the survival time in pH model. 8 parameters are significant to 2 parameters are insignificant at 5% level. That is given in table 2. Okay, this is age at first birth, place of residence, woman education, husband level, contraceptive knowledge, wealth index, and the p-value and the AFT model p-value and the other things are given in this table. So in many cases, it is important to compare the efficiency of different model AIC. It's one of the common criteria to select the best model. The AIC computed by -2 log likelihood plus KP, where log likelihood is a likelihood function, P is a number of parameter, and K is a predetermined constant. Okay. Then AIC value based on equation or pH model and 4 AFT model for the data set computed by using RStudio. Comparison of pH model and AFT model using AIC criteria, pH model and a Weevil AFT, exponential AFT model, and a log normal AFT model, and respective values are given. Okay. So the AIC values in table 3 obtained in the case of full model, which means that the covariates are indicated in the model. According to table 3, AIC values of pH model is and it is double the average AIC value of all the proposed AFT model. It proves that AFT models are much better than the pH model to fit the data set. In other words, log normal AFT model is the best fitted model among the other considered model as per our data set is concerned. Okay. So conclusion, in this, the pH model for 4 AFT model applied to NFHS by 2021 data in India, it was clear that constant hazard assumption for the FBI data in India was violated. Although the procedure of the log cumulative hazard class was relatively simple, it is difficult to make decision about the pH assumption for any covariate which consists of many categories. Okay, the results showed that gamma AFT model is the lowest AIC value comparing the pH model. Weevil AFT model, log normal model, and exponential AFT model. It means that gamma AFT model is the best fitted model for NFHS data in India among the other considered models. Okay, these are all the reference sample 1992 Cox analysis of survival data, non-proportional hazard function, Lee and Wang 2003 statistical method for survival data analysis, New Jersey John Wiley and Son. V AFT time model useful alternative to the Cox regression model in surveillance statistics and medicine, and also K and Kinsley 2002 on the use of AFT model as an alternative proportional hazard. It is a case study influencer drug. Information journal 36 page number is given. Kennel and Srinivas V. Acharya SK in 2014. It is a Journal of Science Research, and Obes et al. For surveillance statistics in medicine in 2002. And then Cox 17. It is a very well-known paper. Any researcher to start their work to start with the proportional hazard, Cox model, regression model like that, you can go through the paper. It is appeared in 1972, JRSS. And there is another one paper which is quite interesting. It's that 2014 estimation of parameter data in this way, and Sheffield 1982. So these are all the references. Now I completed that model, and the gamma priority, log normal, and other priority are discussed by so many authors in recent past. By collecting the data, our gamma priority seems to be the best and gives better result. Okay, thank you very much, sir. Now I completed my talk. Then, with the permission of the chair, let me.
Congratulations, Professor Elangovan. You got well on time. You have completed even well before 2 minutes earlier than the time allotted.
Okay.
Congratulations. Now, Professor Elangovan has delivered a nice talk and informative and very, very useful. And it is I hope that the young research scholars would have find it very much interesting also on accelerated failure time model. Now, I invite comments, questions from the participants.
No.
Comments are also nice. Good morning, Professor Ravanan.
Ravanan, good morning. Speaker Speaker on.
Good Professor.
Good morning, Professor Ravanan.
Hello.
Yes.
Principal.
Well, if there are no questions, I think let us thank our invited speaker, Professor S.R. Elangovan, for his nice talk. And I thank the organizers, Dr. Jayashree and Professor Bhattacharylu, for inviting me to chair this session. Thank you. Now I hand over the session to the organizers. Thank you, one and all. Thank you, Professor Rangovan.
Thank you very much for your sharing. Thank you, Jayashree, also for giving me an opportunity to deliver my talk. I thank all the organizing committee members of the ISPS fortunate enough to give me a chance to deliver my talk. Thank you, Logu. Loganathan is with me for more than 3 decades. So he is my close colleague, and also he started his on the same department. He is alumni of our Annamalai University department. We all together working in the same roof of Professor M. Rajagopalan. He is a Bayesian influence, Oklahoma State. Tomorrow we are going to honor Professor MR in the NAC accreditation visit. One among the alumni is biodata and photo will be displayed for all the committee members, those who are visiting our department, and also on the central stream. I thank Loganathan. He has been with me for more than 3 days. I wholeheartedly thank the chair of Dr. Loganathan. I want to present. Thank you, Jayashree, and other organizing committee member. Thank you, Ravanan. Thank you, Reddy Garu, or other ISPS president, other organizing, other present members for giving me an opportunity to deliver my talk. Thank you. Thank you, one and all.
I thank the chair, Professor Loganathan sir, and I also thank Professor Elongovan sir. Thank you for accepting our invitation. Thank you, sir.
Madam, we leave the meeting because we have to. I have my presentation in another hall. Shall I leave the meeting?
Sir, please, sir.
Thank you, Professor Sandhamarikanan. Professor, thank you very much, sir. Good morning, Professor Sandhamarikanan. Professor.
Thank you, sir.
Thank you, Professor Elongovan. Thank you. All the best.
Sandhamarikanan, good morning.
Thank you. All the best.
Professor, good morning.
Professor Ravanan, good morning.
Good morning, all. Good morning, Professor Ravanan sir. Good morning, Professor Anjaneyulu sir. Good morning, Professor Sandhamarikanan sir. Good morning, Professor Tangaraj sir. Good morning, all. I will take a privilege to introduce our chair of this particular session, Professor GVSR Anjaneyulu sir. Sir is a professor in Acharya Nagarjuna University, Andhra Pradesh. Sir's areas of research interest are statistical inference, design and analysis of experiments, industrial experimentation, quality improvement methods, statistical quality control and reliability, and also in the recent upcoming topic, data mining. And a number of books published and edited by Sir are 4 monographs were edited for 2 textbooks in AP Telugu Academy, and 8 textbooks and study material for the Center for Distance Education and also for a Center for Distance Education of Acharya Nagarjuna University. And Sir has guided 12 PhDs and 11 MPhil. Very thankful to you, sir, for readily accepting our invitation to chair this session. And I also thank the speaker of this session, Professor Ravanan sir, for readily accepting our invitation and be here to present, to give the talk. Thank you, sir. Thank you.
Thank you very much. And I sincerely thank all the organizers of this conference for giving me an opportunity to interact with the speakers and also the fellow teachers. And now I request Professor R. Ravanan to deliver a talk on structural equation model using analysis of moment structure. So before going to deliver his talk, it is my privilege to introduce Professor R. Ravanan. He is at present a Joint Director of Collegiate Education, Tamil Nadu, Chennai region, Chennai, and formerly he was the head of the Department of Statistics in Presidency College, Chennai, and also former principal for Presidency College. And he is the former secretary for our ISPS, and at present he is the General Secretary for Tamil Nadu Statistical Association. And he is a popular teacher. He delivered 360 lectures so far on diversified topics for popularizing and propagating the topic subjects, our subject statistics. And he has guided successfully 12 PhDs, 6 MPhil, 19 MPhils, and he authored 6 textbooks. And for his teaching, he got 4 appreciation awards from USA and also from various organizations in Tamil Nadu, in and around Tamil Nadu. He is got all these awards for his teaching excellence. Now I request Professor R. Ravanan to deliver a talk on structural equation model using analysis of moment structure. My sincere request to the speaker is, sir, your talk is for 20 minutes.
Okay, thank you, Professor. First of all, thanks to the organizer, Dr. Jayasri and the other team and the head of the department for inviting me for this invited talks. I'm also thanks to Professor Anjaneyulu for nice introduction about me. I also thanks to Dr. Professor Sandamarakan, Professor Loganathan, and other team of Tamil Nadu, my well-wishers, dear participants. My topic is structural equation model using AMAS. Yeah, voice is okay?
Okay, sir. Okay, fine.
Yeah. Then usually I can deliver wherever lecture. I can concentrate mainly on practical side, not much more on theoretical side, because my more topics only related to social science. That's why I'm mostly concentrate only on application side. I not concentrate on any derivation or any equation or any assumptions. So first, what do you mean by structural equation model? Structural equation model is nothing but advanced level of multiple regression. You know what is regression? To find the cause and effect. Your unit changes x1, x2, x3, what's the effect on y? That can be studied through multiple regression. The structural equation model is the advanced level of multiple regression. So for any research, always you have to start with structural equation model. That is nothing but the scheme of your research work. Whatever scheme, whether you want to start, where do you want to start, where do you want to finish. For mainly it is focused on social science. Even for statistics, medical field, all this field, we can use structural equation model. See, I can show some of the structural equation model before start main work. These are the sample model. Suppose wherever you want to reach, that you can put it on right side. That is my aim to reach loyalty. How to reach loyalty? Through purchase intention, perception, expectation, satisfaction, I want to reach loyalty. If you connect all the 4 factors directly with loyalty, means this is nothing but multiple regression analysis. But I'm not connecting all the 4 directly with loyalty. First, purchase intention, perception leads to expectation. Now, expectation is the dependent variable. Purchase intention, perceptions are independent variable. In the next stage, the dependent of expectation become independent for satisfaction. So now satisfaction is the dependent variable, expectation, perceptions are independent variable. In the next stage, the satisfaction of dependent becomes independent for loyalty. So in each and every stage, that dependent becomes independent. This is the advanced level of multiple regression. Here, the whole, all values, whatever you are getting values, this is similar to regression. But you have to draw the model, you have to run the model. It is not possible through ordinary SPSS. We have to go for either AMAS graphics or R programming or some other software. So this is one simple model. The next model related to teaching competency. How to reach teaching competency? Through teaching skill. How to reach teaching skill? Through this 5 factor. This is called a scheme work for your research. Wherever you can start your social science, any research, where do you want to start? Where do you want to finish? What is the mediating factor? What is the moderating factor? This you have to study through structural equation model. The another model is mainly related to talent management, organization efficiency. This 2 leads to performance and intensity state. This 2 leads to through this 6 factor. Many studies related to work-life balance. How to reach work-life balance? Through work-life conflict, life-work conflict. How to reach this? through organic support, superior support, family support. So how to prepare this model? Just based on review of literature. Based on the review of literature, you have to prepare model. Suppose already this model is available. You can add some of the factor or delete some of the factor, add some of the factor. This is called your model. See here service quality is the unobserved variable, but measuring service quality through this 5 factor. From the service quality, we're reaching shopping experience, then loyalty, then customer loyalty. This is called mixed model. CFA, that is confirmatory factor analysis, and CFSM. Okay. See here also for service quality reaching through this 5 factor, service recovery through this 3 factor, finally we are reaching store loyalty. So each and every model, there is main factor with the sub factor. But for this wherever circle oval shape, we are not given any data. Only based on the rectangular shape, whatever variable in rectangular, we are given data. So based on this model, whatever research, you have to develop some model. Based on the model, you have to prepare your questionnaire. Based on the questionnaire, you have to collect data, then prove whether your model is fit for your data or not. This is a simple logic of structural equation model. Okay. Now, I want to take one simple model here. How to run this model, how to get the result, what is the interpretation. Everything is very, very easy way to analyze. One of the software is called AMOS, analysis of moment structure. Is the hands-on training is very, very easiest model. Compared to SPS, it's a very easy one. Okay, based on this factor, I'm preparing my questionnaire. Based on this purchase intention, perception, expectation, satisfaction, loyalty. Based on this, I'm preparing my questionnaire. For each purchase intention, I'm preparing some 10 statement, 20 statement, 30 statement. It is depends upon the researcher to researcher. So maybe 5-point scale or 7-point scale or yes or no, whatever. Okay. Now confirm how I have some 5 statement, 10 statement under purchase intention. I want to confirm whether this statement confirming purchase intention or not. You have to run confirmatory factor analysis, CFA. In factor analysis, there are 2 types of factor analysis. One is called confirmatory factor analysis, another is called exploratory factor analysis. Exploratory means you have some set of 30 statement, 40 statement, you have to run factor analysis and decide the factor and name the factor. But here it's opposite. First you have to name the factor. Under factor, you have to prepare some statement. Based on the, I want to confirm these statement confirming corresponding factor or not. This is called confirmatory factor analysis. So based on the data, I am preparing questionnaire. From the questionnaire, I am collected my data and I am entered in SPSS. See my data here. I am entered the data in SPSS software. Purchase intention, perception, expectation, satisfaction, loyalty. I have a set of questionnaire. Adding the statement, we are getting the total score for each one. Loyalty, I'm taking only one statement, 5-point scale. So it's only minimum 1, maximum 5. But others, we have a set of statements, so I can take the total score. Either you can take total score or average. Final result should be same. So based on the questionnaire, based on the statement, I prepared the questionnaire and collected data for 150 sample and entered in SPSS. Now I want to run this model. How to run this model? Now go to AMOS graphics. AMOS is the add-on software in SPSS. Whenever you have to buy SPSS, you can get additional amount, you can get AMOS graphics. For all purpose of structural equation model, we can use AMOS graphics. Now, compared to SPSS, it's a very easy to run the model. First, you have to, my data is in SPSS. You have to open the data from SPSS, go to file, data file, file name, go to the proper folder. Open SEM data, whatever your file name. You are getting your file name with 150 by 150. Your sample size, you can get it here. Just give it OK. Now your data is open in AMOS graphics. One of the simplest software. It's a very easy, useful, very application-oriented software for. Now I want to check whether the data is open or not. What are the variables used in the data? There is third column, third option, list variable in data set. Just click, you are getting one small box. This small box contains all the variable with the label, SPSS label. Now, the next I want to move all these variable on right side, just move. Put it anywhere in the box within the. After that, moving is not possible. There is one function here, move object, second column, fifth one. Yeah, anything want to move, use, just click, that function is working. Now it is possible to move anywhere this variable. Very, very, very friendly user software. Now here, purchase interest is a 2 variable. I want to put that, if it's sometimes 2 variable, 2 variable, 3 variable word, you can put it in a lengthy way. I want to put it one by one, just right click and click object properties. You have to, after purchase intention, you have to put enter, automatically that word comes down. But don't change the variable name. If you change even a single letter in variable name, it won't work. Whatever changes the variable name, you have to do it in the SPSS software. But label you can change, you can type new, so it works. I want to change the shape of the box. There is one function here, change the first column, sixth one, change the shape of the object. Just click here. Whatever size, whatever shape, everything is possible by this software. Once you get final result, you can do full makeup after that. Again, if you want to move anywhere, just move. Now, using the single arrow mark, this single arrow mark indicate partial regression coefficients, simple regression coefficients, just like in regression. Just connect. The single arrow mark indicate partial regression coefficients. See here, whenever there are two, whatever independent variable that is connected by double arrow mark, that is covariant. Double arrow mark indicate covariance. If you are not connected, when you run the model, it will ask whether you want to connect or not. Because in regression, each effect, participation on expectation, we can find out, perception on expectation, we can find out, but how simultaneously these two variables concentrate on expectation, that you have to find out through this model. Now, here the three variables are dependent variable, expectation, satisfaction, loyalty. Whenever you have to dependent variable, whenever you have to dependent variable, you have to predict. Whenever prediction, there is some error. So you have to introduce error term. Otherwise, it won't run. So there is second column, third column, second option, add a unique variable. Just click, click, click. Again, it rotates 8 directions. Any direction it is possible to place. Again, click, again, click. You can get, these are called error. Now I want to introduce E1, E2, E3 error. Just go to plug, by manually it is possible. There is one more option. Go to plugins, name unobserved variable. Just we are getting E1, E2, E3, E for error. You can name any other name, it is your choice. There is one function here, resize the path diagram, fit on page. Automatically it is fitted on A4 size. Suppose if the diagram is outside this range, it is possible to fit on page. Now, your model is ready. Just maximum 1 minute, 2 minutes, 3 minutes, you have to draw the model for any research work. Now you have to save the model, then only possible to run file. You have to save the model in any one folder. Before run the model, what are the outputs necessary? For that, go to view, analysis properties, go to the output. You want to put standardized estimate, just like in regression, we can unstandardized and standardized. Then the very important one, modification indices. The purpose of modification indices, whether the model is not fit, how to improve the model, it gives some suggestion. That's the purpose for using modification indices. If you need other direct effect, indirect effect, total effect, then multiple correlation, whatever needed, you can click, you can get the result. See now, there is some color here, green color, but the next box, there is the colors are not highlighted. If the model is successfully run, we can get same color here. The same color here, just go to analyze, calculate, estimate. See, now the same color you are getting, your model is successfully run. Click the second box, we are getting values along the line. These are the values are unstandardized coefficients, unstandardized regression coefficients. There are two estimates. One is called standardized, another is called unstandardized. Just like in regression coefficient, there are unstandardized and standardized. But if you want both, you can put it in your thesis, or better for standardized estimate is enough. Now, how to view the all output? Go to view text output. First, we can go for analysis summary. When you run the model, just then nodes per group, what is the sample size, then variable summary. See here in the variable summary, there are observed endogenous, exogenous. In simply, you can call it dependent, independent for multiple regression. The name only changed here. Endogenous means dependent, exogenous means independent. Only name changed. Then what do you mean by observed and unobserved? Wherever data given by you, it is called observed. Wherever data is created by the software, then it is called unobserved. I am not given any data for E1, E2, E3, but I am given data for expectation, satisfaction, loyalty, purchase, perception. That's why it is called observed. This is called E1, E2, E3 or unobserved. See in the diagram, I am using some variable for rectangular, some variable for circle, not based on my own interest. Wherever data given by you, you can use rectangular. Wherever data created by the software, that is called unobserved, you can use circle. This is a simple difference between circle and rectangular. Or rectangular, you are given data. Wherever circle or oval shape, the data created by the software. If you put opposite, it won't run the model. So totally how many variables here? There are 8 variables in the model. Of that, 5 variables are observed variable, 3 variables are unobserved variable, 5 variables are independent variable, 3 variables are dependent variable. These are the variable summary of your model. The next you have to get estimate. In this estimate, the same value only along the line. Okay, this is called unstandardized regression coefficients. The next one is the standardized regression. If you click everything, you can get the result. What is what? That's one of the advantage of the software. Any number you can click, you can get. What is 0.240 indicate what? When purchase goes up by 1, expectation goes up by 0.024. Every unit changes, purchase changes by 1 unit, expectation increase by 0.24. So all the interpretations are available here. What is standard error? What is CR? CR means T value. Then P value. So once run the model, you have to check whether all the paths are significant or not. Here, all the paths are highly significant. After this path, which is number 1, number 2, number 3, based on the standardized coefficient, you have to rank which is number 1, number 2, number 3. Don't compare with unstandardized coefficient, always compare with standardized coefficient. Then these are the covariates and other value. Now, you have to check whether the model is fit for your data or not. That is called model fit summary. For this model fit summary, there are chi-square value, degrees of freedom, p value, and chi-square by df. See the p value here, 0, 0, 0. That means your model is not fit, because my assumption is the fitting of model is good. That is the assumption. The null hypothesis here, the fitting of model is good. Now the p value is less than 0.05 means what? It is reject. Reject means the model is not fit. Either p value should be less than 0.0, greater than 0.05, or chi-square by df should be less than 5, then only the model is fit. Here both conditions are not satisfied. If both conditions are not satisfied, how to improve the model? For improving the model, go to the modification indices. There are some suggestions in the model. If you use this suggestion, that model may be improved. What is the suggestion we have received here? We are connecting E2 and perception, then E1, E2. That is a double arrow mark means covariance. You have to connect by double arrow mark. This is one covariance either connect, or you have to add one more regression weight, perception to satisfaction. These are the modification indices. Based on the modification indices, the highest modification indices you have to connect first. What is the highest modification indices here? 23.921. So I want to add perception to satisfaction, that model may be reduced. The chi-square value may be reduced. Now the chi-square value is, what is the chi-square value here? 53.633. But if you connect this, the chi-square value reduced by 23.921. Such a values may be reduced. That's the purpose of modification indices. Now go to the model. If you want to connect anything, you have to remove the values, then only the model is works. So remove the value means you can click the left side. Now using the single arrow mark, connect perception to satisfaction. This is one more suggestion I am received from the modification indices. So all the suggestions are, you can get it in the model. There is no mind work for you. Everything will take care of this software. Now again, run the model. Just click the values, go to the output, see in the output, see estimate, all are significant, highly significant. Model fit, see the model fit here. Now earlier it is 0.000, now it is the p-value is greater than 0.05 means the model is fit. That means you have to accept. Accept means the fitting of model is good, is accepted. Earlier it is not accepted, it is rejected. Now go to the modify indices, now no more changes in the model. Okay, further modification not necessary. If it is necessary, you can add some more model, some more path. So based on this estimate, based on this model fit, then GFI, what is GFI? Goodness of fit index. Everything is available here. How to calculate goodness of fit index? What is the yardstick of GFI? Everything is given. Then AGFI, adjust goodness of fit index. Then normed fit index. Then comparative fit index. These four index indicate the goodness. Any goodness above 90% is well and good. The RMR, root mean square residual error. Any error should be less than 8%, less than 10% is well and good. Instead of RMR, RMSCA is enough. Root mean square error of approximation. Either RMR or RMSCA, anyone is enough. Here RMSCA less than 8%. So based on this, now I can decide the model is fit for my model. Okay, so before this, you modify indices. So all this model will take care of the software. Just based on the review of literature, you have to prepare some model. Even for statistics, for medical side, you can, based on the primary data or even secondary data, whatever data, we have a plenty of variable. That variable, which variable influence which one, which variable influence again which one. This you have to decide it by review of literature. Based on the review of literature, you have to prepare model, and based on the model, you have to collect data. Then once you collect data, you have to run the model, check whether your model is fit or not. Always you have to develop your own model. It is possible in that order. Okay. Any t-test analogy, all statistical analysis is the standard one. But if you want to develop some new model for your research, you have to create new model and run the model, check whether the model is fit or not. It is easy for publish the article and also easy for new model under your name. It is, you can call it some name in your name. It is possible. Such a powerful analysis by using structural equation model by Amos Graphics. There are plenty of software is available, but this software is a very, very friendly user. That's why I'm always use this software for all social science people, because mathematical people or computer science people, they thorough on programming, coding, everything. But for any social science people, they want not much familiar in coding and other things. So for just running the model is very easy for all social science people. That's why so far conducted more than some 400 workshops all over India for structural equation model and the SPSS and all of the data. Thank you, sir. If you have any queries, I am ready to give answer.
Thank you, sir. Thank you very much. Very nice presentation and very quite informative. Sir, this particular software has to be purchased along with SPSS or separately?
Yeah, you can purchase along with the SPSS. Even separate also possible, but SPSS is the add-on separate. Now it is available.
Okay, sir. Okay, very nice presentation, sir. Now I request all the fellow colleagues, any doubts or questions you can raise right now. Sir, here you told that one question that developing our own model.
Yes. Based on the review
So
of
that
literature.
depends up.
Yeah,
That
review
depends
of
upon the
literature.
data.
Yes, data, availability of data. You have to prepare model. Suppose that model is already published in some other paper, means you can add some more factor. Add, it is your model.
Okay, sir. Okay. Okay. Thank you very much, sir. Once
Thank
again,
you.
on behalf of the organizing committee, I sincerely thank you for your nice presentation.
Thank you. Thank you, Professor. Thanks to all, Professor.
Now, I request Dr. Nch Bhattacharylu Now, Dr. Nch Bhattacharylu is going to present his talk on reduction of dimensionality of response surface design models. So I would like to introduce Dr. Nch Bhattacharylu. He is a faculty member from Osmania University, and he has completed his PhD in 1994 and joined the department in 1995. And he has so far successfully guided 5 PhDs and 3 MPhils. And 70 research papers are there to his credit from national and international journals. He has some monographs also. Super saturated design construction and response surface design model reduction is one monograph published by a German publisher. And he has completed 2 major projects. He also did a project, UGC PERS phase 1 project also during 2017 and 18. And at present, he is the deputy coordinator for UGC DRS SAP1 phase 1 project. And now I request Dr. Nch Bhattacharylu to deliver his talk on reduction of dimensionality of response surface design model. Dr. Bhattacharylu.
Good morning to all. Thank you for your nice introduction, Professor Anjaneyar sir. My topic is the response surface designs, reduction of dimensionality. Let's suppose there are V factors each at S levels for experimentation, and D denote the design matrix for the different combinations of the factor levels. Let YU be the response at each level combination, and factor response relationship is generally called the response surface, and the design that is used for fitting of the response surface model is termed as response surface design model. And the design and the study of the functional relationship between the response and the factor combination is generally said to be the response surface study. Here I'm going to about the response surface model, which is generally we are expressing in terms of the general linear model. Y is equal to x beta plus epsilon. So y is the vector of the responses or observations, and xu be the eth row of the design matrix x, and beta be the vector of the parameters, and epsilon is the vector of the random errors. And we are making the assumption of the normality with the homogeneity of the variance. And suppose if you are considering the response surface model, the dimensionality reduction is the problem that what we are facing in most of the designs when the number of factors are more than 10, or depends upon the number of levels also. So as the number of factors are increasing or the number of levels are increasing, automatically the size of the design and the size of the model that is also increases. As a result, the difficulty level of its analysis for the response surface model is also increases. So almost in the large scale, it is always inaccurate in higher dimensions. It leads to the curse of the dimensionality. The size of the design model that what we are going to use is we cannot directly reduce the size of the design model after the conducting of the experimentation, or we cannot reduce the model directly. So whatever with full factors or whatever the combination that you have conducted, with that you have to continue. So here I am considering the 2 aspects in the dimensionality reduction. One is minimizing the number of factors or the factor combinations in the model with the minimum loss of information in the data. So without lossing of the information, it is it is not possible. So the whatever the loss must be as minimum as possible. And constructing the design with the minimum number of design runs, that is another possibility when we are comparing with the number of factors. So these are the two aspects that what we are considering. One is with the minimum number of design points or runs, that is experimentation is conducted, and identifying the most important factors and reducing the size of the model. Now, when we want to go for the reducing the number of design points in a design when you are constructing it, here out of the large number of factors, if relatively few factors are which are active for the experimentation, the experimenter has to minimize the number of design points and to identify the active factors for efficient utilization of the resources and minimization of its cost and time. And in this aspect, the super-saturated designs are playing a key role, which reduces the size of the design by minimizing the experimental cost, time, which are significantly. So what is a super-saturated design? It is a one factorial design, and it is said to be if the number of factors is more than the number of design points or runs. That means as a result, the number of the experimental trials to be automatically minimized. So this is one of the aspects that what we are considering in the factorial design, in the super saturated designs. And whenever it is equality holds, generally called a saturated design. And when computing its E of S square value, the expected value of S square, the criterion for that value, which is minimum, then generally you are said to be E of S square minimum supersaturated, that is called a supersaturated design. These saturated designs was initially introduced by Scatterwhite, and the later the systematic method of the construction was identified by Booth and Cox. And now here there are several authors that contributed for the same in identifying the in the recent development. And here also that we are developing by using the incomplete block designs. So this is one of the aspects that what we have considered for the construction of a supersaturated design for the response surfaces. And a supersaturated design with the two levels can be constructed by replacing the 0 with -1 in the incidence matrix of the P associate class, the partially balanced incomplete block design with the specified parameters. If V is greater than B under that particular condition, we can construct and has one of the supersaturated design. And the method of the construction is very simple. And whatever the partially balanced incomplete block design with B less than V, that what we are considered with the P associate class, by replacing the elements of zeros with zeros with ones and the -1s, the other element, then automatically you are obtaining the supersaturated design. And this can be used for the experimentation, and its E of S square value, whenever you are calculating that for this particular experiment, this value is this. Now for the generalization, the E of S square, the value is also computed for the 2 associate class. So if it is a 2 associate class partially balanced incomplete block design, and specifically that had taken one group divisible partially balanced incomplete block design, in that case, the E of S square value, that is the minimum value that you can obtain by using we have derived that formula. And even if you are calculating for the any other specified parameters for any other design, so that is also general partially balanced incomplete block design with the 2 associate the E of S square value that is obtained. And when you are considering the another aspect, that is reducing the size of the model of the response surface. Let's suppose we are having a first order response surface design model, and we are imposing the conditions of the sum of the levels of all the overall the runs is equal to 0, and the cross product will be also 0, and restricting to the summation of xi square over all the runs, the value is n lambda 2. Then the variance covariance matrix that you can express in the form of this model, and its inverse matrix is 1, 0, 0, lambda 2 inverse I. And the variance of its estimated response that you can be expressed as variance of beta naught plus summation of the variance of the parameters of I is equal to 1 to n. And if you are putting the variance of beta naught is equal to 1 at here, and variance of beta I is equal to lambda 2 inverse. So automatically that is also, we can reduce it. The variance of the estimated response that you can obtain, and the variance of beta hat is equal to x dash x inverse into sigma square. This is a general model that what we are expressing, which is already available. Now, coming to the second order response surface design model, the variance of the estimated response for a second order model, when we are putting the restrictions over the moment matrix, all odd order the moments will be zeros, or the whenever you are calculating the cross product of any of the odd power is summing to 0, then we can express the variance of the estimated response in the function of the rho square. And this is the general which is already available and which is generally said to be a rotatable design. Now, if I'm considering the either rotatable design or non-rotatable design, in both cases, we can use the nested approach for, there are 4 approaches that I'm proposing for the model of reduction, and such that the variance value will variance for the estimated response is least. So one of the approach is the nested approach, and the second one is the Bayesian approach, and the variance component indices that what we are proposing. These are the 3 approaches that what I am trying to explore it. According to the nested approach, let's suppose we are having a response surface design model and containing the V factors are there, and F1, F2, so on, Fv. And we are considering, we are computing the functional correlations between the response and the factors, and we are arranging them in one particular order of their magnitude by ignoring the sign, and we are identifying the maximum one, and we are fitting a first simple linear regression model, y is equal to some beta naught 1, beta 1, x1, by assuming that x1 is having the maximum correlation with the response variable. And again, we are calculating the estimated responses, that is the y hat, by using the, after fitting the model. Then I'm calculating the error value. The error values are the original observations minus the estimated, and these treat these errors as observations, and we are considering the correlations between the error values to the remaining variables which are to be selected, and out of those, again, I'm identifying the maximum correlated variable, and that variable is again included in the model, such that again a simple linear regression model only that I'm trying to fit. And the same process is repeated until the significance is not identified. That means whenever the model is insignificant or that variable is insignificant, then we are stopping it. The same thing that what I expressed in a flowchart model. So here one of the response variable and the factors and ln 1 is one of the first time whenever you are calculating the observations, so these are the other. So evaluate the correlation between unselected factors and response. And again, we are calculating the maximum correlated, and again, we are fitting the model by using this one and calculate the error. And whatever the errors, and we are checking the parameters for its significance. And again, we are repeating, and same process will be repeated until there is some insignificant variable that are identified, and the process will be terminated. The same thing that what we have implemented for the one of the first order design model with I think just one, yeah, 16 design points with 5 factors. And this is the correlations between the responses and whatever the observations are there in the initial. And this is a simple linear regression model that is fitted, and we are evaluating the regression analysis for that, and we are identifying the significance. And again, the errors are calculated and treating those errors as observations. And again, that we are computing the correlation between the whatever the factors are there and to the original the error values. And again, I'm finding the maximum correlation and repeating the same process. And whenever there is some insignificant, this process is stopped. And here the R square value is a 96.2, and the model is significant. Now, whatever the problem of the general in the simple linear regression, or whatever the stage-wise or stepwise regression, it is almost seems to be same, but with a slight difference between the stage-wise regression and the nested approach. And when you are evaluating the full model for this one, there are beta naught values in the first time, second time, third time. These are all that are added, and the whatever the variable coefficient that was added, and we are constructing the model. And also that we are compared with the regular classical models, and found that somewhat it is almost equivalent with the stepwise regression, but a slight difference is there in the decimals, and which is somewhat more efficient. And also that is compared with the other models. Now, suppose if you are considering the non-orthogonal models, so in those cases also that we have examined the same, and we have evaluated, and it is also giving the almost the same result when you are comparing with the classical methods. And the orthogonal and non-orthogonal cases for the first order and second order that we are trying to explore, and we have found the same, somewhat it is almost equivalent with a little small difference between the mean square or the error. And now where you are comparing, computing with the proportion of the variances indices. These are called variance component indices. So let's suppose if you are considering the full order model, and I'm computing the variance components for each of the term of the full model, and variance of the estimated response is divided with variance of each of the component in the model. So those values are indicated with the S naught. S naught is beta, variance of beta naught by variance of y hat, and variance of SI is variance SI is nothing but the variance of the beta I by variance of y hat, and so on. And the indices that are evaluated, like the same what I explained, S naught and S1 and or SI. Sij, that is the covariance term, whatever the variance component, and the covariance term, the components Sijs also that are evaluated. And these are the values that we obtained for a rotatable design for S0 and Si and Sij and Si. And this is also that is published in the communication statuses with one of my student work, Dr. Amin. The another approach that what I proposed. So these are the components that we are calculated and comparing with the different and efficiencies are evaluated. Now, if I'm computing the one of the simple example, let's suppose X be the design matrix and Y be the response of the observations with some 27 design points. These are the estimated parameter that what I got, and I calculated the variance component indices like S1, S2, S3, Sij values and Sii values. And these are all arranged in a ranking order, and also we can identify so which is having the least significance that you can also ignore it. So in that aspect that you can reduce the model. So this
Okay,
is also
Bhattacharylu, can you conclude?
Yeah.
As the time is running short.
Now the another approach that what I am proposing for the same response surface model is the last one, that is a Bayesian approach. Let's suppose there are different possible models that are existing it for the V factors. Now we are evaluating the best model, that is M star, about all possible models M1, M2, so on, MM. And we are evaluating the posterior probability for the different models, and which is having the most posterior probability, that model is selected. So that approach that what I used it for the same. So this is the distribution that what you have derived it for the response of the posterior distribution of the parameter and what are the values, and we have to simulate the data and based upon the original sample observations. So this is my conclusion, sir. Thank you, sir.
Okay, Bhattacharylu, can you complete it?
Sir?
Is it completed?
Yeah.
Okay, now I request the audience.
This is only the last method, sir, that what I have expressed.
Okay.
So we are comparing all the methods, and this is this one. That's only the last. Any questions, sir?
So, I have one small doubt, Bhattacharylu garu. Your title is reduction of dimensionality.
Yes,
So this reduction of dimensionality is for the existing designs, or you are going to construct a design reducing the dimension of the design?
This is design is only for the construction in the before the experimentation, not existing designs, sir.
Okay. Then we have a process in our construction of designs, sequential construction of designs to reduce the time and cost. And we have several other methods also apart from your suggested methods. Do you done any comparison work?
Yes, sir.
So among your works, which method seems to be superior method?
Better method when you are comparing with others.
Okay. I have only one more doubt, sir. One, that is variance estimation response surface design. You are saying in some slides and you are saying rotatable designs. I hope
Rotatable
both
designs
are one.
and non-rotatable, both that you have calculated, sir.
Acha. Okay.
You have calculated for
Okay.
both.
Acha. Okay, sir. Thank you very much. Now I request the audience, do you have any queries, questions, or suggestions? You are welcome.
Sir, I have a small query. I am Professor Victor Babu.
Tell me, sir.
Yes, sir.
Sir, Bhattacharya, sir, can you
Sir.
give the references for this paper? For this
Yes, sir.
talk?
Just.
You have not provided any references.
It's
for
already,
this?
no, in the slide itself, it is there. Just a minute. Is it visible, sir?
Okay, okay.
So these are the papers in one is Communication Statistics Theory and Methods, Tyler and Francis series. One is in Turkish Journal of Computer Mathematics and Education, and one is the International Journal of USA Recent Publications, and another one is Far East Journal of Statistics and Mathematica. Sorry, Far East Journal of Theoretical Statistics. The full-length work is already presented in these papers, sir.
Okay, good, good. Okay, sir, your presentation is nice. Paper is good. Congratulations.
Thank you, sir.
Thank you very much,
Professor
Bhattacharya
Eigen, sir,
and
for
Professor
giving an
Victor Babu, Professor Victor Babu, and all other participants who made this presentation a nice one. And we appreciate the work of Bhattacharya because since we, myself and Victor Babu, both from the same area of responsive designs, so we appreciate your efforts in this area. Thank you very much. I once again sincerely thank the organizers for giving me this opportunity to chair this session. Thank you to one and all. Over to the organizers.
Thank you
Thank
so
you,
much, sir,
Aanjal
for chairing the session. Thank you, sir.
Thank you, madam. Thank you.
ఆగండి ఒక్క నిమిషం ఎవరు రంజిత Next, we move to the contributory papers presentations. Chair of this session is Dr. Ranjita Pandema.
Can I start the session?
Yes, ma'am.
Thank you so much. Welcome to the contributory session of design and analysis of experiments. This is the second contributory session on the same topic. We have 3 speakers here today from
Just
the
1 minute, sorry
schedule.
for interrupting.
Am I audible?
Yes, madam.
Okay, so we have 3 contributory participants here, and then one is reassigned to this session. So in all, we have 4 speakers today. Can I just ask how many of us are present? Sunil Kumar Yadav and Anil Kumar. They will be presenting factorial experiment with logistic error distribution. Are you present here, sir?
Yes, madam.
P. Sheshu Babu and A.V. Bhattacharylu, they are presenting on cubic response surface design using pairwise balance design. Are you present here, sir? I repeat, P. Sheshu Babu, A.V. Bhattacharylu, sir. Are you present here?
I think no.
Third participant, Kancham Srinivasa and Professor Bhattacharylu. So the topic being estimation of missing responses in design and analysis of experiments with EM algorithm. Are you present here, sir? Kancham Srinivasa and Bhattacharylu.
Yes, madam.
Sir.
Yes, madam. I'm going to.
The last participant who has been reassigned to this session, Jabir B and Bindu P. They will speak on a new generalization of inverse exponential distribution and its applications. Are you present here, sir? Jabir B and Bindu P. Are you present here, sir?
I think they are not.
Okay.
So then you can manage the two speakers maybe in 15 minutes.
Okay, fine, sir.
Because we have to start our session at 12 o'clock.
Yes, so fine. I invite Sunil Kumar Yadav and Anil Kumar sir to present their paper on topic an empirical analysis of 2 into 3 square factorial experiments with logistic error distribution. You may share your slides, sir. Yes, we can see your slide now. Try to enter full mode if possible, sir. Sunil Kumar Yadav. Yes, you are in full mode now. Please begin.
Thank you, madam. Good morning to all. Title of the talk is an empirical study of 2 into 3 square factorial experiments with logistic error distributions. So now directly I'm starting with the introduction. Factorial designs were introduced by Fisher and Yates are often the best and most used designs when the effects of multiple factors are investigated simultaneously. Analysis of variance procedure in the framework of experimental designs has traditionally been based on assumptions of normality. It is well known that the least square method is efficient only if the error is normally distributed. So, however, in practice, non-normal distribution are more prevalent, as discussed by these authors in different papers. If the error term have a non-normal distribution, then the efficiency of least square estimates and test is very low. So it is interesting to study the effect of non-normality on the F statistics used for testing main effect and interaction effects in ANOVA. So these are some works done by Tiku and Sineglu gave an analysis of in the framework of two-way classification models in experimental designs when the error follows the generalized logistic distribution by adopting the procedure of modified maximum likelihood. They obtain efficient and robust estimators of the parameter defined F statistics for testing main effects and interaction effects, and found that the methodology developed gives accurate results besides being easy theoretically and computationally. Again, Sineglu 2005 has investigated the robustness of 2 to the power k factorial experiment when error follows variable distribution. They again developed robust and efficient estimators of the parameters in 2 to the power k factorial experiment and defined F statistics based on MMLE for testing main and interaction effects. They also found that these tests have high power and better robustness properties as compared to the normal series solutions. Again, 2012 developed the MMLE procedure for the analysis of design of one-way elimination of heterogeneity, two-way elimination of heterogeneity, and for factorial experiment when error follows T family of symmetric distributions. Yadav 2013 developed the methodology for 2 to the power k factorial experiment when error follows generalized logistic distribution, and it performs well over the usual least square estimation-based procedures. In Selig et al. 2015 derived estimators of the model parameters of one-way ANOVA by using the maximum likelihood and modified maximum likelihood methodologies. A new test statistic based on these estimators were proposed for testing the equality of the treatment effects when the distribution of the error term is skew normal, which covers the normal and normal-like distribution with different skewness and kurtosis value. Now, in this present investigation, logistic distribution has been considered, but here we are considering the factorial experiment where the factorial experiment is asymmetric. That means each factor may have different labels. For that, a case has been considered where 3 factors, suppose A, B, and C have been taken, and factor A has 2 labels and factor B and C have 3 labels. In unblock situation, the statistical model for such experiment is given below. So for this case, where here error follows generalized logistic distribution, its functional form is given here. So from this, considering the logistic error and the model I have shown earlier, we derived the likelihood function for that, and again log likelihood function, and then again we are incorporating here order statistics because this is a summation term is invariant for this order statistics, so we can easily incorporate these into the expression, and then we here we find a non-linear term in the expression, this e to the power minus z igul upon 1 plus e to the power minus z igul. Let us consider a gz igul, and for obtaining the solution of the method given by Tico and Suresh 2092, by expanding log linear function using Taylor series is applied for obtaining the estimates of the parameters. So here for we applied Taylor series expansion in this particular function gz igl, and we obtain the normal equations. Here we have used this Taylor series expansion up to 2 terms, and here this del L we are obtaining here that expression of TL upon 1 plus e to the power TL whole square. So again this TL is given with this expression expectation of Zijun, and that can be obtained by this expression, because although the table has the expected values of TL is given by Balakrishnan and Leong 1988, but obtained from the equation we can obtain from this equation also. The approximate values instead of exact value does not adversely affect the efficiency by MML estimators in Eigen 2001. So we are going to this take this del L term, which is this one, and this gamma L term in our estimation of our parameters. So the final estimate of the parameters are obtained like this, and this.
So you have to wind up in 2 minutes now.
Okay, ma'am. So these are the parameter estimates, and now using those del L terms, we are obtaining the treatment totals, weighted treatment totals like that, and based on these treatment totals, we have calculated this sum of the squares and F statistics. So an empirical study has also been done. We have generated a data for 2 into 3 square factorial setup for different parameter values for theta equals to 0.5, 1, and 2. And then we have analyzed that data using our methodology. We have developed a SAS code for that, and we find the F statistics and their sum of the square and mean sum of the squares like this. So the conclusion part is that 2 into 3 square factorial experiment has been taken, and MML estimates of all the effects, main effects, interaction, and the estimate of error variance has been obtained. These MML estimates are efficient under non-normal error distribution and asymptotic to the maximum likelihood estimates. The Gatras have been obtained, and sum of the square and F statistics have been obtained. So an empirical study has also been done. And based on that, we have obtained this F star statistic. Yeah, so these are some references. Thank you.
Okay, thank you. Participants, if you have any questions, please ask. Any questions for Sunil, sir? Fine. Thank you, Sunil. I will invite the second speaker of the day, P. Sheshu Babu and Afd Model. Are you present, sir, now? P. Sheshu Babu, are you present? Fine, we move on to the next speaker, Nch Srinivasa and Bhattacharylu, sir. Are you present, sir?
Yes, madam, I am present.
Yes. Nch Srinivasa, sir, please present your screen. Your topic is estimation of missing responses in design and analysis of experiments with EM algorithm. Please share your screen.
Now is it
No, sir.
yeah, 1 minute, madam. Okay, madam.
Yes, yes. We can see your screen, sir. Please start.
Yeah. Good morning, all of you. So, to my name, myself, Dr. Kuncham Srinivas. I'm going to present the topic estimation of missing responses in design of analysis of experiments with EM algorithm. So, I'm going to cover what is the expected maximization algorithm, some introduction of incomplete black designs, and so I'm going to explain the derivations of normal equations to estimate missing values using EM algorithm in BIVD, as well as response surface design model with example. So, what is the procedure for using expected maximization algorithm? There are mainly 4 steps. So first of all, we can consider the statistical model with a set of observed random sample that satisfies the model. And first of all, evaluate the likelihood function for observed sample and find out the log of likelihood function. Choose some initial values for the parameter in the model and evaluate the expected value of log likelihood function using initial value. Then evaluate the improved version of the parameter that maximizes the expected value of log likelihood function, and repeat the above 2 steps until unless it will the 2 iterations differences is very less. Now, how to derive the normal equations by using a EM algorithm? So let us assume that y is a vector like y1, y2 up to so on yn minus m, and the second part is yn minus m plus 1 to yn, with the vector of n responses with n minus m known and m missing responses. Assume expected value of y equal to mu y, that is equal to x beta. The general linear model for experimental design can be written in the form of y equal to x beta plus epsilon. The assumed at m design points responses are missing, then the model can be written in the form of in this format. Then where yn minus m is the vector of known and ym is the vector of unknown observations. The same way xn minus 1 and xm are the corresponding partitioned design points, known and unknown responses. The derivation of normal equations can be using the likelihood function can be getting in the form of this. The normal equations to be estimate the parameter beta as well as sigma square and missing responses yu. So those are m can be obtained using maximum likelihood method by solving these 3. And mainly in EM algorithm, there are 2 steps are there. One is the expectation step. Second one is the maximization step. In the expectation step, we can expect the log likelihood and the conditional expectations of missing observations obtained as these 2 equations. And after getting up the values, we can maximize the parameter by substituting whatever expected values. So minimizing the residual sum of square at each step using the normal equations obtained through the each step, and MLE by the considering initial guess or missing values using the following the recurrency normal equations. That is, so here we are looking these equations. So let us quickly remind what is incomplete block design. If in a block the Let us the arrangements of V treatment in B blocks, each of plot sizes K1, K2 up to 7 KB, and treatments are replicated R1, R2, R3 up to 7 RV blocks, and N1 pairs of treatment of first associate occurs in lambda 1 block, N2 pairs of treatments of second associate occur in lambda 2 blocks, and NM pairs of treatments of EM associate occurred in lambda M blocks. Then the resulting design is said to be a general incomplete block design. And suppose V treatments have to be compared and B blocks are available. Let Ki denote the number of plots in the ith block and Rj the number of plots receiving the jth treatment. If n is total number of plots, then we can write as summation of I is equal to 1 to V, Ra equal to summation J is equal to B, Kj. The statistical linear model for BIBD can be expressed in the form of Y is equal to X beta plus epsilon. This can be written in the form of matrix. This is a matrix form we can write. The response value Yij is existing if the ith treatment occurs in the jth block only. But out of VB, Yij's are responses are existing for VR equal to BK equal to N, where mu is the general mean, alpha is the effective due to ith treatment, gamma j is the effective due to jth block. Then here the x dash x max can be expressed in the form of this. Then beta hat can be calculated using the normal equations. For the same thing, if you apply the EM algorithm for BIBD, so the BIBD can be written in the form of for missing and observed values. So this is the equation in the matrix form we can write to yn minus m, ym is equal to xn minus m, xm, beta plus. So the error term, whatever. The where yn minus 1 is a vector of n minus m known observations, ym is a vector of m missing observations, and xn minus m is a part of design points corresponding to the now, and xm is a corresponding to the missing observation design point. Then error term partitioned as accordingly. So here, let us consider the problem of estimating the parameters and missing observations using expected maximization algorithm. Then Y follows normal distribution with x beta and sigma square. Then we can obtain the likelihood function of this BIBD. Then we can
So
find
you
out the
have to
log.
wind up in 2 minutes, sir.
Okay. So in each step we can estimate the parameter value, and M step we can maximize the parameter value by substituting the estimated values. So this is a final iteration. The iteration of the estimated parameters can be expressed in the form of this. So this is one of the example. Can have Z, Y, X is our missing observations. We can estimate. So these are the estimated value at the 30th and 20th and 22nd iterations. These we can get. The same thing we can apply for response surface design model also. So in response design model also can be expressed in the form of log of likelihood function. So in each step we can obtain the estimated values as well as parameter values. And substituting each and every iteration, we can estimate parameter value as well as maximize the parameter values. So this is another example for the first order response design model. So here there are two missing values. So these two missing values can be estimated. So these are the matrix we can estimate by initially we can substitute to 0 or whatever arbitrary values randomly we can take. So these are the estimated values. So if we consider the least square method, then the least square method is slightly different from EM algorithm. So these are the references.
Thank you, Srinivasa sir. The participants, if you have any questions for the speaker. Do we have any questions? Thank you, Srinivasa sir.
Thank you,
Now,
madam.
declare
Thank you.
this session as closed. Thank you, presenters and participants, for joining the session. Over to you, organizers.
Thank you, madam. It is a great pleasure to me to introduce actually the Professor Ranjita Pandey. She is from the Department of Statistics, University of Delhi. And she is worked as a senior grade assistant professor in the University of Delhi from 2005 to 10 and associate 2010 to 13 and professor from since 2016 onwards. And her major area of the research is theoretical and applied Bayesian inference and lifetime distributions, time series models, demography and imputation methods, ecological modeling. And she is the member in various statistical societies like Indian Society for Probability and Statistics, Indian Bayesian Society, and Indian Science Congress, and Human Ethics Committee, and also she is Associate Executive Committee member of ISPS. And she is a committee for the courses of post-graduation in BSc Honors Studies and other various other committees. And also she has published many of the papers and books in various the other journals also. I'm thankful to you for accepting our invitation and chairing the session, madam. Thank you very much, madam.
Thank you, sir, for giving me this opportunity. Thank you.
Now, all the participants are requested to stay in the same hall here for the next actually award ceremony is there in the same hall. So all members will comes to either hall B, hall C, and hall D will comes to hall A. I request all members who are in hall B, hall C, and hall D also join in a hall A.
So are the sessions going on in other halls or
No, because at 12 o'clock it is a common session.
Okay. Okay, that means are we ready to start the award ceremony now?
Yeah, we are ceremony at here, but other sessions the closed or not that we have to check it once and then I will confirm, sir.
Yeah, please confirm after that. Yeah.
Because B, C, D, they have to close it, the contributory papers, if any are there. If there is one or paper are there, then we'll post to the evening and we will continue this one such that because it is a session.
Yeah, please confirm.
Okay, sir.
Call number 1.
Namaste, namaste, namaste.
Namaste, namaste.
Namaste, madam. Namaste.
Namaste.
Namaste, yeah. So,
Namaskar, sir. Namaskar.
I was looking for you only. Okay, you are there.
Yeah, I am here. Yeah.
Yes.
Hello.
So, Reddy sir is there, Neha is there, and all the, I think all the awardees are there. I don't see the name of Professor Arup Bose. I don't know whether.
Sir, this is Jayashree, sir.
Yeah.
Sir, we don't have sir's contact number. We contact sir over mails.
I don't know. I hope he is informed about this. I don't know that he forgot.
Sharda Bhatt from Harvard.
Namaskar, Anagal. David Anagal.
Namaskar.
Professor Reddy, I think you have informed Arup Bose, right, that today he has to join for the award ceremony?
That I think, yes, sir, we have already, because we have sent Neha Garga, she has sent a mail.
Excuse me, sir. I have sent only the citation readers.
Citation, okay.
No, I have sent mail only the citation readers only.
Okay, anyway, once everybody is ready, we will start the program in between. Let us see whether he joins.
So Bala, meanwhile, if you have any contact number, just to contact Arup.
No, I don't have his phone number.
Maybe the mail ID. I think Jayshree is having the mail contact number.
No, she doesn't have. That is what she told
No,
us.
sir, I don't have contact number, sir.
Anyway, I think once we start, I think again I'll try through some other source. I don't know. Professor Prakash Rao has his contact number, sir.
Well, let me see. I don't think I have.
Okay.
But a quick email can be sent. So if he is there on some system, he may still see that.
I don't have
LAN
his
number
number.
is available. His LAN number, I don't know whether office or house. LAN number is available. 033.
1 second.
257.
Wait. 033.
2575. 3409.
3409. Let me start.
Office or home, I don't know. Office, then it won't be working.
Today is Sunday.
Okay.
I think it must be office number. It's ringing, but no response.
I request all the dignitaries to please be on mute, sir. Whenever your turn is there, you please unmute. There will be a disturbance.
Sir, we have some number. Let me try with that number, sir. 1 minute, sir.
Yeah. Anyway, we will. If all others calls are free, we will start the program in between. Also, if he joins, we will.
Balakrishna, I think I can give you his number. Just 1 minute.
Okay.
9830-496
is 98304.
Yes, sir. I am calling to the same number, sir.
96250. Oh, I see.
Calling.
Okay.
Calling to the same number, sir.
Okay, please call.
Yes, sir.
Because he's a member of this society, so I have his directory.
Okay, that is a good thing. I don't know. Somehow there is some communication slip, I think. Let us see. Hopefully, we'll get him. Professor Bhattacharylu, did you check about the other two halls? I mean, B, C.
Sir is joining, sir.
Okay, good, very good. Okay. Now about the other halls, B, C, D, are they free now?
They are closed.
All sessions are closed?
Yeah, all hall B, all C, all D, they came to hall A.
Okay, very good. So about Professor, let me wait for Professor Jayasree's response.
Jay Sri madam, if you say yes, we'll start.
Yeah. He has joined. Good. He has joined. Neha madam, you are ready now?
Yes, sir.
Yeah. Reddys are also ready. Okay. So shall we start the program?
Yeah, please.
Okay. So good afternoon, everybody. So welcome you all to this award ceremony. This is an important event as far as ISPS is concerned, where you honor the award winners as well as the ISPS fellows for the year 2021. Now I invite Professor Rashekar Reddy to chair the session and conduct the proceedings.
Thank you, Balakrishna. Good afternoon to everyone present here. I welcome all to this award ceremony of ISPS. It is my honor to warm welcome to all the awardees, Professor BLS Prakash Rao Garu, Professor Arup Bose, Professor K. Srinivasa Rao, Professor K.K. Jose, Professor David Anagal, Professor Somesh Kumar, Professor Sudesh Patanvalli, CR Gold Medalist, and Executive President of ISPS, Executive Members, citation readers, participants, and invitees, and Senior Professors, Professor J.V. Deshpande, Professor Velaswamy, Vasdeva, Professor Tangaraj, and other members of this award ceremony function. So an idea illuminates and will pave the way for great inventions and wisdom. The efforts of our pioneers in ISPS never goes waste. What enjoying the facilities today are due to the efforts of our seniors. As a part of ISPS annual convention, the seniors introduced to honor fellow award of ISPS in 2004 in recognition of his outstanding contribution towards the promotion and advancement of probability and statistics. The first recipient, Professor B.R. Bhatt and Professor C. Hari, has received the fellow award. From that onwards, later with the help of the donors, so we initiated Distinguished Statistics Award in 2011. 2014, we started first. We have to give. The award has given to Professor Debashish Kundu, and later we also introduced Professor C.R. Rao Lifetime Achievement Award in 2016. The first one which we have given to Professor A.M. Mathai. So there are still now there are 7 more awards like Professor K. Srinivasa Rao Researcher Award last year he has initiated, and likely this year also we have received Professor M.N. Deshpande Memorial Prize. This will come from next year onwards. So I am grateful to all the donors who are coming forward and giving their money. Apart from that, we are also conducting some best research papers. For that, Professor A. Mathai has donated 5 lakh rupees for one endowment lecture and one cash prize award for a best research paper. Similarly, Seturaman has donated 1 gold medal for young statistician. B.K. Kale has donated this prize money for every year 1,500 rupees. Professor M.N. Gopalan has donated every year 2,500 rupees for the prize money for the best research paper. Like that, so that the MSc student project competitions are also we are conducting every year as incentive. So now we are happy to conducting the part of ISPS competition events in ISPS. So now with this, now I request our Dr. Neha Garg, because of she is now the program coordinator, and she is now working in associate executive member of ISPS and presently working in IGNO at Delhi. So now I request Dr. Neha Garg as to anchor the events. So thank you. Over to Neha.
Yeah, thank you so much, sir. Namaskar and a very warm good afternoon to everyone. The Honorable President and the Executive Committee members of ISPS, conference organizers, Department of Statistics, Osmania University, Hyderabad, distinguished dignitaries and dear participants. I, Dr. Neha Garg, on the behalf of the Executive Committee of ISPS and on my personal behalf, wholeheartedly welcome you all. It is my privilege to welcome everyone to this 41st award ceremony of ISPS. Today is a day of honor, a day of appreciation, a day of encouragement, a day of motivation, and a day of felicitation of our ISPS awards winners. Today, I feel very delighted and honored to be with you all to recognize the accomplishment of our awardees. For ISPS, rewarding its fellow is extremely important. Now let's acknowledge and celebrate their moment of glory, as has been the custom of Indian Society of Probability and Statistics for many years. So without further delay, let's start the ceremony. Now it's given me immense pleasure to announce the name of Professor C.R. Rao Lifetime Achievement Award, which goes to Professor V.L.S. Prakash Rao, INSA Senior Scientist, C.R. Rao, Advanced Institute of Mathematics, Statistics and Computer Science, Hyderabad. Many congratulations to you, sir. Now, I would like to request Professor Sarda Bhatt from the Department of Statistics, Karnataka University, to share some of the Professor Prakash Rao's achievement from his long list of credentials. Over to you, ma'am.
Namaste, everyone. Thank you, organizers, for giving me this opportunity to read the citation of Professor B.L.S. Prakash Rao. Thank you, Neha. I am very happy to read the citation of Professor B.L.S. Prakash Rao, recipient of Professor C.R. Rao Life Achievement Award. Bhagavatula Lakshmi Surya Prakash Rao, aka B.L.S. Prakash Rao, is an Indian statistician. He was born on October 6, 1942 in Porumamila, Kadapa district, Andhra Pradesh. He completed his BA honors degree equivalent to MA in mathematics from Andhra University in 1960 with a record-breaking performance and moved to the Indian Statistical Institute, Kolkata, where he completed his MStat degree in statistics in 1962. He graduated with a PhD in statistics from the Michigan State University, USA, in 1966 under the supervision of Professor Herman Rubin. Hope I am clear. Professor Prakash Rao's major research interests are in the areas of stochastic processes, stochastic inequalities, characterizations of distributions and limit theorems in probability, and in the areas of parametric and non-parametric inference and inference for stochastic processes in statistics. Professor Prakash Rao has published more than 300 articles in national and international journals and had authored and edited 18 books in the areas of statistics and probability. He has reviewed more than 70 books and delivered more than 100 invited lectures in national and international conferences. He has visited several universities all over the world during more than 30 academic visits abroad. His works were cited in more than 25 books, and he had more than 5,000 citations of his articles till now. Professor Prakash Rao was the editor-in-chief of Sankhya Series A and Sankhya Series B during the years 2012 to 2015, and was a member of the editorial boards of several national and international journals over the years. Professor Prakash Rao worked at the Indian Institute of Technology, Kanpur, during 1968 to 76, and later moved to Indian Statistical Institute, New Delhi. He was a professor and later distinguished scientist at the Indian Statistical Institute during the period 1976 to 2004, and was the director of Indian Statistical Institute during 1992 to 95. He has also held visiting professorships at the University of California, Berkeley, University of Illinois, University of Wisconsin, Purdue University, University of California, Davis, and University of Iowa in USA. He was Jawaharlal Nehru Chair Professor during 2006 to 8, and Dr. Homi Bhabha Chair Professor 2008 to 12 at the University of Hyderabad, and Ramanujan Chair Professor during 2012 to 2017 at the C.R. Rao Advanced Institute of Mathematics, Statistics, and Computer Science, Hyderabad. He is presently an emeritus professor of the Indian Statistical Institute and an INSA senior scientist at C.R. Rao Advanced Institute of Mathematics, Statistics, and Computer Science, Hyderabad. Professor Prakash Rao received the Shanti Swarup Bhatnagar Prize for Science and Technology in Mathematical Sciences in 1982 from the Government of India, Outstanding Alumni Award from the Michigan State University in 1996, and the National Award for Outstanding and Meritorious Work in Statistics in the memory of P.V. Sukhatme in 2008 from the Ministry of Statistics and Program Implementation, Government of India. Professor Prakash Rao was selected for the Distinguished Service Award by the Mathematical Association of India in 1999 and was awarded Lifetime Achievement Award by the Indian Association for Reliability and Statistics in 2015. He is an elected member of the International Statistical Institute 1982, an elected fellow of the Institute of Mathematical Statistics, USA 1983, Indian National Science Academy 1984, Indian Academy of Sciences 1992, National Academy of Sciences 1992, and the Andhra Pradesh Academy of Sciences 2012. The ISPS is privileged to honor and confer the Professor C.R. Rao Life Achievement Award to Dr. BLS Prakash Rao as a renowned scientist, an inspiring teacher, an able researcher, a profound statistician, and a great humanist at this 41st Annual Convention of Indian Society for Probability and Statistics, ISPS, jointly organized by Department of Statistics, University College of Science, Osmania University, Hyderabad, Telangana, India on Sunday, the 13th March 2022. Indian Society for Probability and Statistics, ISPS, 13th March 2022.
Thank you so much, madam, for taking time to read the citation. Now I request sir to bless us with few words of encouragement. Now I request to Professor Prakash Rai sir to share his thought with us.
So I would like to thank at the outset Professor N. Balakrishna, President of ISPS, Professor Rajsekhar Reddy Garu, Honorary President of ISPS, Professor Malik, Secretary of ISPS, and Professor Srinivas Rao and other members of the Executive Committee, and Professor Jayashree and Professor Bhattacharylu of Usmania University, and all the colleagues for honoring me with this Lifetime Achievement Award. I really appreciate this award that's going to be presented. And as in a few minutes, I can only tell you that I started my statistics journey at the Andhra University in 1957-60 when I was a student of mathematics honors. and statistics was just one subject. Then later on, I moved to ISI, and I learned more directly from Professor C.R. Rao. I was a student in the first batch of MStat degree. And then later on, he was my guru most of the time. But I went abroad to do PhD under Professor Herman Rubin. And then I returned again. I spent some time at IIT Kanpur and then went to ISI Delhi when Professor Rao moved to ISI Delhi. And he has been my inspiration for the last several years. In fact, even today, I'm editing a special issue in honor of him for Journal of Quantitative Economics, which will be released sometime at his 102nd birthday. So C.R. Rao has been my advisor throughout, and it's a great honor to receive a Lifetime Achievement Award in honor of him from the ISPS. And I appreciate with all the greetings and help and ideas from all the colleagues for me to achieve and to receive this award. Thank you very much.
Thank you so much, sir. Your commitment reflects the endless hours you have spent in achieving the target. Many congratulations, sir.
Thank you very much. Thank you.
No one will disagree with the fact that excellence is a result of sincere effort, intelligent direction, skillful execution, and vision to see obstacles as opportunities. So coming up next is a fellow of ISPS. This year, ISPS is announcing 4 fellows of ISPS. It is privileged to honor and confer the Fellow of ISPS award to Professor Arup Bose from the Indian Statistical Institute, Kolkata. Sir, many congratulations. Now I request Professor Kirutika from the Department of Statistics, Pondicherry University, to take over the screen and recite the citation for the sir.
Good afternoon to everyone. Dr. Arup Bose is a professor at the Indian Statistical Institute since 1995. He has been holding a J.C. Bose National Fellowship since 2009. He is an elected fellow of the Institute of Mathematical Statistics, USA, Indian National Science Academy, New Delhi, Indian Academy of Sciences, and National Academy of Sciences. He is also a winner of the Prashanta Chandra Mahalobis Medal, INCA, Shanti Swarup Bhatnagar Award in Mathematical Sciences, the National Award in Statistics, and the Young Researcher Award of IISA USA. His current primary research interests are in the large dimensional random matrices, free probability, and high dimensional statistics. His earlier research areas include principal agent theory, resampling, non-parametric asymptotics, U statistics, estimates, second order properties of sequential point and interval estimates, and statistical estimation in nonlinear parametric diffusion processes. With more than 65 research collaborators, he has published over 150 articles in leading journals of statistics, probability, and economics and econometrics. He has authored 5 books: Random Matrices and Non-Commutative Probability, Patterned Random Matrices, Large Covariance and Autocovariances Matrices with Monica Bhattacharylu, and Random Circulant Matrices with Kaushik Saha, and U Statistics, Estimates, and Resampling with Sigandu Chatterjee. He has been on the editorial board of several journals and is currently an editor-in-chief of Random Matrix Theory and Applications. He has served on the editorial board of Sankhya during 1993 and 2007, the last 6 years of these as an editor. The ISPS is privileged to honor and confer the Fellow of ISPS award to Dr. Arup Bose, a renowned scientist, an inspiring teacher, an able researcher, a profound statistician, and a great humanist at this 41st Annual Convention of Indian Society for Probability and Statistics, jointly organized by the Department of Statistics, University College of Science, Osmania University, Hyderabad, Telangana, India, on Sunday, the 13th March, 2022. Very congratulations, sir.
Thank you so much, madam, for reading the citation. Now, I would like to invite Professor Arup Bose for his inspiring words.
Thank you very much for this honor, and it's a really great honor. And I thank especially Professor Balakrishna, who approached me saying that I might receive this honor. And it's any honor is always an encouragement to do better. So I'll strive harder to work with my colleagues and with my students and serve the cause of probability and statistics. I also want to recall that because Professor Prakash Rao is here, and he has been a great supporter of me. For example, when he was the director of the institute, that is when I got on the editorial board of Sankhya. My PhD thesis, the first two papers were directly extension of his work in diffusion processes. So I remember that very fondly. And people like him are always supportive of juniors like me. So with those words, thank you very much for this great honor. And I'll strive to be worthy of it. Thanks.
Thank you so much, sir. Your dedication is really inspiring. The higher the sense of accomplishment when you eventually achieve something, the harder you work for it. Our next fellow of ISPS is Professor K. Srinivasa Rao, Principal, Andhra University College of Science and Technology, Visakhapatnam. Many congratulations to you, sir. May I now request Professor Ranjita Pandey, Department of Statistics, University of Delhi, to read the citation for sir.
Thank you, Neha. Citation for Professor K. Srinivasa Rao, sir, Fellow of ISPS. His passion towards statistics and data sciences is unmatchable. Professor Rao has joined Andhra University as Assistant Professor in the year 1985, and he was elevated as Senior Professor. He has 37 years of experience in teaching, research, and consultancy. With strong foundations in mathematics and statistics, he has pioneered several new concepts such as independent communication, network models with dynamic bandwidth allocation, new symmetric distribution, family of bimodal distributions, generalized Laplace distribution, generalized logistic distribution, further generalization of generalized Gaussian distribution, merged distributions and their applications in image segmentation, face recognition systems, skin color segmentation, economic production quantity models with random production, hybrid communication network models with optimal scheduling, optimal control charts with random in-control times, manpower planning, models with heterogeneous bulk recruitment, heterogeneous queuing models. Professor Rao got Distinguished Statistician Award from ISPS in the year 2016. He is a Fellow of AP Academy of Sciences, conferred in 2010, Fellow of ORSI in 2016. Dr. Rao has guided 55 students for PhD degrees. He has published 237 research papers in various international and national journals of high repute. He has successfully completed 13 research grants funded by Government of Andhra Pradesh UGC, DST, Ministry of Family Welfare. He has conducted more than 28 international conferences, seminars, workshops, training programs. He has delivered 159 endowment, keynote, plenary invited lectures in various conferences and seminars. He has published 3 patents in image segmentation, skin color identification. He has served as lead consultant for TCS Bengaluru, Satyam Engineering Services Hyderabad, ADB Solutions Hyderabad, Bharat Heavy Electricals Limited Hyderabad, Aurobindo Pharma Hyderabad, Dr. Reddy's Laboratories Hyderabad, Sagar Cements Hyderabad, Visakhapatnam Port Trust Visakhapatnam, and Lucas TVS Chennai and several other corporates. Professor Rao was elected President of Indian Society for Probability and Statistics during the years 2019 and 2020. He was elected Vice President of Operation Research Society of India during the periods 2011-12 and again in 2014-16. He was elected Chief Editor of JISPS during the period 2010 to 2018 and Associate Editor for OpSearch during 2014 to 2018. He also served as Vice President Operations of JBS, an MNC company during 2004-06, while on loan from Andhra University. He has written a book on model-based color image segmentation. Dr. Rao served at Andhra University in various capacities as head of the Department of Statistics for 3 times, Chairman, Board of Studies in the Statistics, ISO Coordinator, and Management Representative during the period 2006 to 8. He is Coordinator of UGC, Dean R&D, Chairman, NAC Steering Committee, and Chairman, Faculty of Sciences, Andhra University, Convener, APRCET for the years 2018 and 19. Presently, Dr. Rao is serving as Member Secretary, APSET, SET during 2015 and Principal, Andhra University College of Science and Technology, Visakhapatnam since 2020. The ISPS is privileged to honor and confer Fellow of ISPS Award to Dr. K. Srinivasa Rao, a renowned scientist and inspiring teacher, an able researcher, a profound statistician, and a great humanist at this 41st Annual Convention of Indian Society for Probability and Statistics, ISPS, jointly organized by Department of Statistics, University College of Science, Osmania University, Hyderabad, Telangana, India, on Sunday, the 13th March 2022. Congratulations, sir.
Thank you, madam, for reading the citation. May I now request Professor K. Srinivasa Rao to oblige us with few words of encouragement. Sir, please unmute yourself.
At the onset, I thank the President of ISPS, Professor Balakrishna, and the Honorary President, Professor Rajshekar Reddy, and Secretary S.C. Malik, and all other executive members and other members of ISPS, and also the organizing committee members of this conference, Jayashree and her team, for confirming this honor. I feel it is a privilege for me to accept this honor, and it made me to take the responsibility of further strengthening my skills in research and consultancy. And I thank all my students, particularly for who have encouraged me to take the research works, and all my teachers, especially in this endeavor. And I thank all the people who are responsible to confer this to me. My association with ISPS is from 1984. When I was a scholar, I attended the first of my conference in Kerala University of that in 1984. Thereafter, I have been associated with ISPS in several portions. Now I feel this is an honor conferred to me for the works that I have done in the works of statistics as well as propagating the statistics. I thank everyone for the given opportunity. Thank you.
Congratulations, sir. Thank you, sir, for your motivating and thought-provoking words. The cornerstone for one's achievement is hard work, dreams, and determination. Our next fellow of ISPS award is Professor David D. Hanagal, Honorary Professor, the Symbiosis Statistical Institute, Pune. Many congratulations to you, sir. Allow me to request Professor G. Jayashree from the Department of Statistics, Osmania University, Hyderabad, to introduce Professor Hanagal.
It's a privilege for me to read the citation of Professor David Hanagel. Dr. David Hanagel is honorary professor at the Symbiosis Statistical Institute, Symbiosis International University, Pune, India. He is a retired professor and head at the Department of Statistics, Savitribai Phule, Pune University, India. An elected fellow of the Royal Statistical Society, UK. He has authored 5 books, 6 book chapters, and published over 135 research publications in leading journals. He guided 9 PhD students and 1 MPhil student in different areas of statistics, namely reliability, survival analysis, frailty models, repair and replacement models, software reliability, and quality loss index. He has delivered more than 100 invited talks in many national and international platforms of repute worldwide. He also has worked as a visiting professor at several universities in the USA, Germany, and Mexico, and delivered a number of talks at conferences around the globe. He is working as editor-in-chief, associate editor, and editorial board member of several reputed national and international journals. He is chairperson, subject expert, and advisory committee member in several UGC committees. He is a National Assessment and Accreditation Council assessor from UGC. Sir is also a subject expert in Board of Studies committees of several universities. Sir is a governing council member, executive council member, and life member of several statistical societies, organizations, and associations, and was also past vice president of ISPS during 2017 to 2018. His research interests include statistical inference, selection problems, reliability, survival analysis, frailty models, Bayesian inference, stress strength models, Monte Carlo methods, MCMC algorithms, bootstrapping, censoring schemes, distribution theory, multivariate models, characterizations, repair and replacement models, software reliability, quality loss index, and non-parametric inference. With over 35 years of research experience and over 40 years of teaching experience, he is an expert on writing programs using SAS, R, MATLAB, Minitab, SPSS, and SPLU as statistical packages. He was born on 16th April 1957 at Gadag, Karnataka state, and was educated in Gadag, Dharwad, and Pune. After completing his MSc from Karnataka University, Dharwad in 1980, he joined Bharatiya Vidyapith Pune and later Savitribai Phule Pune University, Pune in 1988. The PhD degree was awarded to him in 1992 from Savitribai Phule Pune University under the guidance of Professor B. Kale. Sir, he worked in several positions at Savitribai Phule Pune University and retired in 2017. The ISPS is privileged to honor and confer the Fellow of ISPS Award to Dr. David D. Hanagel, sir, a renowned scientist, an aspiring and an inspiring teacher, an able researcher, a profound statistician, and a great humanist at this 41st annual convention of Indian Society for Probability and Statistics jointly organized by Department of Statistics, University College of Science, Usmania University, Hyderabad, Telangana, India, on Sunday, the 13th March, 2022. Congratulations, sir, and thank you for giving me this opportunity.
Thank you, madam, for citing the achievement of Professor Hanagar. Now I would like to request sir for sharing few words.
Good afternoon to all of you. I thank ISPS, especially the Honorary President, Professor Rajshekhar Reddy, President of ISPS, Nch Bhattacharylu, Secretary, Professor S.C. Malik, and other committee members, EC members, organizing committee of the ISPS from Usmania University, and those who are involved in the conference for honoring me with a fellow of ISPS. I have been associated with ISPS for a long time, maybe more than 30 years. ISPS has grown a lot and became one of the productive statistic organization in India. First time I attended the ISPS conference in 1991, held in Usat, Cochin. That time there were a lot of participants from Pune. Myself, Balakrishna was there, the present president, R.P. Suresh, Professor Kunte, Mohan Kale, and several other research students were there. And Professor Kunte was leading us all the time during the conference. And that was a very good occasion during that time. That time, I think Professor B.R. Bhatt was the president of ISPS. Then he moved to Botswana, then Professor B.K. Kale became president, and so on. I am attending the ISPS since 1991, and the ISPS committee, such as I worked in the ISPS as a committee member, as a vice president, EC member, and convener of A.R. Kamath Award Committee, and so on. I thank all the persons involved in cooperating all these activities during my time when I was working out in these committees. I have been associated with ISPS very long time and also ready to serve ISPS in future also. I once again thank ISPS for honoring me with this fellow of ISPS. Thank you once again. Thank you to all. Thank you.
Thank you so much, sir. I'm sure your experience will help us stay motivated. Many congratulations, sir. The harder you work for something, the greater you feel when you finally achieve it. With deep admiration, I announce the name of Professor K.K. Josh, Honorary Director, Mahatma Gandhi University, Kottayam, who is receiving the Fellow of ISPS Award. Many congratulations, sir. Now I request Dr. Upal Shah, the Department of Statistics, the MS University of Baroda, to read the citation for sir.
Thank you, Dr. Neha. I'm thankful to the ISPS body for giving me this opportunity. It's really a matter of great pleasure and honor for me to read the citation for Dr. K.K. Josh, sir. Dr. K.K. Josh Kanichukattu, born on 3rd July 1957 at Ilanji, a small rural agrarian village in Ernakulam district, Kerala, had his studies at Ilanji, Kuravilangad, Palai, and Trivandrum in Kerala, India. His parents were Kurakutti and Annamma, small-scale farmers. He passed MSc Statistics from University of Kerala in 1980 with University first rank and joined St. Thomas College, Palai as a lecturer in statistics in December 1980. He was awarded PhD in statistics by the University of Kerala under the guidance of eminent Professor Dr. R.N. Pillai in 1995. He became associate professor and head of the Department of Statistics at St. Thomas College, Pillai in June 1997. He was instrumental in starting MSc Biostatistics under UGC Innovative Program in 2005. He was appointed as principal on 21st April 2009 and retired from regular services on 31st March 2014. After retirement, he served as professor and head of the Department of Statistics at the Central University of Rajasthan during 2014-15. He was awarded KSCSTE Emeritus Fellowship during 2015-2018. He was honorary president of Kerala Statistical Institute, Thiruvananthapuram during 2015-18 and served as honorary director of the Department of Biostatistics at St. Thomas College, Pillai during 2018-20. He was appointed as an honorary director of the School of Mathematics and Statistics and School of Data Analytics at Mahatma Gandhi University, Kottayam in June 2020. Dr. Jose is an eminent academician who had rendered more than 40 years of meritorious service as a reputed principal, professor, and head of the department, teacher, researcher, and organizer. Dr. Jose has successfully guided 25 research scholars in their PhD work and published more than 150 research papers in reputed national and international journals. He has authored 5 research-level books and successfully completed 6 research projects sponsored by UGC, DST, MOSPI, etc. He had been organizing secretary of international and national conferences and workshops in connection with the annual conferences of ISPS, SSCA, and SSFA, etc., held at Pillai. He had been invited speaker, resource person for more than 150 national, international conferences, seminars, workshops, etc. He had visited various countries. Just a second. Am I audible?
Yes, madam.
Yeah. Please go ahead. Please go ahead.
He has visited various countries as invited speaker in international conferences. He was recipient of World Bank Travel Fund on ISI in 2011 and 2012. He had wide exposure in statistics and biostatistics fields. Dr. Jose served as the General Secretary and President of Kerala Statistical Association during 1994 to 2000 and 2000 to 2006 respectively, and organized over 200 quiz programs and regional seminars for popularizing statistics in Kerala. He was chairman of PG Boards of Studies of MSc Statistics, Biostatistics, and Actuarial Sciences at Nch University, Kottayam during 2006 to 2012. He was member chairman of examination boards of MSc, MPhil, PhD of various universities in South India. He was editor of Stars International Journal, executive editor of Journal of Kerala Statistical Association, and reviewer of many international journals. He was joint secretary of ISPS for 2 terms and hosted 24th annual conference of ISPS at Pillai in 2004 and was executive council member of SSCA and ISPS many times. Dr. Jose is an elected member of the International Statistical Institute, Netherlands, and a fellow of Royal Statistical Society, UK. He's a member of various professional societies like IMS, ISBIS, Informs, ISBA, ISMS, Bernoulli Society, ISPS, KSA, and the list is long. He has won the SB Award for Best College Teacher in Kerala in the year 2007. AIACHE Award 2008 for Most Innovative Teacher, and Professor P.V. Sukhatme Award for ISMS in 2012 for his significant contributions in teaching, research, and development in statistics and biostatistics. Many of his students are in IAS, ISS, etc. Ms. Lishamal Tommy, research scholar under his guidance, won Jen Timbergen Award of International Statistical Institute in 2007. He won the Sam Higginbotham Award of AIACHE for the Best College Principal in India during 2012-13. He was selected as Best Principal under MG University, Kottayam in 2010-11 and 2013-14. He was awarded FSMS Fellowship by the Indian Society for Medical Statistics in 2021 in recognition of his contributions to theory and applications of statistics in the biostatistical field. The ISPS is privileged to honor and confer the Fellow of ISPS Award to Dr. K.K. Jose, a renowned scientist, an inspiring teacher, an able researcher, a profound statistician, and a great humanist at this 41st Annual Convention of Indian Society for Probability and Statistics, jointly organized by Department of Statistics, University College of Science, Osmania University, Hyderabad, Telangana, India, on Sunday, the 13th March, 2022. Thank you so much. Over to you, Dr. Neha.
Yeah, thank you so much, madam, for citing the achievements of Professor K.K. Jose. Now I request sir for sharing few inspiring words, sir, please.
Thank you, ma'am. Hello.
Yes, sir.
Yes, sir. Please go ahead.
Okay. So, esteemed President of Indian Society for Probability and Statistics, Professor Nch Bhattacharylu, respected Chairperson of the program and Honorable President of ISPS, Professor Rajasekhar, General Secretary, Professor S.C. Malik, all members of the Executive Committee, then the organizers of the host of the 41st ISPS conference of the Osmania University, Professor Jayasri, and all faculty members, all senior professors, colleagues, and my dear friends of the Statistical Fraternity of India. I am extremely grateful to ISPS and its executive committee for presenting this award of ISPS fellowship to me. I humbly accept this prestigious award as a mark of recognition of my humble contributions to the field of statistics and related areas. My association with ISPS started from 1990 onwards, while I was a research scholar at the University of Kerala under my professor R.N. Pilli, who was treasurer of ISPS at that time. And I participated in the first ISPS conference in Pusat in 1991, then Pune and various other parts, centers in India. I have attended more than 20 annual conferences of ISPS. And I was very fortunate to host the 24th annual conference of ISPS at St. Thomas College, Pali, maybe the first time for my college. And I was also a member of the executive committee of ISPS and the assistant, the joint secretary of ISPS for 2 terms. And it was I remember with gratitude my professors, Professor R.N. Pillai, Professor K. Ramaswamy, who instilled my interest in statistics and to pursue research and teaching in statistics. I pay my tributes to the founders of the great founders of Indian Society for Probability and Statistics. And I have benefited a lot by attending the annual conferences and interacting with the great statisticians like Professor C.R. Rao and many others during ISPS conferences. Now the world has realized the power of data, and we are living in a data-driven world. All decisions are data driven, and it has led to the development of new disciplines like data science and data analytics. So statisticians are in demand all over the world. It should be considered as a threat to statistics. The statistics community has to become equipped to meet the challenges of big data, along with theory and applications. Statistical computing and data review are important in the present day situation. We have to change ourselves with advances in using softwares like R, Eigen, etc. So with these words, I accept this award and thank all of you. So may I wish you all a glorious future. Thank you. Thank you.
Thank you so much, sir, for your motivational remark. Many congratulations to you again. An award is a powerful mode to endorse the feeling of pride, a sense of accomplishment, and even joy. Now, let me take the pride to announce the ISPS Distinguished Statistician Award for the year 2021, which goes to Professor S.C. Malik, Department of Statistics, MD University, Rohtak. Many congratulations to you, sir. Allow me to invite Dr. D. Lalita Devi from the Department of Applied Statistics, Kasturba Gandhi Degree and PG College for Women, Telangana, to take over the screen and read the citation of the position holder.
Thank you, ma'am. Good afternoon, one and all. It's my privilege to present the citation of Professor S.A. Malik, a distinguished statistician at this wonderful event of 41st Annual Convention of ISPS Conference. Dr. S.A. Malik is presently working as Professor, Department of Statistics, MD University, Rohtak, Haryana. His field of research specializations are reliability theory, sampling, and applied statistics. He has teaching interests in the field of real analysis, measure theory, optimization techniques, complex analysis, probability theory, statistical methods, reliability theory, and stochastic processes. He has published 3 books in the field of real and complex analysis, and 205 research papers are to his credit. He has supervised 45 PhD and 30 MPhil students in the subject of statistics. Dr. Malik has been invited by various academic institutions to deliver talks and to present research papers at conferences, seminars, symposium, workshops held in India and abroad, including USA, UK, Portugal, Singapore, Germany, Hong Kong, France, Spain, Netherlands, Belgium, Austria, Italy, Japan, Switzerland, and Nepal. He is a reviewer of various journals, specifically for all journals in the areas of reliability, operations research, and statistics. Professor Malik has been a life member of various academic and professional bodies. Sir is a founder president of Indian Association for Reliability and Statistics, IARS, and also chief editor of the UGC listed journal IJSRE, being published by IARS. He has worked 3 times as elected member of section of Mathematical Sciences of ISPA. He has been associated with several universities in India as an outside expert in Board of Studies and at the Court and Academic Council. He has also organized various academic activities in the form of workshops, seminars, and conferences of national and international level. Sir has been appointed by the UGC as a member of Advisory Committee for SAP. He has completed successfully a UGC MRP on reliability modeling of computer systems. Recently, the Department of Science and Technology, DST, has awarded the prestigious project matrices to Dr. Malik for a period of 3 years. The ISPS is privileged to honor and confer the Distinguished Statistician Award to Dr. S.C. Malik, a renowned scientist, an inspiring teacher, an able researcher, a profound statistician, and a great humanist at this 41st Annual Convention of Indian Society for Probability and Statistics, jointly organized by the Department of Statistics, University College of Science, Osmania University, Hyderabad, Telangana, India, on Sunday, the 13th March 2022. Congratulations, sir. Thank you, Neha ma'am, for giving me this opportunity.
Thank you, madam, for reading the citation. Now, I would like to request Professor S.C. Malik to share a few words with us.
Yes, a very good afternoon, all of you. First, I would like to thank the entire ISPS community to give me a chance to achieve this award. Really, I'm very thankful to the President, Professor Balakrishna, the Honorary President, Professor Rajsekhara Reddy, and the members of jury who took decision to honor me, to recognize my contribution. I salute the entire ISPS community first. Then I dedicate this award to my research scholars who made me to achieve this award. Without the contribution of my research scholar, I was not in a position to get this award. Really, I'm grateful to all my research scholars. I'm also thankful to my university who provided me a platform to carry out the research activities, to do something in teaching in the subject of statistics. When I joined MD University Rohtak, Haryana, it was very poor condition of the subject statistics. No student was ready to opt this subject, statistics. They always offered mathematics at their priority. But now I'm happy to share with you that we are now in a position in Haryana, MD University Rohtak, that we have more than 50 students intake in our department. So all because of the efforts of my research scholars, my teachers, my university, and I tried my best to get this situation at the national and international level. Really, I'm very grateful to the entire statistical community, and really a very enjoyable moment for me. I accept this award, and for this, I'm also thankful to the organizers of this conference for providing this platform to the ISPS to honor one or more persons in order to recognize their contribution. So thanks all of you for giving me this chance. Thank you all of you. Salute to all you. Thank you, madam.
Thank you so much, sir, and many congratulations once again. Nothing can beat the feeling of discovery, something new for the first time, something that may have existed for thousands and thousands of years, but we never discovered before. This year, the ISPS is privileged to honor and confer the Professor K.S. Rao Best Researcher Award to Professor Somesh Kumar from the Indian Institute of Technology, Kharagpur. Many congratulations to you, sir. Now, I would like to request Professor Sadha Bhatt from the Department of Statistics, Karnataka University, to read the citation for this, sir.
I am very happy to read the citation of Professor Somesh Kumar, recipient of K.S. Rao Best Researcher Award. Professor Somesh Kumar has research interests in the area of statistical decision theory and inference. He has published more than 100 research papers in the area of statistical decision theory and inference, probability theory, quantum computation and robotics. He has supervised 11 doctoral and more than 200 masters for MTech and MSc dissertations. He is an associate editor of American Journal of Mathematical and Management Sciences, Taylor and Francis. He has been on editorial board and referee for many national and international journals. He is an elected member of the National Academy of Sciences, Allahabad, India. He was an elected member of the Executive Committee of the Indian Society for Probability and Statistics and an elected General Council member of the Forum for Interdisciplinary Mathematics. He has developed 3 video courses on probability and statistics, statistical inference, and statistical methods for scientists and engineers under NPTEL project of the Ministry of Human Resources and Development. These are available through websites of NPTEL and YouTube, etc., and have received millions of views worldwide. He received the Platinum Jubilee Lecture Award of the Indian Science Congress Association in 2016. He is on selection panels of faculty positions at various IITs, NITs, universities, and other academic organizations. He is also a member of admission committees, board of studies of many institutes and universities. He has delivered more than 150 invited lectures and talks in various national and international conferences, symposia, and workshops, and also chaired sessions. He has been a resource person for several short-term refresher courses at IIT Kharagpur and other institutions. He has visited the University of Ulm and the University of Dortmund in Germany as a guest professor. He has also visited Middle East Technical University, Ankara, University of Wollongong, Australia, University of Salzburg, Austria, University of Colombo, Sri Lanka, for delivering invited lectures. He has held administrative positions of President, Students Gymkhana, Dean of Students Affairs, Organizing Chairman for Joint Admission Test for MSc, JAM, etc. He has interest in contributions of ancient Indians to mathematics and regularly teaches the course History of Science and Technology in Ancient India for students in IIT Kharagpur. He regularly delivers expert talks on this topic for various universities and institutes. The ISPS is privileged to honor and confer the K.S. Rao Best Researcher Award to Dr. Somesh Kumar, a renowned scientist, an inspiring teacher, an able researcher, a profound statistician, and a great humanist at this 41st Annual Convention of Indian Society for Probability and Statistics, ISPS, jointly organized by Department of Statistics, University of College of Science, Osmania University, Hyderabad, Telangana, India on Sunday, the 13th March 2022. Indian Society for Probability and Statistics, ISPS, 13th March 2022.
Thank you so much, madam, for reading the citation. Now I would like to invite Professor Somesh Kumar to share his inspiring words. Over to you, sir.
Sir, Professor Somesh Kumar, sir, unmute. Yes.
First of all, I would like to thank all the
Not audible, person.
Somesh Kumar, you are not audible.
Senior functionaries of Indian Society for Honorary President, ISPS, Professor N. Bal. Okay, just a minute. Yeah. Can you hear me now?
Now can hear you, but earlier.
Now you can hear me? Yeah.
Please continue.
Yeah, please
okay,
continue.
Sure. Okay, yeah. First of all, I would like to thank all the
Professor Somesh Kumar, again you are not audible. There is some signal problem, I believe.
Can say without camera, you can say that. Probably that will help you.
Okay. Yeah. Professor Malik, General Secretary of ISPS, all the faculty members of the Usman.
Still the problem. Somesh Kumar, still we can't able to hear you.
Who are present today in the conference at the moment. I would like to thank all my teachers at IIT Kanpur who actually generated my interest in statistical research and teaching, and also all my research scholars with whom I could work on so many different problems. And I learned that in order to actually develop yourself, you should really work on different areas. So, and especially it is apt that it is the award is named in the in the name of Professor K. Srinivas Rao, who has also worked on so many different topics. This also encourages me to work even harder for doing more service to the statistical community in the form of teaching as well as research. At this moment, I would like to thank especially my parents and also my family members for supporting in my work. I would also like to thank my PhD supervisor, Professor Diwakar Sharma, and all other my professors at IIT Kanpur who taught me the fine things about the statistics. I would also like to thank some of my collaborators like Professor P. Vellai Swami of IIT Bombay, Professor Neeraj Mishra of IIT Kanpur, Professor Kishore Sinha, Professor Ashish Sen Gupta, with whom I interacted and learned many new things. Finally, I would like to thank all my research scholars with whom I could work on different areas. Finally, I thank once again Indian Society for Probability and Statistics for bestowing me with this award. Thank you very much to all of you.
Thank you so much, sir, for sharing your thought with us.
I'm sorry that there was some network issue when I'm speaking, so I don't know whether my full thing could be told here or
Yes,
not.
we were able to hear you. Thank you so much, sir, for sharing your thought. Many congratulations to you once again. Confidence is born within, but when someone recognizes your work, then it makes lots of difference. This year, Professor C.R. Rao Gold Medal goes to Dr. Sudhish Kumar Kuttumanil from the Indian Statistical Institute, Chennai. Many congratulations to you, sir. Now, I would like to request Dr. Subha R. Nair from NSS College for Women, University of Kerala, to take over the screen and introduce the position holder.
Thank you, Neha ma'am. Good afternoon, respected professors, organizers of the conference, and esteemed participants. I find myself privileged to have gotten this opportunity to read the citation of Dr. Sudhish Kumar Kuttumanil, Professor C.R. Rao Gold Medal winner of this year. And I express my sincere thanks to the organizers of the conference, the president and executive members of ISPS, and to my guide and mentor, Dr. Satish Kumar sir. Dr. Sudhish Kumar Kuttumanil is an associate professor in Indian Statistical Institute, Chennai, India since 1st January 2020. He worked as assistant professor in University of Hyderabad from 17th March 2009 to 22 December 2011. He joined Indian Statistical Institute, Chennai as an assistant professor from 23 December 2011 to 31st December 2019. He was a postdoctoral fellow in City University of Hong Kong from 2nd May 2019 to 2nd September 2019, and Indo-US fellow in Michigan State University from 30th December 2013 to 29 December 2014, a postdoctoral fellow in Indian Statistical Institute, New Delhi from 17 March 2008 to 16 March 2009. He completed his BSc in Mathematics in 2000 from University of Calicut, Kozhikode. He was awarded MSc in Statistics in 2003 and PhD in Statistics in January 2009. His thesis was submitted on 31st December 2007 by the Cochin University of Science and Technology, Cochin, India. He has many awards and fellowships in his credit, like the Mathematical Research Impact Centric Support 2018 by SERB DST Government of India, Indo-US Research Fellowship 2013, constituted jointly by Science and Engineering Research Board DST Government of India and Indo-US Science and Technology Forum, Indo-US Research Fellowship 2013, constituted jointly by Science and Engineering Research Board DST, Government of India, and Indo-US Science and Technology Forum, Jan Timbergen Award for the Young Statisticians from Developing Countries 2009, International Statistical Association, Netherlands, NBHM Postdoctoral Fellowship 2008, Department of Atomic Energy, Government of India, U.S. Nair Memorial Young Statistician Award 2006 by the Indian Society of Probability and Statistics, and UGC CSIR Junior Research Fellowship 2003. He has published 32 research papers and 1 book. He has supervised 1 PhD and completed 1 major project of budget 13.6 lakhs. His 15 research papers are currently communicated or under revision, and 10 research papers are under development. He is an associate editor in Journal of Indian Statistical Association, JISA. The ISPS is privileged to honor and confer the Professor C.R. Rao Gold Medal Award to Dr. Sudhish Kumar Katamanil, a renowned scientist, an inspiring teacher, an able researcher, a profound statistician, and a great humanist, at this 41st Annual Convention of Indian Society for Probability and Statistics, ISPS, jointly organized by the Department of Statistics, University College of Science, Osmania University, Hyderabad, Telangana, India, on Sunday, the 13th March 2022. Congratulations, dear Professor. Thank you.
Thank you so much, Madam, for reading the citation. Now I would like to invite Dr. Sudhish Kumar for sharing his thought.
I am very happy today. I think you can see everything is fine. I could not see, that's why.
Yeah, go ahead.
Yeah, I am very happy today. I would like to thank ISPS and jury for selecting me this award. I thank all the teachers of Department of Statistics for encourage constant support, which I am getting. I did my PhD under the supervision of Dr. Nch Bhattacharylu, who is the former president of ISPS. During my PhD, he always encouraged me to do good research. But after that, I went to Indian Statistical Institute, Delhi, for doing my postdoctoral work. Professor Isha Diwan, the supervisor, always give a good support. Still, she is giving good support to me. I also would like to mention the support I am getting from Professor Nch Bhattacharylu to do good quality of research work. I always talk to him. He always give advice in personal and academic matters. I am very happy to have a lot of good collaborators, so that I could contribute to the statistics. I also would like to acknowledge the love and support I am getting from my mother, wife Ramya, and daughter Veda. Finally, I would like to mention one point. When I message to Professor Isha Diwan that I got this award, then she wrote 2 messages. One is congratulations, Sudhish, and the second one is responsibility to work hard. I promise to this gathering that I will try my best to do good research work in the future. Thank you all for blessing me in this occasion. Thank you.
Thank you so much, sir, for sharing your thought with us. Now, I would like to invite Professor Parameshwar V. Pandit from the Bangalore University to announce the best research papers. Over to you, sir.
Thank you. Am I audible?
Yes, sir.
Yes.
Okay. President of ISPS, Professor Balakrishna, Honorary President Professor Rajshekhar, and other executive members of ISPS, Professor Jayashree and Professor Bhattacharylu of organizing committee and their team. So it is my privilege to announce the best research paper awards. There are 4 awards. I just would like to read those. The first is ISPS Young Statistician for Best Research Paper Award. This goes to Shilpa Subhash of Cochin University of Science and Technology. Congratulations, Shilpa. The second award is Dr. A.M. Mathai Cash Prize Award. It goes to Aradhya Girish Ramachandra, Central University of Rajasthan. Congratulations, Girish. The third is Dr. M.L. Gopalan Prize Award. This goes to Dilip Kumar Yam,
from University of Calicut. So congratulations, Dilip Kumar. The next award is Dr. B.K. Kale Prize Award goes to A.S. Satinthar, University of Kerala. So congratulations, Satinthar. So I congratulate all the winners personally and on behalf of ISPS. I thank ISPS executive body for this giving me this support. Thank you. Thank you.
Thank you so much, sir. And many congratulations to all the researchers who have received the Best Paper Awards. Now, I would like to invite Professor C. Satish Kumar from the University of Kerala to announce the Best MSc project. Over to you, sir.
With great pleasure, and on behalf of the President, Secretary, and EC members, Honorary President, and EC members, and Associate EC members of ISPS, we would like to announce the results of ISPS MSc Project Competition Award 2021. This time we received 7 entries and we shortlisted 3 among them based on the adjudication reports of 3 experts. And on 11th March, the first day of the conference, these 3 teams were allowed to present their project reports. And on the basis of the reports of the 3 judges, we come up with the final ranking as per the consolidated evaluation reports of all the experts. With the permission of the ISPS and EC members and associated EC members, and all those who assembled here in this hall, let me to announce the result. The first rank goes to the team from Department of PG Studies and Research in Statistics, Mangalore University, Vinita Sararo, Sukesh Kayan, and Ankita K. The second rank goes to Department of Statistics, Yenipoya Deemed University team. From there, Sushama, Sanjana S, and Lahiri L are the team members. The third rank goes to the team from Department of Statistics, Madras Christian College, Chennai. The team members are Ashwini Rajendran, Malolan T.A. and Prajesh S. Once again, I utilize this occasion to congratulate each of these team members, and their certificates will be sent to you by email or by post from the ISPS office.
Thank you so much, sir, and many congratulations to who have received the Best MSc Project Report Award. Before concluding this award ceremony, on the behalf of the Executive Committee of ISPS, I would like to express my gratitude to all the jury members of all the committees for their efforts and significant assistance during this process. Thank you so much for being with us today, and we sincerely wish to see you all again in the next convention of ISPS with renewed enthusiasm and energy. Now I hand over the session to the chairperson of this award ceremony. Thank you so much.
Yeah, thank you, Neha. Before going to propose vote of thanks, I would like to congratulate to all the awardees of this program, of this ceremony function, and I'm also grateful to Dr. Neha, the program coordinator, and all the citation speakers. So now I request Dr. Venkateswaran, who is our treasurer, I request you to propose vote of thanks.
Good afternoon to all of you. I'm very much happy to present the vote of thanks for this award ceremony. On behalf of ISPS and on my personal behalf, first I wish to thank ISPS President, Secretary, Honorary President, EC members and AEC members, and award committee members for identifying the deserving personalities to honor them. Then I would like to thank Dr. Neha Garg from IGNO, New Delhi, for coordinating the award ceremony, also in preparing of citation and invitation. Thank you, madam. Then I would like to thank Professor Sharada Bhatt, Bangalore University, Professor Kritika, Pondicherry University, Professor Ranjita Pandey, University of Delhi, Professor G. Jayashri, Usmania University, Hyderabad, Dr. Rupal Shah, MS University, Baroda, Dr. Lalita Devi, Kasturba Gandhi College for Women, Telangana, Dr. Subha R. Nair, NSS College for Women, University of Kerala, for presenting the citation of the awardees in a nice way. Thank you all of you, madam. Then I would like to thank the awardees, Professor BLS Prakash Rao sir from C.R. Rao Institute, Hyderabad, for getting a Professor C.R. Rao Lifetime Achievement Award. Professor Arup Bose from ISA Calcutta for getting Fellow of ISPS. For Professor K. Srinivas Rao, Andhra University, Visakhapatnam, for getting Fellow of ISPS. Professor David Hanagal, the Symbiosis Statistical Institute, Pune, for getting Fellow of ISPS. Professor K.K. Jose, Mahatma Gandhi University, Kottayam, for getting a Fellow of ISPS. Then Professor S.C. Malik, MD University, Rohtak, for getting the award, Distinguished Statistician Award. Professor Somesh Kumar, IIT Kharagpur, for getting Professor K.S. Rao Best Researcher Award. Dr. Sudesh K. Kotumanil, ISI Chennai, for getting Professor C.R. Rao Gold Medal. I would like to congratulate and thank all the awardees for receiving this award. I also thank all the committee members of Best Research Paper and Best MSc Project teams and the awardees also. Thank you one and all.
Thank you all of you.
I think with that we are done with the award ceremony. I will start, Professor Reddy. Yeah. Okay. So thank you all for making this very grand success. I think it went on very well. Thanks to Neha, in particular, and also Professor Reddy for coordinating all the things. Professor Satish and Professor Pandit for managing the the competitions. Also for all the jury members. Thank you. Thank you very much.
Thank you, Bala.
Thank you,
Thank you,
Professor.
Rao. Dr. Srinivas Rao.
Thank you all of you.
Yeah, I think we will meet in the afternoon session.
Okay, bye.
Okay. Bye.
Right,
Let us have some lunch now.
Right, sir. Kodu Srinivas garu. Namaskaram. Okay. Yeah.
Thank you all.
Right. Thank you.
Okay. Bye. Bye.
Thank you all.
Done a great job, sir, honoring the really talented people.
Thank you very much. Thank you very much. Congratulations to all awardees. It's a wonderful, wonderful session that we had today, and identifying and encouraging all the people who are involved in statistics and probability.
And then again, and again you are going to see on 10th September in Tirupati.
Oh, same.
Yeah. Yes, sir. We are planning.
If it is online or offline, hybrid.
Congratulations to all the winners from the Department of Statistics. Congratulations to all the winners and awardees from the Department of Statistics, Usmania University, from the organizing committee.
Good afternoon, one and all. Can you hear me?
Yes, ma'am, we can hear you.
Thank you. Actually, now the session should be chaired by Dr. Sudhish Kumar, but sir is taking his lunch, so it may take a little bit of time. So sir requested me to start the session. So let me introduce the speaker of this particular session, Dr. Deepa Modia. Madam is an assistant professor in the Department of Statistics, University of Rajasthan. Madam, thank you for being here. And madam's area of specialization are quantitative techniques. And madam has authored a particular book, co-authored a particular book. Madam is a member in the Indian Science Congress Association, International Association of Engineers, and also in the Rajasthan Statistical Association. And madam worked as madam worked as assistant professor in JCER C University, Jaipur. And madam, before that, madam worked as assistant professor at St. Wilfred PG College, Jaipur. And madam is working since 2004 and as faculty. And madam is a member of admission committee of Department of Statistics. Madam even taken coursework of PhD scholars. And I request madam to start the lecture. Thank you, madam, for accepting our invitation and to be here to deliver a lecture. Thank you, ma'am.
Yeah, thank you so much, Jayashree ma'am. It's wonderful feeling with you in Osmania University. Even I'm very much thankful to you that you have given me the invitation for my talk. Now I will do my presentation. Yeah, I'm sharing my screen.
Yes.
Is it visible, ma'am?
No, not yet, ma'am.
Not yet. Yes. We can see your screen.
Ma'am, you are muted. Madam, you are muted. Please unmute yourself.
Yeah. Is it, I think, audible now? Now I'm trying to share again my screen. Now is it audible?
Yes.
Yeah, okay. Thank you so much, Jayashree ma'am. I'm beginning with my topic. Yeah, thank you. So my topic is the statistical analysis of the cyber crimes in metropolitan areas. I selected this topic because all of you had faced last 2 years this pandemic time, and we received so many cyber crimes related with this. The cybercrime system was working earlier also, but this time we found and we realized that such crimes are happen. First, we have to know what is cybercrime. Now, it is again a crime. That means it's a criminal activity which is directly related to the use of the computers for their illegally trespassing from the computer system or a database to another. Higher the country is technologically advanced, higher would be the rate of cybercrimes. We found this. And in India, we all know the Karnataka is very much well-to-do into technologically advancement. We found this, that according to the total cybercrime cases reported in 2019 in India, the Karnataka has shown the highest number of cybercrimes, followed by the Uttar Pradesh and Maharashtra. So we decided to work on this. Now, what types of the cyber crimes are? Cybercrime is not only that you had purchased something and someone had done wrong with you and it is a crime. There are so many types of crime. One of them is hacking. Everyone is aware of this, what is hacking. It's a kind of a intruder in which your computer system, anyone without your permission. Hackers are basically computer programmers. They have an advanced knowledge of computers. They misuse their knowledge in a very appropriate reasons. They're usually technological buffs who have expert levels, skills in one particular software program or a language. And the motives are several. They can be explained by a human tendency such as greed, fame, power, and few of the people purely to show off their expertise, ranging from their harmless activities such as modifying software to carry out tasks that are outside the creator's intent, and others just want to cause the destruction. These hackers use that certain techniques like the SQL injections, theft of FTP passwords, cross-site scripting, and many more. It was hacking. And another is the virus dissemination. What is this virus dissemination? We all know what is virus. It's a computer program which attach themselves to or infect a system or a files that have a tendency to circulate other computers or the networks. They disrupt the computer operation, affects the data, either by modifying or deleting altogether. The worms, unlike viruses, don't need a host to cling on to this, and they replicate until they eat up all the available memory in the system. There are again two kinds of viruses depending upon how they are damaging your system. First is only dissemination, and which do not cause intentional damage. And second is intentionally programmed, which cause the damage. Another one is the slack code. What is this? We generally in a language says the logic box. It is a malicious piece of code which is intentionally penetrated into the software, execute the inappropriate task when triggered by a specific event. These are the viruses which behaves in a similar manner. Inserted the program, lies dormant until the specified conditions are met. The software such as viruses and worms often contain the logic bombs which are triggered as a specific payloads. Another one is DOS attack. DOS is a denial of service. If there is an attack on a denial of service, it is a DOS attack. It exploits the attempt by a cyber criminals to deny the services to intended the users of that services. It makes a computer resource overflowing with requests more than it can be handled, consuming its available bandwidth, which leads to server overloading. This causes the resource to crash or slow down significantly so that no one can access it. The attacker can render inoperable massive amounts of traffic to the targeted site, and the malfunctioning completely resulting in ability of the system. It affects user policies of virtually internet services provider, and like this it works. Another is phishing. Phishing is the term which we'll use in this pandemic time a lot. It's a social engineering, where a cyber criminal sends a corrupted messages designed to trick on an individual victim into revealing their sensitive information to the criminals or to deploy malicious software. There are various types of phishing that we'll not all discuss, but we should know the spear phishing, mail phishing, wishing, and whaling. All of them are the online scams which steal your sensitive informations. Another is email spamming and bombing, that again most of the people are familiar with this term. It is again a mail target to the address, resulting in victim's email's account. The mail servers crash, and the message in meaningless and excessively long in order to consume network resources. Have almost everybody faced this. Unwanted messages, we go somewhere else, we give us our mail ID, they junk it, they club it, and they try to send you all the mails with have so many long, it's excessively long, which covers your data and the resources. These emails are arriving frequently in your inbox and can be easily detected by spam filters, which use machine learning algorithms. It carries out using botnets. It as a DDoS attacks, and the spamming is a variant of email bombing. Here, unsolicited bulk messages are sent to the larger number of users instead of targeting one user at a time indiscriminately. Opening links, gifts, and spam mails may lead you to the fraudulent phishing website hosting malware. The spam mail may also have an infected files as attachment. The addressee receiving the replies and the address box and sell them to other spammer, and it creates an invalid email addresses. Another is the cyber stalking. Again, in this pandemic time, we face this cyber stalking. What is the cyber stalking? It is one of the most prevalent forms of internet crime in a society, where a person is pursued or followed online. These stalkers doesn't physically follow his victims. He does it virtually or following his online activity to collect the informations about the victim and harass him or her and make threats using the verbal intimidations. And generally, we online, what does it mean? Online can be anything. If you are using a simply WhatsApp, generally the people are not doing the text messages using WhatsApp, and they say whether the person is online or not. The moment they say that you are online, they hack and trying to harass the victims. It is a way of stealing one's sensitivity and personal information. Cyber stalking uses the internet and any other electronic means and is different from offline stalking. It is usually accompanied by it. Most victims of these crimes are women because they are stalked, who are stalked by men and children, who are stalked by adult predators and pedophiles. The cyber stalkers thrives on inexperienced web users who are not well aware of netiquette and the rules of internet society. A cyber stalker may be a stranger, but could just easily be someone you know. Cyber stalking includes both internet and computer stalking, and is now rapidly spreading to social media networking stalking. Another is identified theft and credit card fraud. Am I audible?
Yeah, you're audible, ma'am. You can go ahead.
Thank you so much. I thought I'm speaking, and because it's a one-way, I'm feeling like a one-way communication, I thought I'm only speaking. Yeah, thank you so much, sir. Now the next one is we are discussing with the identity theft and the credit card fraud. This again, this time explore the credit card and the debit card a lot because everybody want to do being online shopping. It's a theft when someone steals your identity and pretends to you access sensitive resources such as credit cards, your bank accounts, and any other details in your name. They use your identity to commit other illegal crimes. It is a kind of fraud where your credit card to fund his transaction. It's theft in its simplest form. So many cases and your pre-approved card falling into someone else's hands. The worst condition in these kinds of threat is when the cyber criminal uses personal information through the stolen or a fake documents to carry out banking activities like taking loans, etc. The abusive content and pornography. With the advent of cybercrimes, displaying of abusive and pornographic content on social media websites and portals where both adults and minor children are developed and deployed in inappropriate sexual activities, whether the uses of abusive language, or it's a kind of showcased in the form of animated pictures or movies or etc. Counterfeiting and fraudery. It is the creation of imitated version of an unauthorized article with an intention to defraud. It create and produce the objects with the intention of defrauding another. The offenses related to the counterfeiting and fraudery has become quite popular because making fake birth certificates, mark sheets, has become very easy through the techniques or the softwares that allow the such cyber crimes. Cyber terrorism. It's again a kind of terrorism which mainly target the government or its people illegally fetch information stored in their system. It is premeditated, politically motivated attack against information which might result in violence. It experienced cyber terrorists which damage the government's computer system and risk of the further attacks too. The most prevalent cyber crimes with examples in India. The nature of cyber crimes can be financial crimes, cyber pornography, sale of illegal articles, intellectual property crimes, or the email spoofing. Financial crimes like is the cheating through your credit card, your money laundering. Cyber means pornography means any of the pornography websites. And the sale of illegal articles. Illegal is the narcotics, the weapons, the wildlife. Intellectual property is like your software privacy, copyright to infringement, the violations. Email spoofing is, it seems to be originated from one source but has been sent to from another source. Such as the fraudery, cyber staking, and all that we had discussed. To regulate such cybercrime activities that violate the right of an internet user, the Indian government has the Information Technology Act 2000 in place. These are few of the laws which govern by the cybercrime in India. The cybercrimes are also registered under IPC and special local laws that is very well known by SSL. Some of the sections in which these laws like 65, 66E, 499, and many more laws running and working on this cyber crime. Point is how to prevent. We have to remember the update security softwares. It gives the latest mode in order to maximize its efficiency for fighting against the viruses and worms. The locking your system, the stepping away, not using it to ensure that else can have access it without your permission, especially when we are outside. If your system is always connected to the internal, there are chances that it will get attacked by the cyber criminal online. Try to disconnect it from the internet when not in use. Try to use the passcodes, the pins, the passwords, the pattern locks for your electronic gadgets. Sometimes it happens when we're seeing and watching anything on our television. Nowadays, the Netflix and this were on high beam. The people used to start, see, and they left like where the movie stopped, I will stop, and they will run out. This is have not to be done. You should log out properly. Whenever you have a doubt, don't click. When you find there's a mysterious mails or messages, don't click. Public Wi-Fi is a very easy tool of the hackers. They gives you like anything. It's free for you and all. I know people connected with that. It is harmful because it's publicly. No, anyone can connect with you. Anyone can hatch your data. Keep your social media settings very ordered. You should know to whom you are connecting, how you are connecting, and how the person can see your data. If you think you have been attacked, don't panic. Report the situation to a responsible person who has a knowledge of it, and then take further legal actions according to the nature of your crime or the questions you have. Now, the effects of the cyber crimes. See, the people those are facing such crimes, they only knows what they lost, because the fraudery and all is like it's an emotional crime also. Whatever you are giving to the person, crime is one is publicly announcement that he or she is victim. It affects a human life in a huge negative impact on all the fields which are actively the part of the digital world, where its penetration is highest: national defense, business, private forums. It affects on also financial services. Many profit-driven criminal activities like ransomware attacks, email, internet, identity frauds, they steal financial credit cards. That leads to your huge financial harm. Effect on individual private information. Whatever you are given to someone else, they are using information as in a criminal offenses. Your private pictures is your multimedia. Effect on business as well. It loss of the reputation, the loss of trust of your customer. If someone is selling and someone is hacking their email ID, they were doing fraudery with the customer, the business affect directly. There were so many cyber crimes, and the cases were in India. In 2001, in January, there are a few of the cases which we want to discuss you to aware. There was a famous journalist, Nidhi Razdan. She has become a victim. She was a journalist. She knows everything. She was dealing with the things. She was exposing everything. Still, she becomes a victim of very serious phishing scam, which gives a fraudulent offer of being an assistant professor at Howard University. She filed a complaint in a cyber cell, and offenses including the fraudery, cheating, identity fraud, and impersonation of strangers against her. That attack was done to access her personal details, the bank account details, the medical records, or a passport, or 2 electronic gadgets. India witnessed its first cybercrime conviction in 2013 through a website called sony.samdhan.com, which sells electronic products of Sony to non-resident Indians. A fraudulent transaction has happened when a person has used someone else's credit card details to pay the devices he had purchased under the complaint many sections of IPC and IT Act. As we have a lack of time, so I'm not going to discuss all the cases, but I had mentioned here, and those who want to see, they can see all that. The major motives will come to the point that found in the 16 metropolitan areas is this. I had given the table. By this table and the data, we analyzed so many things. Another one is the cyber crimes under the IT Act in 2016. We found in the 16 metropolitan cities is this much. Graphically, I shown that you can see the Bangalore is the highest cyber crimes under Act 2016. Then in the 17, we have again the data. It's all data is available on the site. Again, you will see the Bangalore is receiving the highest cyber crime. Then it is for the 18. See, I think the Bangalore is on highest and the Lucknow, you can see, is on second stage. It is clear that again the city of Bangalore has the highest number of cyber crimes, followed by the Lucknow and Hyderabad. And again, the city of Patna has shown the 0 cases of cyber crime. In 2019, again, we'll see this table. It rised up, it highed up. It's like receiving like anything. And cities like Indore, Kolkata, they have least number of cases. So I had taken out to 14th to 19th, if you will see. In 2019, from 14 you will count, it's multiplied like anything. It's raised like anything, you can see. Height of the cyber crimes in India. In the cities, those are technically strong. You know, it can be concluded that the cases where we had found an exponential trend curve, and we found this exponential trend curve to our data. We analyzed this technique to find our exponential curve, that is yt is equal to a plus bt, and I got this result. From these equations, I put on the data and I found the trend values being this. Now we'll check from taking the hypothesis. We found, again, 14 to 19, the observed value, we found this approximately the same. Now, from all this data and all the calculations, we found this ratio will raise in 2020. It would turn into 47,437. It is just double from 2019. These cyber crimes have their also some motives. They want to take some revenge, the extortion, the political moves, and nowadays it's again used as a woman, mostly such things used on the women crimes, the fraud, the disrupt, sexual exploitation, etc. The most of them cyber crimes were used as a fraud. They fraud with this. We found there is a significant difference between the number of cyber crimes committed by the means of fraud and the sexual exploitation and causing disrepute. So we consider that the major motive of cyber criminals behind committing any cyber crime in these metropolitan areas. We made a different, only for the fraud, how many fraud cases we found in the metropolitan cities. You can see the most fraud cases are in Bangalore. It shows that it's committed by means of fraud, followed by the Mumbai and Hyderabad. It's a sharp difference between the number of cases committed in Bangalore and cases committed in Mumbai and Hyderabad, or Indore and Karachi, and this Kochi also have this problems. Now we analyze from this to deal with all this. The analysis of the general growing pattern of cyber crimes being committed in these areas, and it concludes that the number of cybercrime has been growing exponentially over the years and following for the exponential trend patterns. The 16 metropolitan areas have the top cyber cities of India, and the cyber crimes under the IT Act was in Mumbai and Lucknow, Indore and Kochi. We obtained the time series model for the future forecasting for 2021 and 22. as I had just started doing work from the 20. So we had taken for the 20, 21 as well for 22 since it's running. And lastly, on analyzing the different motives behind these crimes, being found that the criminals committing crime with intention of doing fraud and all this. And it can be interpreted that these cities are the top cyber cities of country, more prone to such digital cybercrime, and compare the cities with not topmost list of the cyber cities of India. So thank you so much for listening me on the. If you have any question and query, so you can ask me. Yeah, anyone of you want to ask any question? Yeah, Jai Shri ma'am.
Time after the lunch. So any question?
Yeah.
Hello.
Yes. Yeah, Jai Shri ma'am.
Yes. Any questions?
Okay, if not, Maria for his.
Yes, sir. Thank you for joining, sir. Sudesh Kumar, sir.
Thank you.
I thank Deepa Modia madam, and I also thank Sudesh Kumar, sir, for joining us.
Yeah, thank you so much, Jai Shri ma'am. It's a pleasure to being with you all and to connect with the Osmania University, because otherwise we have to plan a lot to think that we have to go and rush there. It is the best way that I can connect with you, and I'm inviting you all for visit the Jaipur whenever the summer breaks come. Jai Shri ma'am, आप आइए Jaipur. हो सकेगा तो हम practically भी मिलेंगे. Virtually we are meeting. And we want to meet you practically also. Thank you so much to listening me carefully. Thank you, ma'am.
Thank you. And Jaipur is known as Pink City, and you are also wearing a pink color saree.
I'm representing my city now.
That's nice to see you, madam.
Here, ma'am. Thank you. Thanks a lot.
Thank you. Thank you. Thank you. Thank you, Sudesh Kumar, sir. Thank you very much. Sir, sir.
Ma'am, Chairperson Venkateshwaran sir is already online.
Venkateshwaran. Good afternoon, sir. Venkateshwaran, sir, I welcome you to this particular session, sir.
Yeah, good afternoon, madam. Thank you.
Thank you, sir, for being with us and accepting our invitation, sir. Venkateshwaran, sir, is an assistant professor of statistics from the Madura College, Madurai, and sir's areas of research interest are stochastic modeling and queuing models. Sir, I invite you to chair this particular session, and please ask the presenters to present their papers, sir. Please take the chair, sir. Thank you, sir.
Yeah, okay.
Thank you.
Okay, very good afternoon to all. So first of all, I would like to thank the organizers for giving me this opportunity to chair the session. So I hope all of them as present here. Just I can have a check. Asmita Shukla.
Yes, sir, I'm present.
Yeah, okay. Then Suvarshi Sudarshi. Okay, they may be joined later. So now we have totally 12 presentations, so that our time will be up to 4:30. So as per that, on average, you will be getting around 7 minutes. So kindly stick on the time to 7 minutes. And you can start with our first presentation. The first presenter is Asmita Shukla on topic Bayes analysis of lifetime regression model with high dimensional covariates. Please, madam, start your presentation.
Yes, sir. Thank you. Is it visible, sir?
Yeah, it's visible, madam.
Okay, this is Asmita Shukla from DST Center for Interdisciplinary Mathematical Sciences, Banaras Hindu University. Hello, everyone. My topic is Bayes analysis of lifetime regression model with high dimensional covariates. And these are the contents. My paper proceeds with the two objectives. The first one is the Bayes analysis and variable selection of viable regression model with high dimensional covariates using Bayesian lasso prior. And the second objective is to find the good computational strategy to draw sample from high dimensional posterior. High dimensional data means when the number of observations is less than the number of covariates. And the model we have considered is viable model, as I have said earlier. So the density of the viable regression model is given in equation 1, where beta is the shape parameter and b is the regression coefficient vector. And the survival function for the same is given in equation 2. The data in many cases, including the one we are working on, are right censored. To incorporate the additional information due to censoring, we have defined indicator variable del I, which takes value 1 when the lifetime is observed and 0 when Ti is censored. Under such settings, the likelihood is defined as given in equation 4, and that for the viable regression model is given in equation 5. Lesser estimates often are viewed as L1 penalized estimates. The lesser estimate for linear regression parameters can be interpreted as a Bayesian posterior mode estimate when the regression parameters have independent Laplace prior. And we are following the same idea. So we have considered the Laplace prior for the regression coefficient vector, which is given in equation 6. The right hand side of the equation 6 can be further represented as equation 7. And this representation suggests a hierarchy of prior. Suggested a multivariate normal prior for the regression coefficient vector with means 0 and variance covariant matrix S, where S is a diagonal matrix with diagonals Sj, which follows exponential distribution with parameters lambda square by 2, where lambda is the lasso estimate. And for the shape parameter of the viable model, that is beta, we have considered gamma distribution with parameters P and Q. And for the parameter eta, we have considered non-informative prior, which is 1 by eta square, as given in equation 11. So in this way, we have defined all the priors. Next, coming to the posterior, combining likelihood and corresponding prior distribution, we can get the posterior up to proportionality as given in equation 12, which is clearly visible from the equation 12 that it is not a closed form density, neither it can be reduced to. Thus, posterior cannot be analyzed analytically and no inference can be drawn. In such situations, sample-based approaches are a good alternative. And for this purpose, we have considered give sampler. We hereby propose two strategies to draw samples from the posterior. The strategy first involves give sampler, and the second strategy is give sampler within additional metropolis adjusted Langevin update. Under strategy 1, to update B, that is regression coefficient vector, we define a full conditional for all the components of B, which is given in equation 13. It can easily be shown to be log concave and can then can be generated using adaptive rejection sampling, that is ARS. Similarly, for the beta, we have full conditional as given in 14, which is also log concave and hence can be generated using ARS. For updating eta, we write the full conditional, which comes out to be the density of gamma distribution, which is given in equation, not an equation, which is mentioned here with parameters A and B, and thus can be generated using standard gamma junction algorithm. And similarly for S, the diagonals of S are conditionally independent, and 1 by Sj follows inverse Gaussian with the given parameters. Therefore, they can also be generated using corresponding standard generation algorithm. Okay. To update lambda, we have used an iterative process based on EM algorithm, where the ideal update estimate lambda k for the iteration k is given in equation 15 with the initial value given in equation 16. In this way, we can update all the parameters and run the Gibbs sampler algorithm. For the strategy 2, it is same as the strategy 1, except the fact that the generation of regression coefficient vector is quite different. Here we are using Metropolis adjusted Langevin algorithm to generate the samples from regression coefficient vector. This algorithm is just a slightly modified version of the well-known Metropolis Hastings algorithm. The proposal for this algorithm, that is Metropolis adjusted Langevin algorithm, is given in equation 17. That means the proposal involves a gradient of the density from which we are drawing the samples, and the acceptance probability is given in equation 18. For numerical illustration, we have considered the data that was originally reported was by National Center for Biotechnology Information, and the URL I have already given here. The final data set consists of 240 observations on 558 variables, and gene expressions affecting the lifetime are considered to be the covariates. That means finally we have designed our study with 556 covariates, each with 240 observations. Clearly the problem is high dimensional because the number of observations here is less than the number of covariates. Out of 556 regression coefficient that we have selected 20 corresponding to high value of estimated mean. The table here presents the posterior summary of regression coefficient vector. Moving on, we have another table which also presents the posterior summary for the parameters of model, viable regression model, that is beta and eta. The table presents mean, median, mode, and HPD interval for 95% of coverage. Here are the conclusions. The paper considers viable lasso regression model and performs Bayesian analysis when the data are right censored. 2 strategies has been proposed to draw samples from posterior, which is analytically intractable. Posterior summary has been tabulated. That's it. Thank you.
Okay, first of all, thank you, madam, for sticking on to the time. Any questions? So for time being, just you can invite only at least one question. Any questions? Okay, if there is no questions, okay. Thank you, madam. Thank you for your presentation.
Thank you. Thank you.
So then we move on to the next person, Dr. Masood H. Siddiq.
Good afternoon. I am sharing my screen.
Yeah, okay, sir. Okay. So he is going to present on detecting diseases using voice biomarkers, a statistical based ML approach. So please proceed, sir, and please note that it will be for 7 minutes, sir. Thank you.
Okay. So my slides are visible to all of you. This is Professor Masood Siddiqui from Department of Statistics. My co-authors are Dr. Pritam Singh from Department of Computer Science, VIT University Bhopal, and Pritam Singh and Dr. Deepak Singh from Department of Analytics, that is Jaipur Institute of Management, Lucknow. Okay. So our research paper is actually based upon the visual biomarker, and from that we try to detect the disease, and here we are especially concentrating upon depression. So actually vocal biomarker is a signature, a feature or combination of features from the audio signals of the voice that is associated with the clinical outcome. And it can be used to monitor patients related to disease, related to severity of the disease, or anything related to drug development. And a number of authors from the different streams has tried the voice biomarker on a voice biomarker or vocal biomarker on different diseases like Parkinson, Alzheimer's, various diseases like arthritis, mental health, cardio. Even some of the authors have tried on the COVID also. And these are the references as papers number as per the references. So here our focus is on identification of depression using vocal biomarker or audio biomarker. What was the rationale? Because in the universe, around 350 million of people suffered from the depression. So that is a big problem. So here we have used wavelet transform analysis and statistical pattern recognition technique. So to split the adaptive wavelet transformation using the concept of time wavelet transform domain. So we start with the questionnaire, right? which is used on the sample, which is related to different questions, and they are asked to count 1 to 10, and their voices are recorded in order to detect whether these people are having depression or not. So database actually included 208 respondents or the voice samples, 150 from pathological and 58 from the healthy voices. And the process flow is the data collection followed by data processing, then data analysis, identification of the dominant features, then statistical feature identification, that is the phase 2. Then we develop machine learning algorithm, we implement the algorithm, then we deploy and test the app, and then finally we will test the product. So the phase 2 is actually based on the statistical feature selection that involves evaluating the relationship between each input variable and the target variable using statistical analysis and selecting those input variables which are most important. And these methods can be fast and effective, although the choice of a statistical method depends upon the data of input and output variable. So it is the broad description of the feature selection technique, which consists of both supervised as well as unsupervised technique. In supervised technique, we have different methods like intrinsic method, wrapper method, and the filter method. In intrinsic method, the decision tree method has been used. And in the wrapper method, the recursive feature elimination method is being employed. And in the filter method, statistical measures like using crosstab and feature importance has been used. Right? So it is the second step that is related to feature selection. It is depend upon the input variable as well as the output variable, which is helpful. So to decide which feature selection method should be used. So actually here acoustic waveforms are being transferred into the acoustic signal, which is used for the speech recognition, which consists of noun phrase and the verb phrase. And from that, the features has been evaluated. So, and the next step is to convert the voice signals into the digital signals, which is analog to digital confirmation. Then we go for the sampling and quantization. Use filters to measure energy levels for various points on the frequency spectrum. Then knowing the relative importance of different frequency bands or the speech, that makes the process more efficient. So after that, we move to feature extraction, which is the first step of the pattern recognition approach, which is the transformation of the pattern into features which are targeted as a compacted representation. So here, first order statistics like the 4 measures, then we go to the second order statistics, that is the angular second moment, which also include correlation and the entropy. And we have also considered the different features of the voice, that is speech length and the loudness. Here, 2 classifications are broadly used. They are minimum distance classifier, which employs as classification technique, which use minimum Euclidean distance between the unknown entity and the mean value. And the second one is the k nearest neighbor distance classifier that also use the unknown entity and the k nearest neighbor. Right. Other 2 techniques that can also be employed, that is the least square minimum distance classifier and the quadratic classifier. So these are the different features that has been considered. So the paper is still to be completed since the data is being collected. And after that, we will use, we will try to detect depression using a voice biomarker, employing supervised ensemble learning algorithm, which consists of the combination of binary logistic regression and artificial neural network. Why ensemble learning is being used to have better predictive accuracy. Then we go to model development, model testing, and model deployment. For the model development, we use the design thinking approach that will be helpful for a better model development. And these are the references. Thank you.
Thank you, sir. Any questions? Okay, if there is no questions, okay, sir. Thank you, sir.
Okay, thank you.
Okay, then we have the next speaker, Divya. Divya is available.
Yes, sir. Am I audible, sir?
Yeah, you're audible. So you're going to present on comparison of variable selection methods for high dimensional data.
Yes, sir, exactly.
Yeah, please proceed. So make a note that it has to be completed by 7 minutes.
Sure, sir. Thank you. Is my screen visible, sir?
Yeah, it's visible. Please proceed.
Okay. Good afternoon to everyone present here. My name is Divya. This is scholar in Department of Statistics, University of Madras. I'm here to give my presentation on the topic comparison of variable selection method for high dimensional data. And this work was done under the guidance of Dr. S. Suresh, Assistant Professor, University of Madras. These are the content, and this presentation explains the need for variable selection method in the field of survival analysis when high dimensionality exists. In this introduction, we're going to see the importance of gene expression in cancer biology, which leads to personalized treatment, but the dimensionality of gene expression is high. To reduce dimensionality, a variable selection method is performed. Gene expression signature significantly improves the knowledge of cancer biology, proficiently estimate progression, and capability of decision-making on cancer treatment, that how individual will behave for a particular treatment, and also observing mutation of genes will be helpful to understand the risk of the patient with cancer or the risk of relapse. Based on the gene expression profile, the most promising strategy available to predict the recurrence of malignancy and provide information to select patients who can be benefited from personalized treatment. Variable selection method. Variable selection means choosing a variable among the complete list of variables by removing irrelevant or superfluous one to include in a particular model. The purpose of such selection is to determine a set of variables that will provide the best fit for the model so that accurate prediction can be made. Variable selection is one of the most difficult aspects of model building also. In this study, the main objective is to identify active biomarkers using variable selection method. Lasso and some of its extensions are discussed with simulation study using R software, where the generated datasets contain survival endpoints. To compare the performance of selection method in case of increasing the sample size with fixed covariate while considering the null and alternative setup. Generally, in low-dimensional data, semi-parametric Cox proportional hazard model is commonly used to study the relationship between the covariates and time to event endpoints. Where equation 1 explains the partial log likelihood of Cox regression model, where beta can be estimated using this equation 1, where n is nothing but my number of observation, delta is nothing but my event indicator. When event indicator means whether the event has occurred or not, it can be identified based on this delta I. Beta is a regression parameter. Zj is the number of covariates, a vector of covariates. In case of high dimensional data, this model fails to be identifiable. Several methods have been proposed to handle such a case with a number of predictor P, which is greater than number of patients N. Many variable selection methods are available. One of the important methods is penalized approach. Penalized Cox regression model make it possible to simultaneously perform coefficient estimation and variable selection. Least absolute shrinkage and selection operator is an abbreviation of Lasso. This was introduced by Professor Robert Tipshirani in 1996. Lasso regularized a model parameter by shrinking the regression coefficient, reducing some of them to 0. In this presentation, we're going to see for Lasso CVL method and Lasso PCVL method and elastic net algorithm. The least absolute shrinkage and selection operator is an L1 norm regularization method. The coefficients are estimated by maximizing a penalized log like a partial likelihood, which is equation number 2. Where finding this lambda is very difficult. This is called as tuning parameter. The choice of shrinkage parameter is challenging and is generally obtained by maximizing the cross-validated log likelihood function. Choosing a proper lambda is very important because the larger the value of lambda force all the coefficients to 0, or smaller the value of lambda will make the irrelevant variables to remain in the model. In Lasso PCVL method, it's an extension of cross-validation approach, which is denoted as a panelized cross-validated log likelihood, and compared its performance to other existing extensions like adaptive lasso, percentile lasso, etc. This approach balances both goodness of fit as well as the parsimony of the model, leads to the selection of fewer genes by applying a more stringent selection criteria. Elastic net method. Zhou and Hasty proposed the elastic net method, penalized regression, with the combination of L1 norm and L2 norm penalties. And this is the equation 3, where we're going to have a partial log likelihood Cox regression model with this parameter. This by subtracting this equation 3. Here, regularization parameter lambda and mixing parameters alpha, both are generally estimated by cross validation. But by recent study, generally we fix alpha value as 0.5 and estimating at lambda value through cross validation. In resultant discussion, first we're going to see the simulation study. Here we're going to fix number of biomarker P as 1000, and the sample size is 100, 250, 500, and 1000. Here we're going to give two set of scenarios. One is null scenario and another one is active alternative scenario. In say null scenario, we're going to give there is no active biomarker present in the data set. Where when it is q equal to 5, q equal to 20, 50, we're going to give that this is a number of truly prognostic biomarkers present in the data set. Then we look at the data set. This is n, the sample size, and this is where P is nothing but by number of biomarkers. You know, Q is in null and alternative setups. For each data set, the event occurred and the censoring also displayed in table 1. This Kaplan-Meier curve explains the survival probability of data set when the sample size is 100 with a fixed number of covariates 1000. The first plot is for when Q is equal to 0. Second plot is for Q is equal to 5, and third plot is for 20 and for 50. So in this we can able to see two set of step function is there. One is for treatment 0.5 and another one is treatment minus 0.5. So in each year we have data like initially it has 59 and next year it is 27. So similarly we have plotted for 250 and for sample size 500 and for 750. Now for each data set we have applied the selection method. We can able to very clearly understand when there is no active biomarker, all methods didn't select any variables. For each data set, 3 selection method, lasso CVL, lasso PCVL, and ENet algorithm is performed. So these are for when it is like Q is equal to 5, when there is a 5 active biomarkers, lasso CVL have selected 24 variables, and ENet algorithms selected 84 variables, where lasso PCVL selected 15 variables. Similarly, for all the data sets we have displayed in table 2. Whether those selection methods have selected true prognostic biomarker is observed by performing evaluation criteria, that is FDR and FNR, false discovery rate and false negative rate. Where false discovery rate is nothing but is the rate of inactive biomarker among the selected one, where FNR, false negative rate, is that the rate of unselected biomarkers among those which are active. So the first value is explaining about FDR, and the below value explains about FNR, which is false negative rate. The ultimate purpose is to be it should select less number of variable, and it also select all the necessary variables. So in conclusion we'll discuss about this, but comparatively lasso PC will selecting less number of variables, that is given in this table 3. Summary: using simulated data sets, we investigate the variable selection of lasso and some of its extension with a different sample size and a fixed number of biomarkers. From table 2, for each sample size based on a null scenario, all 3 method performs well by selecting no active biomarkers. Whereas in alternative scenario, when Q is equal to 5, 20, 50, the ENet algorithm selected a number of variables that are higher than the other two methods, especially when the sample size is 25%, 50%, and 75%. Comparatively, lasso PCVL selects less number of variables, though varying the sample size in all scenarios. Accuracy of each selection of the predicted model is evaluated based on FDR and FNR. From table 3, when the sample size is 50% and 75%, each method selected all active biomarkers. But still, the rate of false positive is higher except lasso PCVL. Lasso PCVL has minimum FDR with moderate FNR in all cases, whereas lasso CVL and ENet algorithm selection have more false positives. Conclusion. In high dimensional data settings, lasso penalty is a flexible and popular method for variable selection. Generally, choosing the appropriate parameter.
Excuse me, can you conclude now? Already
Yes.
time is running.
Yes, sir. So comparatively, lasso PCVL method performs better than other two methods, whereas lasso CVL and the ENet algorithm selecting more number of variables, that is leading to false discovery rate. So these are the reference.
Okay, thank you,
Thank you,
Divya.
sir.
Okay. Any questions? Okay, if not, we'll go for the next one. Is Girish? Girish is available. Girish, are they?
Yes, sir. I'm present, sir. Girish.
Yeah. Okay. So please present, sir. He is going to present on a new mode matching composite regression model and its application to motor vehicle insurance claim data. So please proceed.
Yeah, just a minute, sir.
Yep.
I will share my screen, sir.
Okay.
So I hope my screen is visible, sir.
Yeah, it is visible, sir. So kindly stick on to time for 7 minutes. Sir.
Yes, sir. Yes.
Okay.
Good evening, one and all. I am Girish Radde from Central University of Rajasthan. So I'm going to present my work on a new mode matching composite regression model for motor vehicle insurance claim data. So this is the outline of my presentation. I will start with the challenges and I will end with the application of our proposed model. So in real life situation, there are random variables may come from a single probability distribution or from a set of distribution. So it is often a challenging task for the actuaries to model such type of data set. So, and in presence of large number of small losses and a small number of large losses, fitting a single density, single probability density to entire data is often a difficult task. And due to larger upper tail, so these are the characteristics of the claim severity data which need to be addressed. So this is the these are the challenges in the modeling law of claim severity data. And what is the need of composite models now? So there is no standard parametric model which is available, which can give an acceptable fit for both small and large losses. So composite model enable us to model these small losses and large losses using two non-overlapping densities, which is an head and tail part. So this is the mode matching technique on which I'm going to present. So for the first model, means the small part will be modeled by a unimodal light tail density up to a mode value. And after that, a second density will concatenate at the mode of the second tail part of the density, which is estimated from the data. And this technique is derived by Caldrin and Koch in 2016, where you can see in equation number 1 stands for the probability density function of a mode matching technique, where XM is nothing but the mode of the second part of the density, which separates its non-two overlapping density. R and F1 star and F2 star are mixing weight and adequate truncation of first and second density. So here I have included some literature on composite model developed using mode matching technique. So I have to mention one important note is that whatever the models are developed above, they use only, oh, I'm sorry, sir. They use only the amount available in the claim severity data. Means what I'm trying to say is that with available claim amount, there are always covariates, other covariates are available with the claim amount, which means the age of the policyholder, gender of the policyholder, he is wearing seat belt or not. So this type of characteristics are needed to be taken place while we are modeling the claim severity data. And such a regression model is not studied in earlier one. But here we are making a first attempt of giving a mode matching composite regression model. There are previous composite regression models are available, but they are generated using a different technique. Now here I am going to present a novel mode matching composite regression model. In the previous composite model, the threshold with separating the non-overlapping density, it is not based on the covariates, but in our So in our model, we are addressing this problem by introducing covariate information in the threshold of the composite model, so that the heterogeneity of the policyholder will also took place while the modeling. And we need such a claim severity model which can sufficiently model the distributional modality, the heavy tail of the distribution, and which can capture the impact of covariates on the different part. Different part, what I mean is that the mixing weight R means a proportion of observation belonging to either of the density. Second one is the peak of the composite density. And third one is the tail heaviness of the distribution. So we need such a model which can have this type of characteristics. And our newly proposed model is an first attempt to make this happen. We have proposed here one mode matching composite regression model, where for the head part of the density, we make use of a log normal distribution. And for the tail part of the density, we use a generalized log model distribution given by Bhatti and Ravi, 2018. And we imply covariate information in the tail index parameter of the G log model distribution. This is the density of generalized log normal G log model without covariates. And we are introducing covariates into the beta, which is the tail index parameter of our composite model. To give covariates flavor to the tail index parameter beta, we use exponential log link function. The reason behind is that the beta is the positive support parameter. So to retrain the support of beta, we make use of exponential link function to link covariates with the tail index parameter beta. And this is the log normal G log model composite regression models density, where you can see instead of beta, we use covariate information associated with the claim amount. This is the interesting slide. So one can see that in the equation number 7, which is stand for the R mixing weight, the beta is also involved in this equation. So what does it mean? It means the mixing weight is also using the information of covariates to decide which observation will go into which density. And this is not earlier case with the composite regression model. Here the threshold which separating the two non-overlapping density will also consist a covariate information. Now, which means each and every policyholder will decide his or her own threshold based on his or her own characteristics. And once we equate these two modes, we can reduce the parameter very easily. As you can see in equation number 8, now sigma can be written as the other parameter, which reduces the computational burden. Means if you provide mu and other parameter, one can estimate the sigma very easily. So these are the advantages that we are introducing covariates into the R, into the mode, which means the threshold, and as well as so this makes a use of heterogeneity that we are encountering through our model. And this is one challenging task for us to get parameter estimate for the unknown parameter. And one can see equation 9 is not a straightforward density.
Sir,
that
excuse me, sir.
Yes, sir.
Sir, can you conclude in 1 or 2 minutes, sir?
Yes, sir. Yes, sir. I will conclude, sir.
Yeah.
So we have used a Optim as a general purpose optimizer, but the optimizer needs valid initial to start the algorithm. So we use, we make use of our own initialization strategy, that using this, we are providing initials to the initial parameter which can start the algorithm. This is the real data application that we showed to showing the versatility of our proposed model. We have taken a motor vehicle insurance data. In fact, this data set motivates us to go for a mode matching composite regression model, which constitutes of 3911 non-zero vehicle claim severities, where claim is the response variable and other as covariates you can see on the slide. Here is some descriptive statistic or summary of the explanatory variable. And these are the important graphs which shows the impact of covariates on a claim severity distribution. One can easily see that the vehicle age is one of the covariate which showing their impact on the peak of the density as well as right-hand side of the density. So this motivated us to introduce beta into the tail index parameter, and which is a part of mode of the data, mode of the composite model. So we are introducing covariates into the right-hand side also, and as well as the mode also. In fact, this is the motivation behind creating mode matching composite regression model. These are the parameter estimates, and this is the log likelihood value. And we use log normal Stoppa and G log model as a competitor model for our log normal G log model. One can see that the difference between NLL is quite significant, as Anderson and Berman 2002 suggested that if the difference in the log likelihood exceeds 10, then our model is significantly different. So here we can see log normal G log model is giving the best fit among two heavy tail regression model. And the advantage is that earlier we will not get a variable threshold. We will get only fixed threshold, which creates problem. It's quite unrealistic many of the times. So as a conclusion, we provided a novel mode matching composite log normal regression model. We introduced covariates into the tail index parameter. We have provided a real world insurance data application to show the versatility of the model. And these are our key references that we followed. And thank you so much.
Okay, thank you, sir. Any questions? Okay, we can move on to the next speaker. Is Sandesh is available? Sandesh Kirkire. Kavita.
Yes, sir.
Yeah,
I'm there.
Yeah, okay. So please present, madam. So you are going to present on crowding out effect, a statistical perspective.
Right.
Madam, please kindly stick on to the time, madam, because
yes,
we have some more speakers.
Yes. So thank you very much for giving this opportunity to present my work. This is actually done by two of us, Sandesh Kirkire, who is ex-CEO of Kotak Asset Management Company, and former IMC Praveen Chandra Gandhi Chair Professor, and I am working in Jamnalal Bajaj Institute of Management Studies. The work is on basically economic phenomena which is called as crowding out, and it arises out of the fiscal deficit. So whenever there is a fiscal deficit, the government will fund it through the government borrowings, which will happen. So the government borrowings will be available to the government agencies to put in the money in the economic activities. Government borrowing could lead to rise in the borrowing cost of the government. And if government is borrowing too much, will it affect the
Sir, I have a question.
money available at the for the other partners or other members of the economy? Every time the economists feel that
Madam, actually slide is not moving, madam.
slide is not moving. Is it visible now?
Yeah, now it is visible, madam.
So if government borrows in large amount, will the money available to the other components of the economy, it will be less, and that will increase the cost of borrowing, is what the philosophy that the economists have. We wanted to, is it changing?
Yeah, okay, madam. Now changing, madam.
Yeah, we wanted to find out that if there is any correlation between the various parameters that we are considering for checking whether this impacts the CPI or interest rates in the economy. And if it is so, then we will be required to find out what are the measures that we will reduce the fiscal deficit and government borrowings. In fact, the government borrowings happens in the economy, and typically the government of India borrows from RBI, the central bank, and then put it into the economy for infrastructure development and other economic activities that government follows through different departments and other initiatives that they have for upliftment of the poor and infrastructure development. In financial year 21, India had almost 50% of its total expenses were funded through these borrowings. And they were either funded by the local investor or RBI, as the RBI is the central bank to the government. There is a very strong banking system, and 18% of the deposits, the banks will have to keep it with government securities as the statutory liquidity ratio. Insurance companies are required to invest more than 50% of the premium received by them on their guaranteed products in the government security. Provident fund pension companies are also mandated to invest 50% of their investment in government securities. And in the crucial situations, the Reserve Bank of India also acts in this economy through open market operations by adjusting the rates of interest and other rates that they decide. So with such a large fiscal deficit and large government borrowing, does the availability of fund to other borrowers in the economy get impacted? With such large borrowing, government cost would rise. And if the government borrowing cost rises, then the interest rate for other borrowers will also rise. Global rating agencies consider the extent of fiscal deficit while rating the country. And if it is impacting our country, then the flow of FII, foreign direct investors or foreign investors, will also get impacted. And that's why this crowding out effect is important as far as the macroeconomic activities are concerned. So we started with understanding that how should we consider that crowding out effect is getting impacted to the other borrowers. Is the funds not available? So we started with identifying that which are the macroeconomic parameters that we should consider. After doing the literature review, we identified that we can have some of the macroeconomic parameters like gross borrowing, net borrowings, net open market operations of RBI, CPI, aggregate deposits.
Madam, excuse me, madam, your screen sharing has stopped, madam.
Foreign reserves, etc. Is it visible now?
Yeah, now it is visible, ma'am.
So we identified such parameters which are impacting the macroeconomic activities in the government. And then after doing that, we tried to find out the correlation analysis and regression analysis. The data was collected from RBI website, and for 8 years, starting from 2012 to 2021, almost 430 weeks data was considered. And then the data consisted of gross borrowings of the government, commercial advances given by the banking system, and the 10 years benchmark for government security yields, as also the CPI, and the net open market operations of RBI was considered. We considered regression across government borrowings and advances to commercial sector to find if government borrowings had any impact on the advances of the commercial sector. We did regression analysis to understand the government borrowings with the rates using the 10 years government security yield. Also with CPI and RBI net open market operations and the interest rate. We also considered interest rate with CPI. And surprisingly, though the economic scientists and the economic theorists are proposing that the crowding out effect will definitely have great impact on the macroeconomic activities, but the correlation analysis and the regression analysis that we have attempted on this is not showing any such relationship strongly. So government borrowings have no relation with the advances of to the commercial sector. The government borrowings had a very weak kind of relationship with the interest rate, and the relationship is better when considered the borrowing of the year 2021. But we all know that this is an extraordinary year where the commercial economic activities were slowed down, and only the government was pouring in the money for the development. So this is an extraordinary year, and in that year only we are seeing that there is some influence. Financial year 2021 borrowings by the government was highest, and it was more than 60% of the previous year, financial year 20. So with the analysis, the CPI had a strong relationship with interest rate, and RBI.
Madam, excuse me. Madam,
yes,
can you conclude, madam?
Yes, sir. Yes. RBI open market operations also had a weak relationship with interest rates. So when we are looking at the data for over 8 years, where only the last part was having some impact of pandemic, the hue and cry that is made out of this crowding out effect does not hold in a statistical perspective. So this is what we have identified. And also we are trying to look at how we can see the seasonality impact. So the study is still on, but the preliminary impact of government borrowings to the available cash in commercial spectrum does not have any impact. Thank you very much.
Okay, thank you, madam. We can move on to next speaker. So, is Dr. D. Lalita Devi is available? Or
yes, sir. Yeah, today I'm giving the presentation on behalf of Lalita.
Okay, okay, right. So it is your topic is on lifestyle and health, a triple 2-part and parcel, a case study.
Yes, sir. Yes.
Yeah, please go on. And one more thing, the upcoming presenters, please remind that we will be having a time around 5 to 6 minutes. Already you are running out of time, so kindly note that.
Yes, sir. Thank you. Good afternoon, everyone. My name is Divya from Department of Statistics, Kasturba Gandhi Degree and PG College for Women. Let me share the screen, sir. Sir, is my screen visible to you, sir?
Yeah, it's visible. You can make it
Hello?
as full screen.
Yes,
Yeah,
sir.
now it is visible. Okay, okay.
Thank you, sir. So the title of our paper is Lifestyle and Health, a triple to part and parcel, a case study. Let us discuss the background of it. Earlier, the food, which is the mixture of natural ingredients, now turned to a combination of artificial ingredients. So today's society is undergoing rapid change. Due to that, the lives that contain high levels of physical effort to a lifestyle with no regular or irregular physical activity. Let us see the introduction of our topic. The lifestyle is a way used by the people, groups, and nations and is formed in specific geographical, economical, political, cultural, and religious texts, etc. And the variables which are involved in lifestyle are diet, exercise, yoga, etc. Let us see the brief of these topics. Diet is the greatest factor in lifestyle and has a direct and positive relationship with health. And the factors include, or the foods that are included in the balanced diet are fruits, vegetables, grains, dairy, and protein foods, etc. We just want to discuss a new type of food which is known as rainbow colored food, which consists of phytonutrients, and it is advisable to eat this kind of food to enhance the health conditions. Let us see the benefits of balanced diet. Opting for a balanced diet can lead a path to healthy lifestyle. And let us see the consequences of having a poor diet, which is obesity, and it is nationally declared as epidemic. And one of the major factors of it is hypertrophy, which means the multiplicity of fat cells, which can result in the gain of weight. Exercise. So let us see a few benefits of it. It controls weight, combats health conditions and diseases, improves mood, and boosts energy. Let us see what is yoga. It is an ancient practice and it is derived from a statistic word which is known as yog, means union. So hence yoga is the union of organ systems in the body with consciousness in the mind. These are few benefits of practicing yoga regularly. Meditation. Meditation is nothing but set of techniques that are intended to encourage a higher state of awareness and focused attention. And the benefits of practicing meditation are as follows. Medication. This happens regularly, and unhealthy behaviors in such medication are as follows, which is due to self-treatment, sharing medication, using medication without prescription. Sleep. It is also essential as food and water to us. And the first thing comes into our mind is how much sleep do we need to have? So according to National Sleep Foundation of American Academy of Sleep Medicine, the sleeping hours should be 14 to 17 hours for newborns, 12 to 16 for infants, toddlers 10 to 14, adults 7 to 8, and so on. Let us see the objectives of our study. To know the awareness of healthy lifestyles and its importance, and we wish to find the ways to combat several diseases using healthy diet. So we have collected a sample of 205 using the Google Forms on awareness and importance of healthy lifestyle in and around Hyderabad. Data is compiled and analyzed for percentages and proportions. And the main objective of our study is to know the health practices of the people. And we have observed that 62% of the respondents have dinner at 8 p.m. and so on. These are few diagrammatic representations of our observations, and we have used Likert scale for few questions as well. So these are the references which helped us to gather information, and we have analyzed the data using SPSS software, and we have observed that there's a relationship between the dinner time and the students suffering from obesity, and eating habits are correlated to frequency of visiting hospitals. And thank you.
Okay, thank you. Then we can move on to next speaker. So is Manas Ranjan Tripathi is available?
Yes, sir. I'm.
Yeah, please start your presentation. So he's going to present on classification and regression tree modeling with applications to endometrial cancer survival data. So please stick on to time for 5 to 6 minutes, sir.
Okay.
Please stop sharing, Ms. Divya, previous one.
Sorry, is it visible? My screen is visible?
Yeah, 1 second. Yeah, it is visible, sir. Please proceed.
Thank you, sir. Okay, so good afternoon, everyone, respected chairperson and all the participants. I am Manas Sanjan Tripathi, a PhD research scholar from the Department of Statistics, Variance University, Cuttack, Odisha. I'm doing my PhD under Dr. Prafula Kumar Swami, Assistant Professor, Utkal University, Bhubaneswar. So today I'm going to present the research outcome of my topic. It is classification and regression tree modeling approach to predict the number of lymph node dissection among endometrial cancer patients. So these are the outlines, which consist of introduction, data sources, material and methods, and analysis and results with the conclusion and the references used. So classification and regression tree is a non-parametric statistical modeling technique. For the simplicity, in the modeling, the interpretation, for the simplicity of the modeling and interpretation, it has been widely used in the statistics, health sciences, computer sciences, and meteorological sciences. So this method was developed in the year 1963 by Moran and Sanket, and after that it was by Breman et al. In the year 1984. So CART has been used to regulating and developing different health policies nowadays. And endometrial cancer, as my topic is modeling the endometrial cancer patient data. So the endometrial cancer arises from the uterine adenomyosis, and its diagnosis may be very challenging in the patients because they refuse to report themselves, and might be they report on advanced stages. And the awarenesses and timely test can reduce the diagnosis delay. Endometrial cancer emerged as the 6th most common gynecological cancer among women worldwide. However, in the developed country, it is the 5th most common type of cancers, with the incident rate 4.8%, and with the death cases, it's around 2% worldwide. So it's around 0.88 million endometrial cancer cases in the of the 8 standardized incidence rate, 105 per 1 lakh women in India, and the identification of the number of positive lymph node in early stage may prevent the progress of advanced stage cancer among the patients. So here we proposed a CART model to predict the number of lymph nodes required using some informations on their covariates and its levels. So data taken for this study was from the local hospital, that is Acharya Harihara Postgraduate Institute of Cancer from Odisha, and it is a cancer hospital situated eastern part of the country. And the data was collected from 170 endometrial cancer patients on their number of lymph node involved and some of their covariates by age, post-menopausal bleeding, obstetric history, status, tumor size, their histology, their grades, their myometrial invasion, and so on. So now coming to the material and methods, let us consider a regression problem with the continuous response variable YI be the number of lymph nodes dissection from the ith endometrial cancer patients, those having P predictors, X1, X2 up to XP. And this problem can be like modeled into a regression framework, which is denoted in the equation 1. So in this ordinary regression model, the parameter beta can be easily estimated. But however, if the data structure suffers from different restrictive assumptions, then these results may get a poor fit. To overcome these limitations, we can use a non-parametric approach, that is CART approach. So now coming to the regression tree, this is based on the two approaches. One is splitting criteria and one is cost complexity criteria. So to make a regression tree, we have a data set consists of a response variable yi, that is our number of nodes, and P predictors, that is xij, and each having a set of n observations. And consider a data space divided into m regions, that is R1, R2 up to Rm. Then we can model the response Cm, which is a constant on each region, that is Fx, which is represented in the equation 2, where Cm here is the output value that lies in the region Rm. Here I is the indicator functions which will decide the value will lie in the region Rm or not. So as in the every regression analysis, the main aim is to minimize the sum of square. So here also we like minimize our sum of square, which is given in the equation 3, where Cm is the average value of yi given all the value of xi in the region Rm. Now the splitting criteria can be followed as if we have the available
excuse
data.
me,
Yes.
kindly conclude in 2 minutes.
Okay, sir. Okay, so this is the splitting criteria. So we have to minimize the error in the selected area. So now then we have to follow also a stopping criteria, because to continue to grow the tree is seems like overfitting the data, and if you stop growing the tree, then we may miss the interesting pattern in it. So according to Hasty et al. 2009, he has said up to minimum 5 nodes we can split the tree. Okay, so validation of the model can be verified by these criteria, and all the statistical analysis were done by R and spaces, and the significant value is taken for p value is less than 0.05. These are my patient characteristics. All the major patients, like the range of the age of the patients varying from 25 to 18, with the mean age 56.86, and all the other criteria are there. Okay, so now here it is the splitting strategy of the CART modeling. Here we can see this is the root node with the 170 patient, and the first splitting variable we have like it is tumor size, where the 2 nodes of the relation tree is less than 1.9 centimeter and another node is 1.9 centimeter. Here the dotted line represents these are the parallel nodes. Okay, these are the second node and third node, and these are all the parallel nodes. So this is also represented in the regression tree. Okay, so the more dense in the color represents the patients with the more risk. So in this CART model, we can find out there are 2 significant predictors on the lymphadenectomy, that is tumor size and its status. And the outcome of the model says that patients with the tumor size greater than 1.9 centimeter are in the high risk, whereas in the less than 1.9 centimeter patients are in the lower risk. Similarly, we can find out the patient status if they are in the status para-aortic are in the high risk, whereas the other side, the pelvic status, then they are at the lowest risk. And validation of the model can be achieved by different criteria, like we can compare the ROC curve. These are some parameters we can to compare different models. So here we are using these parameters to compare the multiple regression model with the CART model. Here we can see the area under the curve is greater in the CART model. Similarly, in the accuracy, we can find out 95.9% accuracy in the CART model. Okay, so in the conclusion, we can say the CART model in the study suggests that information on the tumor size and the status help us to predict the required number of lymph node dissection with a greater accuracy. And these are my references. Thank you.
Okay, thank you. The next speaker, Mukta Deshpande, is available.
Yes, sir. Yes, sir.
Yeah. Okay. So please present. Your topic is on random permutations and data structure.
Yes, sir. Just sharing screen.
So Manas Tripathi, can you stop sharing?
Yes.
Yeah,
Yes,
okay.
sir.
Sir, is the screen visible?
Yeah, it's visible, ma. And please stick on to the time, 5 to 6 minutes.
Yes, sir. Yes, sir.
Yeah.
Thank you, sir. Good afternoon, sir. I am Dr. Mukta Deshpande, and my today's topic of presentation is random permutations and data structure. As we know, the data structure is an important branch of computer science, and binary search tree is the popular data structure considered for data storage. Binary search trees are generally constructed using the permutation of an ordered set. We have studied and proposed here one method of generating permutation, and our main focus is on the study of random variables associated with binary search trees constructed using the resulting permutation. Data structure is the logical or mathematical model of a particular organization of data, and it can be both linear as well as non-linear. But our study is based upon an important non-linear type of data structure, namely the binary search tree. Binary search tree has the different features associated with it, like total number of terminal nodes, element at the root, and depth of the tree. If we choose a random permutation of integers 1 through n and construct a binary search tree, then these features of the resulting binary search tree are clearly random variables having different properties. So we define a binary search tree as a labeled binary tree, a labeled binary tree that is either empty or has a labeled root node. And as seen from the diagram, all the labels in the left subtree are less than the root label, and all the labels in the right subtree are greater than the root label. And each left and right subtrees are themselves binary search trees. These are some basic terminologies which are commonly used with binary search trees as well as binary trees. Now let us construct a binary search tree. Here we define pi equal to pi1, pi2, and so on up to pi n with the permutation of integers 1 to n. Then the first element pi1 becomes the root of the search tree. If pi2 is less than pi1, then the element pi2 goes to the left subtree and is placed as the left child of the root. Otherwise, pi2 goes to the right subtree and gets placed as right child of the root. Subsequent elements of the permutation are guided to the left and right subtrees according to whether they are less than or greater than the root label. Here is one illustration. For n equal to 9, we construct binary search tree, and here node number 8 is the root of the tree. Node number 2, 5, 7, and 9 are the terminal nodes, and the depth of the tree is defined as the longest path starting from the root of the tree up to the terminal node. Now our study is based on generating a random permutation, then using the resulting permutation to construct a binary search tree, and then study random variables associated with it. Here first we see the permutation generation method, which is based on a coin tossing experiment. So we toss an unbiased coin n number of times and note the trial numbers resulting in heads and those resulting in tails separately. Let x1, x2 up to xk be the toss numbers that result in heads, and y1, y2 up to yn minus k be the toss number that result in tails. The observations are arranged in ascending order of their magnitude. We collect these two sets in two groups, group 1 and group 2. And the permutation of integers 1 through n is obtained by setting pi I is equal to pi xi is equal to xi plus 1 for I equal to 1, 2, and so on up to k minus 1, and pi xk equal to x1. And by setting pi yi equal to yi plus 1 for I equal to 1 to n minus k minus 1, and pi yn minus k equal to y1. It may be noted that if either k or n minus k equals 1, then pi xk equal to xk and pi yn minus k is equal to yn minus k. Here is one example. For n equal to 7, we toss coin for 7 times and note down the toss numbers. And the number of observations are grouped into two groups. Group 1 contains elements 1, 2, 3, and 7. And we set the permutation as pi1 equal to 2, pi2 equal to 3, pi3 as 7, and pi1 equal to pi7 equal to 1. Similarly, for group 2, the elements are 4, 5, 6, which are all tails. And then we set pi4 equal to 5, pi5 as 6, and pi6 equal to 4. Then the resulting permutation is given by equal to pi. It is observed that in the above experiment, if the outcomes of the tosses are interchanged by heads and tails, then it may lead to the same permutation as before equal to pi. Thus, every permutation corresponds to two sets of outcomes of n tosses, and the probability of generating the permutation is equal to 1 upon 64.
Now in the combinatorial aspects, the total number of possible distinct permutations is 2 to the power n minus 1, and all permutations generated are equiprobable. Here are some possible permutations for n equal to 5, and the corresponding probability is 1/16. Now, once the permutations are ready, we construct binary search tree and study a random variable pi1, that is the element at the root of the BST. This is for n equal to 5. For n equal to 13, the binary search tree may take a look like this. Now in statistical aspect, we study the probability that 1 is not a terminal node of binary search tree is 1/4. The probability is surprising as it is independent of n. Similarly, the probability that n is not a terminal node of binary search tree is equal to 1/4 plus 1/2 to the power n minus 1. As we were unable to prove this particular probability theoretically, we propose it as a conjecture. Now the probability distribution of random variable pi1, as defined earlier, pi1 denotes the element at the root of the binary search tree. It can range from 1 to n, and its probability distribution is given by 1/2 to the power n minus 1 for I equal to 1, and 1/2 to the power I minus 1 for I taking 2, 3, and so on up to n values. The graphical representation for the probability distribution of random variable pi1 shows that it is positively skewed. Now we calculate expected value of the random variable pi1, and it is observed that it tends to 3 for large values of n. Now the conclusion. Here we introduced one new method of generating random permutation based on a coin tossing experiment, and statistical properties of the random variable pi1, that is element at the root, are studied. We also obtained one surprising result, that in a binary search tree, the probability of integer 1 not being a terminal node is independent of n, and a conjecture related to the similar event has also been proposed. These are the references which I used to prepare this particular paper. Thank you, sir.
Okay, thank you. We move on to our next speaker. Is D. Lalita Devi available? Or K. Sangeeta?
Yes, sir. I'm here, sir. Pavani.
Yeah, Pawan is going to present. Right, okay. So it is on topic shift in paradigm from traditional learning to e-learning. Please go on.
Yes, sir. Yes. Good afternoon, everyone. My name is Sai Pavani from Department of Statistics, Kasturba Gandhi Degree and PG College for Women. Just now, I will share the screen. Yes, sir. Is it visible to you also?
Yeah, it's visible. You can make it full screen.
Yes. Now it is okay, sir?
Yeah, now it is okay.
Okay, thank you, sir. My paper title is Shifting Paradigm from Traditional Learning to E-Learning, a Case Study. These are the relevant images of ICT and impact of ICT and education. That is, ICT means information and communication technology. So let's see the background of ICT. Education is one of the main cornerstones for economic development and improvement of human welfare. A well-educated and skilled workforce is one of the core pillars of the knowledge-based economics. This realization makes the reforms in education and development to remain a central preoccupation for many countries and for international development. What is an ICT? ICT is the short form of three basic terms: information, communication, and technology. Information help in decision making. The term communication may be referred as imparting or exchanging of information by speaking, writing, or using some other medium. Any communication has four essential elements, namely sender, message, medium, and receiver. Technology refers to the methods, systems, and devices which are a result of scientific knowledge being used for practical purpose. Technology can be used for creation and communication of information. The term ICT, Information and Communication Technology, includes various forms of technologies that are used to create, display, store, process, transmit. ICT. So therefore, the examples of ICT is a radio, television, and
Oh, you are not audible, Pavani.
not. Yes, sir. Is it now? Am
Yeah, your voice is having,
audible?
no, your voice is having some break. Now it is okay.
Yes.
Continue.
It is okay, sir. Now.
Now okay, ma. You continue.
Yeah. Okay. Thank you, sir. Every technology have benefits and challenges of ICT are benefits of ICT tools. Communications channels are increased through email, discussion groups, and chat rooms. So let's see the benefits for teachers. ICT facilitates sharing of resources, expertise, and device, easier planning and preparation of lessons and designing materials. Let's see the benefits for students. Flexibility of anytime, anywhere access, development of higher level learning styles, opportunities to address their work to an external audience. Let's see the benefits for parents. Communication on the parents and cases improved self-esteem. Let's see the challenges in use. Limited accessibility and network connections, lack of effective training, limited time, institution with limited technical support. The objective of ICT are to see the awareness about the ICT tools and its importance, to find out the opinion of teachers, students, and parents on mode of classes, to give the diagrammatic representation of the collected data. So what is the methodology of ICT is a sample of 339 was collected using the Google Forms on awareness and usage of ICT tools in and around Hyderabad. To answer the main objective of this study, that is difference between virtual and e-learning using ICT tools. From the collected data, we have observed that 82.6% of the respondents learn in and offline mode. These are the diagrammatic representation of the observed responses. For the 5% respondents, and in this diagrammatic representation, 89.7% response enroll in online learning platform like Byju's, Vedantu, etc. And the conclusion of this this paper is, by performing basic analysis on the available data, we observe that most of the respondents are interested in offline mode. There is a relationship between online mode of classes and number of people joining another online learning platform. These are the references which help us in gathering information. Thank you so much.
Okay, ma. Thank you. Next, we can move to the next speaker. Adira Krishnan is available.
Yes, sir.
Yeah, okay. Please start presenting, ma. So she is going to present on E-Bayesian estimation and its EMSE for Chen distribution based on type 2 censoring scheme.
Adira Krishnan RB, Research Scholar, Department of Statistics, University of Kerala. First, I thank ISPS organizers for giving me opportunity to present my paper. The topic of my presentation is E-Bayesian estimation and its EMSE for chain distribution based on type 2 censoring. This is a joint work with my guide, Dr. A. Abdul Sattar, Professor and Head, Department of Statistics, University of Kerala. The outline of my presentation is Introduction, MLE, Bayesian Estimation, E-Bayesian Estimation, EMSE, then Properties, Numerical Study, Conclusion, then Reference. Experiments in reliability and F-testing are conducted to acquire information about the time of some event of interest, the time to failure of a component, the time to remission of a disease, or the time to death of a biological unit are some examples that give importance to the time of occurrence. In most of the studies, complete information on the lifetimes or failure times of experimental units may not be at hand for several reasons. Data thus obtained are called censored data. In the literature, most commonly found censoring scheme is type 2 censoring. Inference under type 2 censoring scheme for different parametric families of distributions have been extensively studied in the literature. For more details, one can refer to the cited examples. In the reliability literature, for most commonly used models to analyze various real-life data are generalized exponential, gamma, Weibull, log normal, whose hazard functions are constant, increasing or decreasing in nature. However, these models are not suitable for the data sets which exhibit Bardab-shaped hazard rate. Several authors have introduced a probability model such as modified Weibull, extended Weibull to analyze real data with Bardab-shaped failure rate. But they are still not suitable to produce good Bardab-shaped failure rate. Chen in 2000 introduced a two-parameter lifetime distribution with Bardab shape. Chen distribution is an appropriate model for analyzing the lifetime of electronic and mechanical products as well as humans. Further, it can be used for modeling positively skewed data apart from the well-known models such as log normal and gamma. Who in 2008 derived MLE of the parameters of Chen distribution under progressively type 2 censored sample. The MLE based estimator of the parameter of Chen distribution using complete and censored samples are derived by many others. Some of them are caught here. The literature on the estimation procedure for Chen distribution discussed above mostly focus on MLE and Bayesian procedures. In addition to the Bayesian approach, E-Bayesian estimation method was developed in the literature. The definition for E-Bayesian estimation was originally addressed by Han and Ding in 2004. The E-Bayesian method is more robust than Bayesian since it considers the prior distribution of the hyperparameters also. In recent days, so many works related to the E-Bayesian inference of parameters and reliability functions of different distributions using complete and censored samples are discussed in the literature. For more details, one can refer to the cited examples of research papers. These above works offered inspiration to another avenue of investigation on the topic of E-Bayesian estimates for the scale parameter and hazard rate of Chen distribution under type 2 censoring scheme and derive the EMSEs of the proposed estimates. Now let's see the maximum likelihood estimation. Here we are considering the PDF, CDF and hazard rate of Chen distribution. We will get the likelihood function of the type 2 censored sample as in equation number 4. And obtain the MLE of the parameter theta as in equation number 5. Next is Bayesian for estimates. We have chosen error, entropy, and precautionary loss functions and the conjugated gamma prior density with the probability density function as in equation 6. Here A and B are the hyperparameters. We will get the posterior density of theta as in equation number 7. Theorem 1 gives the base estimates of theta and hazard rate under different loss functions, and the expressions are
Adila Krishnan.
Hello.
Yeah, Adila Krishnan, you are not now. You are audible.
Sir,
you have to present the screen again.
Am I audible, sir?
Yeah, now you are audible, ma. Yeah, now the screen is visible. Now you are not audible again. There is some network problem for Adira Krishnan. You can check with the next speaker. Is the next speaker available? Bipin Gokoi. Bipin Gokoi is not available. Yeah, Miss Adira Krishnan. Adira Krishnan, you are not audible till now. So better we can hold her for a minute. Then we can move to the next speaker. Is Bipin Goka is available? Not available. Okay. Is
Jabir is available, sir. Jabir.
Is Jabir is available? Jabir.
Yes, sir. Yes, sir.
Yeah. You can start present now.
Okay.
He's going
Okay,
to
sir.
present on a new generalization of inverse exponential distribution
sir.
and applications.
Hello? Hello?
Hello,
Yeah.
sir.
Adira Krishnan, you hold on. Next presenter is going to present. Then you can present.
My name is, good afternoon, everybody. My name is Jabir, Department of Statistics, Government Arts and Science College, Kozhikode. My topic is new generalization of inverse exponential distribution and its application. First, I will give you some review of literature of my work. The probability distribution models mainly.
Yeah, Jabir, excuse me, Jabir, 1 minute.
Yeah.
Yeah, other question has to stop sharing. Your screen is not there.
Okay.
Adira Krishnan, can you stop presenting? Yeah. Yeah, now you can present your screen, Jabir.
Is it visible, sir?
No, not visible. Jabir still not visible.
Sir, 1 minute, sir. Sorry, sir.
Just now it got visible.
Sir, is it visible?
No, previously it was visible. Now it is not.
Okay. Is it visible, sir?
No, not yet.
Is it visible, sir?
Yeah, now it is visible.
Okay.
So please conclude in 5 minutes because
okay,
you have
okay,
to go for next valedictory.
Okay. So these are my review of literature. Azalini in 1985 and Marshall and Olke in 1997 and Gupta in 1998. They were pioneers in this area first, and in 2013, Cordero proposed a new class of distribution with the addition of Timor shape parameter This is the introduction of additional parameters have been proved helpful in studying tail properties and also for providing a better goodness of fit of the distribution. For this, 2020 Modi et al. Proposed a new family of distribution with the application of two real data sets on survival problem. Now we define the Modi family. The PDF and CDF of Modi generator are respectively given in equation number 1 and equation number 2. Now we define the inverse exponential distribution. The PDF and CDF of inverse exponential distribution is given in equation number 3. Now we combine inverse exponential distribution into Modi family distribution, and we can generate a new model proposed distribution, which is known as Modi inverse exponential distribution. Its PDF is given by equation number 4, and its graphical representation is given, and its CDF is given in the equation number 5. And these are the graphical representation of its distribution function for the different combinations of alpha, beta, and theta. Now we derive the hazard rate function of the proposed model, and hazard rate is given equation number 6, and its graphical representation is given figure 3 for the different parameter values. And we derived its survival function, which is given in equation number 7, and its survival graph is given here. And we derived the mode of the proposed distribution, and which is given in equation number 8. We can find mode by equation number 8 for various values of alpha, beta, and theta. Now we derived the moments for the proposed distribution, which is given in equation number 9. And the same way, we calculate the maximal likelihood estimator in the equation number 10, 11, and 12. If we are solving these three equations and equating to 0, we get the MLE of the proposed distribution. And after that, we derived the order statistics of the proposed distribution. Here we are derived the rth order statistic, which is given in equation number 13. Now we will move to the application of the real life data. In this section, the proposed Modi inverse exponential distribution is applied to two real data sets. We observe its flexibility over some well-known existing distribution. The result for the analysis in this present study are obtaining using our software. We have also calculated the AIC values and p-value for the considered distribution to observe their fit. Meanwhile, the distribution with the highest log likelihood value or the lowest AIC is considered as the best. Here we are taking some of the distribution, Barrett's 11 distribution and log logistic distribution, Bible distribution, Duncan distribution, Modi inverse exponential distribution. We are comparing those distribution with Modi inverse exponential distribution with two set of data. Here the data set 1 and the data set 2. Here we are taking the H0 as the data follows Modi inverse exponential distribution, and H1 the data do not follow Modi inverse exponential distribution. Then we get the MLE estimate of the Modi inverse exponential distribution parameters and AIC values for the data set 1 and data set 2 are given by the following table 1 and 2. For the set of data, the Modi inverse exponential distribution has the highest log likelihood value among other well-known distribution and the lowest AIC value. Thus, making it fit, we can conclude that our proposed distribution is more fit the well-known distribution. These are the AIC values and log likelihood value. Here given the well-known sum of the distribution, Bible, log logistic, Dungham and Burke distributions, and his AIC values and log likelihood value. from this table, we can observe that the Modi inverse exponential distribution EIC value is very low. So we can conclude that from this above distribution, this distribution is more better than the remaining distributions. So these are my conclusions. In this paper, we introduce new generalization of inverse exponential distribution called Modi inverse exponential distribution. We obtain various statistical properties of the proposed probability distribution and introduce parametric estimation technique for the parameter estimation, mainly MLE, and also introduced order statistics. We applied the proposed distribution to real data sets. Results showed that this distribution is better fit than some other well-known distributions. These are my reference. Thank you, sir.
Okay, thank you. So with this, we came to end of our presentation session.
Hello, sir.
Yeah, yes.
Sir, I am Adira Krishna. May I continue my presentation, sir?
Already the time is up. Can you go for only? I can give you 2 minutes. Already the time is over.
Sir, other halls also there are sessions going on, so I think we can allow.
So can we allow, sir?
Yes, sir, we can allow.
Yeah, okay. Okay, other question, you can continue.
Okay, sir. Thank you. So I continue my presentation from this slide. Now, Bayesian estimation was first introduced in the literature by Hananding in 2004. Here also, we have chosen 3 prior distributions and 3 loss functions. Hananding in 2004 stated that the prior distribution of the hyperparameter should be determined to ensure that it is a decreasing function in theta. So the hyperparameters A and B should be selected with the restriction of 0 less than A less than 1 and 0 less than B less than C. Definition 4.1 gives the definition of the E-base estimate of theta. Definition 4.2 gives the EMSE of the E-base estimates of theta. The prior distributions of hyperparameters we used are given in equation number 20, 21, and 22. These prior distributions are used to guarantee that pi of theta given AB is a decreasing function in theta. Theorem 3 gives the E-base estimates of theta and hazard rate under different loss functions by using that first prior pi 1 AB. Theorem 4 gives the E-base estimates of theta and hazard rate under different loss function by using that second prior density pi 2 AB. And the expressions for the estimators are given in this theorem. Theorem 5 gives the E-base estimates of theta and hazard rate under 3 different loss functions by using that third prior density pi 3 AB, and the expressions are given in this theorem. Next is EMSE of the E-base estimates. These are the expressions for the EMSEs of the E-base estimates that we have derived above. Next is the properties among estimators. Some important properties of E-Bayesian estimates and EMSE of the E-base estimates are discussed here. Theorem 6 gives the relationship of E-base estimates of theta by using different prior distributions under different loss functions. Theorem 7 gives the relationship between the E-base estimates of the hazard rate using different 3 priors under different loss functions. Theorem 8 gives the relationship of EMSEs of E-base estimates of theta by using 3 prior distributions under different loss functions. Next is numerical study. We study the performance of the estimators derived in this article by using a simulated data and a real data, which is the graphed survival times in months of 148 renal transplant patients reported by Han et al. 1994. These are the results of simulation. From these tables, we can conclude that bias and the MSE of different estimates decreases as n increases. Bias and the MSE of different estimates decreases as r increases. Bias and MSE of different estimates in pi 3b are less than pi 1 and pi 2b. E-base estimates of theta performing better than Bayesian in terms of MSE. Next is real data analysis. These are the computer results from that real data. From these tables, we can conclude that Bayesian estimates perform better than MLE and Bayesian estimator in terms of MSE. Next is conclusion. Real data and Monte Carlo simulation are used for computing the estimates, and the comparison of these estimation methods are also carried out. Important finding of the study is the superiority of the proposed estimator with the existing estimators. We also study the effect of various loss functions and prior distributions theoretically. Important concluding remarks are: the deviation estimate of theta have minimum MSE among all other estimates. Estimates of theta based on entropy loss function with the prior distribution pi 3 AB have minimum MSE comparing with other estimates. For fixed value of N and R, the MSE is less for deviation estimates as compared to the Bayesian and MLE. After all, the performance of the proposed estimates are better than Bayesian and MLE in terms of MSE. Next is reference. These are some of my important references. Thank you, sir.
Okay, thank you, Adhara. So with this, we came to end of our presentations. Thank you all the presenters. I also once again thank the organizers for giving me this opportunity.
I would like to thank Dr. M. Venkateshwaran sir for chairing this session. Thank you so much, sir.
Thank you, ma'am.
Jayashree madam. Professor Jayashree. Ashapatik?
Yes, sir.
I think you have come from a different session, right? Like that.
Yes. I have from B hall B to hall A. I joined.
Okay. I think there are some sessions still going on. I think.
Okay, maybe, sir.
Okay.
Yes, sir. Still session going on, sir. In CND going on, sir.
Oh, CND still going on.
Yes, sir.
So just in a 2 minutes, company is going to come on.
Okay.
What, Dr. Isapathic Das?
Hello, sir. Hello, sir. Good evening.
How are you? Good evening.
Good evening, sir.
Okay.
Sir, good evening, sir.
Yeah, good evening, Swaran. Yeah, morning you didn't come as Isapathic for the award ceremony. It seems you are not there. Maybe you are having class. Today,
Yes, sir. Today Sunday, but I had some other institution that asked me to some FDB program. So
okay.
Yes, sir.
What happened that agriculture college? No, have you discussed with Lavanya?
No, sir. I will discuss next week. Last 2 weeks I had some other assignments.
Yeah. Before
Yes.
going, you please inform so that I will put a word to her.
Okay, sir. Okay, sir. Yeah.
Sure.
Yeah. So I thought some research proposal. So I will discuss with.
Professors.
Yeah, good evening, madam. Good evening, madam.
Good evening, madam. Good evening. Good evening, sir.
Yeah, good evening, madam. Good evening. What, brother Malik?
Yes, sir. I'm here. Yes. Now I'm watching and observing all things from home.
Oh, I see.
Yeah, but your background, there is some change in your background.
No, background actually I'm at home now.
Yeah, that's why
I'm at
doors
home.
are open.
Yeah.
Yeah, Ishpathik looks like he is in some stars galaxy.
Yeah. This is virtual background, sir. I was also at home.
Yeah, I think you are in somewhere in the stars. I saw.
So he himself is a star, no?
Okay.
Oh, sir, I'm student.
You are a student of IIT.
I'm student of sir, all respected sir. I'm the student, sir. All others are my teacher respected. Professor Sumesh Kumar, all others. Professor Balakrishna, sir.
I am very happy that Professor Dr. Koduri Srinivas watching all the events of our ISPS.
Very kind of you that included me, sir. I think he attended all the sessions.
Yeah, all the sessions. Very nicely.
Dr. Srinivasan is based in Hyderabad now?
Yes, sir. I do have 2 or 3 major assignments. Sometimes I be expected to go out of Hyderabad also. But mostly these are stories of parallel processing. Then you're dealing with the Internet of Things, standards for IEEE. Then again, coming back, we do have certain problems that Professor Pandit sir has left behind. We need to calculate the eigenvalues for them. Eigenvectors we have already solved, but the eigenvalue problem has remained tough. He has got 8 such transforms. Somesh Kumar sir is from IIT Kharagpur. Am I correct, sir? Yes, sir. Yeah. Professor Pandit was with IIT Kharagpur in the early 60s, sir. Who was
Good evening to all.
Professor Narahari Pandit. Then Professor Bhattacharya. Yes. Professor Bhattacharya was an examiner. Yes.
Professor S.N. Pandit, S.N. Narahara Pandit.
Yes, sir. Shall we start, sir?
Actually,
Whether all the halls are free now? I mean, other sessions are over?
Yeah.
All are.
What about D sessions? Hall D?
I mean, we need to confirm the session chairs, sir.
Yeah, please ask Professor Krishna Reddy. He was there in section D, Hall D.
It is completed, sir.
Okay, then fine. Yeah. Okay.
Krishna, the brother.
Professor Reddy garu, good evening.
Good evening. Elangavan, how are you?
Yeah, fine, sir. Tomorrow is NAC accreditation. Tomorrow on 14, 15, 16. Visit our university.
Oh, Annamala University. You are all going to busy.
14, 15, and 16, 3 days.
So Venkatesh has to present.
Yeah, Venkatesh has to present.
Did Krishna Reddy is there or he left? I think he left. Oh. Krishna Reddy, good evening. Krishna Reddy, good
Oh,
evening.
he's there. Namaskar, sir. Srinivas here. Krishna Reddy, sir.
Yeah.
Student.
Srinivas, hello. How are you?
Fine, sir.
Yeah.
ఏంటి కృష్ణారెడ్డి గారు ఎలా ఉన్నారు?
Yeah, I'm fine. And by end of this month, I am
planning to.
Yeah. And I may go to join my son in mid of May.
Oh, Austin. Okay. Yeah. Austin, Houston. Both are you are going.
Yeah, at both places. And
so you are not giving a chance to them to come back, to come to Hyderabad and stay with you, and so you are planning to go.
No, they came.
I see. Next month,
My son came in January, December, January.
Okay, next month BLSP is planning to go. BLSP.
Okay.
He told me that today afternoon that
I am going purely on my family.
Yeah, I know that.
Academic.
Flights and other things, schedule, logistics are worked out, sir.
What, Srinivas?
Flight details and logistics are worked out.
I don't understood.
Flight, you are going.
Yes, yeah. My from 27th onwards, now all flights will be operational.
Okay.
So yeah, he has not booked the ticket. He is about to book the tickets.
Fine, sir.
Yeah.
So from now onwards, I will be 50% months there and 50 months here.
Oh, that's good, sir. Do you get to see other people, sir? Your senior colleagues like SS sir, Surendra Naidu sir, and
Yes. Yeah. Now,
where are they, sir?
Recently, Hargopal arranged a meeting with Surendra Naidu and Srinivas.
Okay.
And also most of your contemporaries, Bhanumurthy, Jayanti, and about 20 people joined in that Zoom meeting.
Okay. Ramna, Rahul, all these people would also have been part of that.
Yeah.
Bhagavatam also is there.
Yeah.
All sessions are over.
Yeah. Bhattacharylu, yes, my session finished by 4:40.
I think then everything is over, I believe.
Yeah. Sir, I think it can be started.
Shall we start, sir?
Yeah, I think so.
Yes, sir. Very good evening to all the dignitaries and one and all. It is my great privilege to invite all the dignitaries onto the dais. First, I would like to invite Professor N. Balakrishna sir, Senior Professor, ISPS President, Department of Statistics, Cochin University of Science and Technology, Cochin, Kerala. Sir, please occupy the chair. Next, I would like to invite Professor S.C. Malik sir, ISPS General Secretary, Department of Statistics, Maharshi Dayanand University, Rohtak, Haryana. Sir, please occupy the chairs. Next, I would like to invite Professor P. Rajshekar Reddy sir, Honorary President, ISPS, Sri Venkateshwara University, Tirupati, AP. Now, I would like to invite Professor G. Jayashree, Madam, Department of Statistics, Usmania University Convener, ICSDS 2021, and Vice Principal, UCS. Ma'am, please take over the seat, ma'am. Next, I would like to invite Dr. Nch Bhattacharylu, Head Department of Statistics, OU, Organizing Secretary, ICSDS 2021. Sir, please occupy the chair.
Now I am requesting Professor N. Balakrishna sir. Sir, please preside over the function, sir.
Sir, please unmute. Sir, please unmute.
Please unmute yourself. No, yeah, I repeat. So I see a lot of smile on the faces of Professor Jayasri and Dr. Bhattacharylu. Now, so they have been under stress and tension during the last, I think 3-4 days actually. So now there seems to be a lot of relief on them. Good. So I think my hearty congratulations to both of you and also your colleagues in the Department of Statistics, Usmania University, for your wonderful work, nicely coordinated and well prepared and well planned. And I think I just want to also mention that the technical group you have hired, they are wonderful. They have done very nice. I don't know whether anybody is there now listening to us. They have done wonderful job. There is no hitch anywhere. Everything was very well planned. Good. I think I should congratulate you for choosing such a very nice, organized people. Good. And also take this opportunity to thank the Usmania University for giving all the or sparing all the facilities to conduct this program nicely. And also I think I thank all the executive committee members and associate executive committee members for their cooperation throughout the program. And especially today's this award function. I take this opportunity to thank Professor Rajshekhar Reddy, Dr. Neha Garg, and Dr. Venkateshan and other people who have coordinated the program very well in preparing the citations and certificates and all those things. Everything went on very well, just like camera finish kind of things. So I'm really happy that I'm heading an organization where a lot of committed people are there who are always with us for all sorts of help and cooperation. Thank you very much. And I think I invite some of the delegates to share their experience who have attended the proceedings during the last 3 days. Some tips or some comments about the program coordination, which will help the organizers as well as the ISPS in the future coming conferences.
Yeah, shall I say something? I'm Somesh Kumar here.
Yeah, sure.
Yeah, I would like to congratulate ISPS, the entire ISPS organizing body, for really handling it well. And the first thing is that starting from the initial brochure and the announcement of the conference, people are always in touch with us so that we submit the papers and our abstracts and everything very timely. And then the planning of or the scheduling of the talks is also excellent, including the endowment lectures and plenary lectures and all. And second thing I would say that the Department of Statistics of the Usmania University, they were really punctual. Like I received phone calls. They have put some volunteers there. Before every session, actually, they are calling and informing that your talk is there. So that, there is no technical difficulty or person is absent due to some reason. So I think this really calls for a big thank you to all and big, you can say, shout out to all of them for this excellent effort actually. And over the years, the Indian Society for Probability and Statistics has actually become the biggest organization of statisticians in India. And for that also, I must thank the senior functionaries like Professor Rajshekhar Reddy. In fact, he has taken the role of a guardian of this society. So that he is actually able to attract the people from all parts of the country. I have seen the participants; they are from all over India. So no institution is left out. Like we have, like IIT Kharagpur, Indian Statistical Institute, which are already there, but they are covering even colleges and various universities in North India, in western part of the country, and all other parts also. So slowly it has grown big, and I must appreciate the efforts of all the organizers. I'm just, my prediction is that in the next 5 years, this will cover even much bigger. I mean, that your membership numbers may become a double of this, and maybe some sort of publicity in the sense of sending the brochures and all, so that the young researchers, and in fact the people who actually participate, each of them, they can request, or they can inspire their own students or other people to become life members of ISPS. I think that will give a big boost to the visibility. Now I'm going to ask all my students to actually, my former students and the present students, to become members. And likewise, I would request all the dignitaries and other people to say that, do the same thing. I think the base will increase much, and it will be really a good thing for statistics in India. Thank you.
So that's where, hello, that's where we are planning a pre-convention workshop for life members. Pre-convention workshop for life members. So when it means life members, so before the conference there will be a convention. So that's why it attracts many scholars to become life members. Okay. So much.
Speak, sir.
Anybody else would like to?
Yes, sir.
Briefly,
I am Professor Ilangovan from Annamalai University, sir. First of all, I thank all organizing committee members, especially Professor Jayashree, other members of the Osmania University, for conducting this ISPS 2021. So I want to place on record, the link for each session is given well in advance, and also the presentation session for the contributing speakers is accommodate all the speakers, and I really thankful to the effort made by the organizing committee members. And another thing is, the first ISPS president, Professor Sankar Narayan, basically from Annamalai, the department is jointly with the mathematics statistics. Now it is separated now. So on behalf of the former president also, we are all the scholars in our department and other staff also listening all the important session. So in my conclusion, I thank all the organizing committee members, especially Professor Balakrishna, Professor Digaru, and also the convener of the conference, Professor Jayashree, for giving an opportunity to thank, sir. Thank you, sir. Thank you, one and all.
Prakash Rao here.
Okay, sir.
First of all, I would like to again congratulate the Society, Indian Society of Probability and Statistics, for an excellent job. This is within a span of 6 months, they did it twice. So this is remarkable, and I congratulate them. And the wide coverage of subjects that are there, that itself is a miracle here. But I think, in fact, I feel that pandemic has helped us in some way, because several people could participate in this through the webinars. Whereas if you say you need funds for travel and so on, not many could have participated.
Right.
In that way, this is a blessing in disguise. So, and of course, it's always nice to come to a convention and a conference, meet other people in person, get to know and talk to them. That's very important. But in the present circumstances, we couldn't do it. But then it still was helpful. And I have seen, in fact, I have been very busy with so many webinars sitting at home. And so this is what is happening. And of course, the society, in fact, I don't know, several of you, I have met Professor Sankar Narayan in 1976. I went to a conference which he conducted. And at that time, he didn't start this society, but then he had the ideas. And I was traveling with him for some time over the years. And I did attend, he had a sort of workshop in Annamalai for about 3 weeks on stochastic process and inference. So I went there, and I remember his hospitality, typical South Indian style. And then over the years, the society has grown so much. At Delhi, probably, and in those days, we didn't have many people, but now it has grown from strength to strength, thanks to the efforts of all the people in the committee, and Professor Rajasekhar Reddy, Professor Balakrishna, Professor Malik, and all the colleagues here and there. And I'm happy. And of course, I'm especially happy to be in part of this society because you have honored me with this award. And that itself is my association with you establishes our interest in these things. And I again congratulate the colleagues the colleagues at Osmania University, Professor Jayasri and Professor Bhattacharylu of Osmania University, and all the colleagues at ISPS for an excellent program that has been arranged and conducted. Thank you.
Professor Rashekar Reddy, you have to say a few things about the conference proceedings.
Okay. I am very happy to say a few words on this valedictory function occasion. Actually, earlier we used to organize only 3 days conference earlier. Last time, when Professor Jamlamadka Srinivas Rao has arranged, asked her to do it 1 day workshop for the scholars in Bhubaneswar. From that date, we have decided that every time before conference, we'll have pre-convention workshop, which we have done it. And this award ceremony also, because of the many awards, I thought of taking much time at the time of the inaugural function, so that we thought of doing separately this one. That also happened, these two. And now the organizers, every day I used to talk with Jayasri in the evening or even night, 11 o'clock. Also she used to make calls and discussing with me. Somebody is not there, so that, okay, I will do it like chairing the session or this dropping session like that. So, and Bhattacharylu is also in touch with me. And well in advance, we have fixed this workshop audio resource persons, so that all the 9 speakers which they have delivered on first day, and the remaining sessions are also now really went on well. So I am really appreciating Jayasri and Bhattacharylu and their team. Hope like BLS Prakash Rao Garu has mentioned that within 6 months we have done September and March, this one 2 conferences, that is 40th and 41st. Sir, apart from that also, last time while organizing that Shankar Narayan endowment lectures, they have donated 5,22,000 rupees, 3 lectures. And now recently last month we got another donor, M.N. Deshpande Memorial Prize, for which we have received 2.5 lakh. And now we are hoping, confident that because of Professor S.N. Pandit, there may be now people are ready to donate some money in the name of him and instituting a endowment lecture. So the society is now almost 9 endowment lectures are there to strengthen this one and some type of activities. So I am very happy now the life membership has crossed more than 1,650. With this conference, yesterday also I have received some 4 or 5 members. Maybe another 10 days, I am going to get some more members. I am very happy that now slowly our ISPS is spreading throughout all over at India and abroad level also. So I am once again, I am grateful to all the speakers, plenary speakers and executive members, associate executive members for their full cooperation in organizing this event in a befitting manner. So I also congratulate Bhattacharylu and Jayasri and their team for the successful organization. So thank you. Thank you.
Okay. I just have one small comment to make, sir. Can I
Sure,
speak?
sir. Please go ahead. Yeah.
Thank you for granting me an opportunity, sir. First, the organizers have done a fantastic job. I compliment the society organizers, including your good self. Then, of course, from the Osmania University, Professor Jayasri Madam, Professor Bhattacharylu Garu, they have been, a phenomenal, inspiration for everybody here. Professor Hargopal and so many others are also there who actually were instrumental in bringing a lot of people from the SSN and Pandit's students team. But coming to the point, what I thought I would share with you people is, you are now having the required quorum and you are going great guns. In IEEE, what we do is we have a PhD for scholars forum where, you know, before they come to the conference, they have an opportunity to meet once or twice, get it reviewed, and then actually come to the conference better prepared. So such kind of discussions, if they are facilitated, they will be great, sir. Thank you so much, sir, for granting me an opportunity.
Okay, thank you. Thank you for your suggestion. Yes, Srinivas Rao Garu. Okay, if not, I think invite Professor Malik to say a few remarks.
Yes, now very good evening to all of you, and it is a time to say a few words about the organizers. Really, I am very much impressed with the organizers, particularly Professor Bhattacharylu, Professor Jayashree. They did very hard work to make each and every event successful. And we did not face any problem technically and manually. Whenever we asked them to arrange any session or any program, they were always ready to manage all these things well in manner. And they did it. Really, I appreciate their efforts from very beginning of this conference. And they are trying to make this event successful since last many months, maybe because of some problems due to COVID-19. Now I can say that really they deserve for the congratulation. So I congratulate the organizers for sparing your valuable time. I congratulate the university for giving an opportunity to conduct this event, this international event with the Joint Convention of ISPS. So on the other hand, I also thank all the committee members of ISPS, live members of ISPS for contributing in one way or the other. And the credit goes to our leader, Dr. Professor Balakrishna. Professor Bala,
thank you.
Really, you deserve for this. And we, under your noble leadership, we are always ready to work hard as and when you do so. The credit also goes to Professor Reddy, who was untiring. He was always ready to spare time without any hesitation and without any burden or without any. He is always ready to spare time, really. So we salute you, Professor Reddy. We salute you. And what I observed, there is no doubt that we are conducting this conference at Osmania University, Hyderabad, after a 5 or 6 month gap. And the conference was the prior conference was also conducted through the online mode, which was also a remarkable conference. But this time, this conference somehow cannot be considered as less as the previous one. So really, I did not face any type of problems on the part of the organizers. So many speakers, eminent speakers, presented their contribution in terms of good research work, good findings. And I think about 200 research papers have been presented during these 3 days. And it was not very easy to accommodate all these to about 200 research papers, to invite all such speakers. And every time the problem was not in a position to say a few words against the organizers. Really, they did very well work, and I appreciate the steps. I congratulate the organizers, and I hope that the time will come when they will be ready to conduct this conference physically, I hope. And at that time, we will enjoy their food, their hospitality physically. And I invite the organizers, the ISPS members to come Rohtak, Haryana, MD University Rohtak. They are always welcome with us. They are always welcome. And I'm ready to spare my time in the interest of the ISPS. Whenever you feel like so, then you are free to contact me at any time. So thank you all of you, and congratulations, best wishes to the entire ISPS community, and congratulations to the organizers. Thank you, please. Thank you.
Thank you. Thank you. Anybody else? Satish or Professor Srinivas Rao? Before leaving the dais to Professor Jayashree and Dr. Bhattacharylu.
Say two words, Balakrishna.
Yeah, sure. Yeah, yes, please.
Yeah. At the onset, I congratulate the President of ISPS, Honorary President Professor Rajshekar Reddy and other executive members, as well as the organizing committee, Professor Nch Bhattacharylu and their team, for conducting a very nice and successful, it is a grand successful conference. And we are very happy to be a part of it. And even in spite of it is online, there was no single flaw we can point out, because every program is in time and all speakers have delivered their goods exactly in time and also done in an excellent manner. So really we are very happy to have this and participate in this conference.
There is some signal problem, I think.
Also, I should congratulate the present executive, the inaugural,
okay.
And also making a separate session. It is a highly appreciable thing. And not only that, all efforts that was taken in that, and I advise the organizers of this conference, particularly Jayashree and Bhattacharylu, to bring a proceedings of this. And ISPS, particularly the good papers, after reviewing, our journal may take off printing some of the good papers in that, particularly the Journal of ISPS. I am very happy that the conference went on very well. And I once again congratulate all the team members of ISPS as well as the organizing committee for conducting this conference. Thank you. Thanks for the given opportunity.
Thank you. Maybe the one final response from somebody, and then we will invite the organizers. Anybody else? Satish? Yeah, please.
In fact, last 3 days, we are on the virtual mode. Even though in the virtual mode, we have been given a feast from the side of the Osmania University. And in fact, the Professor Bhattacharylu and Professor Jayashree did a very wonderful work during these days, and they are very sincere towards the each and every activities of this conference while organizing the conference. They contacted several times, and even in the night and the other time also they are preparing and rescheduling, structuring the very beautiful work. So on behalf of the ISPS and all assembled here in this group, let us give a big clap to both these two personalities for the successful conduct of this conference.
Okay.
And I'm very much proud to say that our ISPS is now in the developing stage with a geometrical growth with the Trimurtis like Professor Reddy, Professor Balakrishna, and Professor Malik, and with the support of all EC and associate EC members, I'm sure, and with all blessings from the great people like our Prakash Rao and others. We are very much happy and very much glad to be in this moment after the conduct of our professors are waiting to get relief out of these hard works during these days. I know the efforts while conducting a conference. With all best wishes and great success to our organization, our association. Let me to once again thanking you all. Thank you, professors, We expect your blessings and support in future also for the ISPS. Thank you all. Thank you.
I think now I invite Professor Jayashree, leaving Professor Bhattacharylu to conclude. So, Madam, please, now it is your turn. I think you have to unmute.
Thank you, sir. Can you hear me, sir?
Yeah. Now you are audible.
Thank you, sir. A good evening to one and all, the dignitaries on the dais, respected Professor Balakrishna, sir, Professor Malik, sir, Professor Rajshekhar Reddy, sir, Dr. Nch Bhattacharylu, sir, and I would like to just give a small report on the conference, sir. On the conference, some of the outcomes of this international conference on statistics and data science, theory and practice for progress and prosperity are 3 plenary talks were delivered on the theme of the conference by Professor BLS Prakash Rao, sir, Emeritus Professor, C.R. Rao Institute of AIM, SCS, and former Director of Indian Statistical Institute, Calcutta, recipient of Shanti Swarup Bhatnagar Award in Science and Technology, and C.R. Rao Lifetime Achievement Award. Professor Arup Bose, Indian Statistical Institute, Calcutta, and recipient of Shanti Swarup Bhatnagar Award in Science and Technology and Fellow of ISPS. Professor A.M. Mathai, Pala, Kerala, University, Kerala, recipient of Founders Award from the Statistical Society of Canada. We are very thankful to you, sir, for delivering these lectures. And on the theme of the conference, talks were delivered by Professor P.G. Sankaran under Professor P.V. Sukhatme Endowment Lecture, Professor K. Srinivasa Rao under Professor R. Ravanan Endowment Lecture, Professor Debasis Kundu under Professor A.M. Mathai Endowment Lecture, Professor Isha Diwan under Professor Y.C. Narsimulu Endowment Lecture, Professor Somesh Kumar under Professor D.D. Hanagal Endowment Lecture, Professor C. Raghavendra Rao under MP Sastry Endowment Lecture, and a series of 3 lectures were given by Professor G. Arivarignan sir, Professor S. Udayabhaskaran, and Professor Tangarajan under Professor G. Sankaranarayanan Symposium lectures. Professor M. Vishnuvardhan Rao, Professor V.V. Haragopal, Professor Subramanyam, and Mr. Kaundinya Vajha delivered their talks under Professor S.N. Narahari Pandit Memorial Lectures. 34 sessional invited talks on the theme of the conference were delivered by distinguished senior professors and professors. Out of 201 papers received, research papers received, 122 contributory papers were presented in the conference. The sessions were chaired by 65 distinguished senior professors and professors. I am thankful to all the senior professors and professors for readily accepting our invitation and taking time to conduct these sessions out of their busy schedule. And thank you for delivering the lectures whenever we approached them for delivering an invited talk. I take this opportunity to thank Professor N. Balakrishna, Professor S.C. Malik, Professor P. Rajashekhar Reddy sir, Professor Satish Kumar, Dr. Venkateshwaran for their suggestions and kind cooperation. Whenever I called, they were always ready to help me and always ready with the suggestions. And I'm very, very thankful to all of you, sir. Without your suggestions, it couldn't be successful. And thank you very much for all that, sir. And I thank our organizing secretary, Dr. Nch Bhattacharylu, sir, for his work since 3 to 4 months. And without his cooperation, his suggestions, I couldn't have done it. Thank you all. Thank you very much, all of you who have made it a big success. Thank you.
Okay. Thank you, Professor Bhattacharylu. You may take over now. Maybe you may close with your out of thanks also.
Yes, sir. Good evening to all.
You could keep your camera on. Yeah, you are visible.
Respected Professor N. Balakrishna Garu, President ISPS, and Professor S. C. Malik Garu, General Secretary, and Honorary President Professor Rajsekhar Reddy Garu, and Professor G. Jayasri, convener of this conference, and respected senior professors, research scholars, scientists, and students. Good afternoon to all. It is my privilege to say the vote of thanks to all the members who are involved either directly or indirectly for making this conference as grand success. It is a great pleasure for us hosting of the 41st annual conference of Indian Society for Probability and Statistics in Osmania University. We are treating that it is honor for us. We are grateful to Professor Rajsekhar Reddy Garu for giving a chance to us to host this conference in the Osmania University by keeping confidence on us by considering our request. Thank you very much, sir. And on the behalf of the Department of Statistics, Osmania University, first and foremost, we are grateful to Professor N. Balakrishna, President ISPS, and Professor S. C. Malik, General Secretary ISPS, and Professor P. Rajsekhar Reddy, Honorary President ISPS, for their unconditional support and in suggesting the speakers, chairs, and for various talks and sessions. And also, I'm very much thankful to Professor Satish Kumar for unconditional support. I'm sorry, sir, we are disturbing many times, even the nights, for identity. So we are disturbing and conducting the meeting and taking the suggestions and scheduling. And because it is a very big schedule, so that what had taken the previous from the Professor Satish Kumar and Professor N. Balakrishna Garu, they are related to the same. We are grateful to the speakers, Professor Ashish Chakravarti, Professor Anup Chaturvedi, Professor Somesh Kumar, Professor Ravi Surdi, Professor M. Krishna Reddy Garu, and Professor Kodur Srinivas, Dr. R. Vishnuvardhan, for accepting our invitation and delivering the inspirational talk in the virtual workshop on the innovations on data and statistical sciences. So thank you very much for the delivering the talks, for your kind acceptance. And also we are thankful to Professor Rajsekhar Reddy Garu for guiding and taking consent for the speakers for the workshop. So thank you very much, sir. Without your cooperation, we cannot continue and we cannot find out the distinguished professors. We are grateful to the speakers, Professor BLS Prakash Rao Garu, Professor Arup Bush, and Professor A.M. Mattai for accepting our request and delivering the thought-provoking and inspirational plenary talks. So thank you very much, sir. And we are also grateful to all the delivered lectures, Professor Anup Chaturvedi, Professor Somesh Kumar, and Professor Krishna Reddy Garu. And we are also thankful to Professor K. Srinivas Rao Garu, Professor Devashish Kundu, Professor Isha Diwan, Professor Somesh Kumar, Professor Raghavendra Rao, Professor Arvir Vignan, Professor Uday Sankaran Tangarajan, and Professor Vishnuvardhan, and Professor Haragopal, and Dr. Kaundinya and Dr. Y.V. Subramanian for endowment and the symposium talks. Thank you very much and so I'm very much thankful to all the speakers for coming and joining in time and as per the schedule, and out of the total, the schedule of the 34, the sessional talks and the 13, the endowment and the other talks, and 3 plenary talks. Only one we missed it, and all the other sessions are conducted as per the schedule that what we have prepared it. So thank you for each and every speaker who have spent more time and also cooperating. Without your cooperation and without your support, it is very difficult for us to make it success. And Professor S.C. Malik, Professor N. Balakrishna, Professor P.R. Vittal, Professor D.S. Uda, Professor K.K. Joshi, Professor T. Ramanathan, Professor Sudesh Kattumani, Professor C. Satish Kumar, Professor Loganathan Sir, Professor Elangovan, Professor Sandamarai Kannan, Professor Tirupati Rao, Dr. Latpate, Dr. Nehagar, Dr. R. Vishnuvardhan, Professor Abdul Sattar, Dr. Manoj Chako, Dr. Isha Patik Das, Dr. B.G. Manjunath, Dr. V. Kaviyarsu, Dr. P.K. Swain, Dr. Bindu Krishnan, Dr. Ananya Lahari, Dr. B.N. Mandal, and Dr. Ramakrishnan, and if any other that we miss, please excuse, and we are very much thankful to each and every speaker. And we are also thankful to all the professors chaired the sessions of the invited talks and contributory talks. So around 65 the chairing sessions, which are with a short span of time, within minutes, they are readily occupied the chair and conducted without any disturbances. And we are also thankful to all my colleagues of the department, Dr. S.A. Jyotirani, Dr. G. Sirisha, Dr. M. Raghavendra Sharma, and Dr. Mr. J.L. Padmasri. And also, I'm thankful to the my post-graduation students and who are continuously monitoring the 4 sessions by allotted to them, and the Himaja, Harshita, Haripriya, and Manasa. And also thankful to the total coordination taken by my research scholars, Dr. C.H. Anusha, Ranjita, and Swarnalata, and who are directly involved or not directly involved in the workshop and conference. For all them, that I'm very much thankful to all the members who have cooperated. And also we are thankful to Madan Murthy, Basiruddin, Kiran, Lakshmi Prabha, and their team from Video Technologies for developing the virtual platform for the delegates or speakers without any interruption in telecasting, and also telecasting through YouTube simultaneously. And we are, as for even today, so more than the 250 plus they are viewing the YouTube on live. And we are apologizing for any inconvenience made, either unwantedly, whatever that is happened. Please don't mind, and we are apologizing. And the speakers or chairs or contributory speakers for the inconvenience, whatever it is made. Thank you to one and all.
Okay. So thank you all for staying till the late evening. And I wish that we will join for the physical conference during the 42nd annual convention to be held at Cochin in January first week of 2023.
Yes, we will be there. Best wishes in advance.
Okay, thank you. Thank you. See you all again. Bye.
Okay, bye.
We will be meeting. Hopefully, we will be sitting there physically.
Yeah, yeah.
Okay.
We
Okay, sir.
hope.
Okay.
We hope.
Thank you, sir. Thank you very much.
Thank you,
everybody. Goodbye, everybody, and happy.
Okay, sir. Bye. Bye. See you again.
Very memorable event, sir. Thank you very much.
Thank you.
Particular thanks are also due to Rajashekar Reddy Garu for taking all the pains.
Thank you,
Namaskar,
sir.
sir.
Thank you.
Prakash Rao Garu. We are really grateful that you have been a great mentor here for us.
Yes, sir.
I'm thankful to the donors, Sai Sudhir Degree and PG College for major conducting of this conference, and also Jahanavi Degree and group of institutions. Thank you, sir.
Thank you.
Let us have a big party at our own respective places.
Okay.
In fact, we missed the physical presence at the Usmania University.
Yeah,
So
yeah.
it was a great missing because this Professor Bhattacharylu and the team, Professor
Satish Kumar.
Satish Kumar sir and Rajashekar Reddy sir,
Yeah.
and S.C. Malik sir, you have helped in great in arranging the
Programs, right? Yeah, programs. Program scheduling committee.
It may not be success.
Webmaster also must be thanked, sir. Webmaster must be thanked.
We shall try our best to visit your university.
Satish, Satish, you may
Yes, sir.
free in September. May not plan any programs in September because
Yes,
who are
I
coming to
think
Tirupati.
Professor Satish and Professor Reddy are competing for conferences
So that's why well in advance I am putting a request not to organize that time.
to avoid any collision.
Okay.
Surely, Professor,
Bye.
surely.
Okay, sir. Let us take rest for some time.
Come
Yeah,
on.
yeah. Now I am
Bye
sitting with.
bye.
The session will be ended with Janaganamana sir.
Thank you, madam. Thank you.
Yeah, if you
Oh,
wish.
Neha came.
Yeah.
Okay.
Thank you.
There is a Janaganamana.
Okay.
National anthem.
All right.
Yes.
No, no.
That's fine.
जनगणमन अधिनायक जय हे भारत भाग्य विधाता पंजाब सिंध गुजरात मराठा द्राविड़ उत्कल वंगा विंध्य हिमाचल यमुना गंगा उज्जल जलधि तरंगा तव शुभ नामे जागे तव शुभ आशीष मांगे गाहे तव जय गाथा जन गण मंगलदायक जय हे भारत भाग्य विधाता जय हे जय हे जय हे जय 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 हे
மேல இருக்கு 4 PhD 40 மார்க் சாலிடா அந்த தேர்ட் காலம் வந்துரும் 100 மார்க் கண்டிப்பா.
Yeah, I mean, this was not planned actually. It's good.
Good. Ending is good. Very good. So closing also very good.
Yeah, yeah.